started is I need you to create an account with Clarifai and then log in. And once you create your account and log in, you're going to have something that looks like this. Now, this is going to be your dashboard. And within this dashboard, you can create an app, which we're going to do later on in the videos. But I do want to show you some nice things that we have here. One is that we have the documentation. Again, when using any API, you need to learn how to use it, right? So all APIs usually have a documentation website where you can learn about the API and how to use it. In our case, what we want to use is right here, the API guide, and specifically, we want to make predictions. You can read through all of this yourself if you want, but I'm saving you a lot of time by just telling you where to go. So if you go to the API guide, making predictions, we're going to work with images. But you can see we can do videos, text, audio, lots of things. So for us, we're interested in making image predictions. And this Clarifai API is going to allow us to make a request to the API. We've learned about the REST API and making requests. And you can see that we have JavaScript here, but also different languages as well as Node.js, which we're going to use later in the course. Now, when making predictions, we have two ways of doing things, using bytes or URLs. In our case, we're interested in doing URL predictions. Now, the way the Clarifai API works is that we have models. And these are models trained by this company to understand what images are, what are inside of those images. And Clarifai has a ton of models that we're going to use and play with. If you go to the model gallery, and don't worry, I'm going to link to all of these pages after this lecture so you can just open them up yourself. You can explore a ton of models that they have. You can search for models. You want something that detects logos? Yeah, you can do that as well. In our case, we're going to use the face detection model. So if I search for it, you see that we have a couple of models. We're going to use this one, the face detection model. It's going to be really cool and we can do something, well, like this. Now, to get started, in the next lecture, I'm going to provide for you all the links that you should have opened throughout this section, including the API documentation, the model over here, and have all these tabs open as you work along with me on this project. So go create a free account, sign up, go to your dashboard, and then I'll see you in the next lecture. Bye-bye. Hey everybody, I wanted to make a quick video of 4 key things that I want to warn you about before we dive into what I think is the hardest part of this course. And well, the first point is this, that this is going to be hard and you need to watch all the videos and pay attention. You see, the next couple of videos are going to be pretty tough. And I mean, we're developers, right? This is what our jobs are. We're doing the things that a lot of people find difficult, and we find solutions to problems. So if you find yourself getting stuck on this final project, that's a good thing. We don't want everything to go smoothly. We want to make sure that we encounter roadblocks. We encounter issues with our code and we debug. We get to solve those problems and we get to the final stages of the project. Because once again, in real life, on the job, you're not going to have somebody hold your hand and show you how to fix your problems. You want to develop the muscle of problem solving. So I've made this pretty hard in this section, but along the way, I'll help you make sure you get there. So although you may feel like this part, these next couple of videos are hard, that's just your brain stretching your boundaries, allowing you to really learn problem-solving skills. So watch all the videos, follow along, and I promise I'll get you there. Number 2, the project works. This is a common thing with developers, and I used to do it all the time too. Sometimes when your project doesn't work, you think, I'm doing everything right. I copied everything that Andre told me to copy, but something isn't right. I'm getting errors. I think the project's broken, or I think the Clarify API is broken. And this is usually wrong. Usually there's a typo, usually there's something that you missed. I actually have a weekly check that I do, an automatic check that I do on this project to make sure everything works. So if you encounter issues, it's most likely something inside your code. And that is your time to debug, to figure out what goes wrong. Again, I do weekly checks on this project to make sure that it's always working. Number 3 is to follow my method. Okay, this part, you just have to trust me. I'm going to teach you how to use the Clarify API in a pretty convoluted way. I'm going to show you 3 ways that you can use the API. And the reason I do this so that you're able to see how the Clarify API has evolved over time, and also allow you to understand when using other APIs, how to solve your own problems. So although I show you multiple ways of doing things, just trust in the method. I've combined some old videos with new videos to show you how things have evolved and how to solve a problem that you may encounter with older versions of code. For example, you might see in the next couple of videos an older version of the Clarify API. And that's there on purpose. It's there to show you the differences of how it was before and how it has evolved over time. Remember, the snapshot model of learning. Finally, we're going to talk about this thing gRPC at the very end of the course, when we deploy our app to production and then do a security analysis and update our app. So although you might hear about me talk about gRPC, don't worry, we're going to cover that later on in the course. The key thing to remember is that within Clarify, there's multiple ways that you can talk to the API. If we go to the Clarify basics, we see that they have something called API clients. And these are clients that we can use to communicate with Clarify. You see that there's one for Python, for Node, for PHP, for all types. And if you click on the Node.js one, which we're going to do later in the course, you see that it's the Clarify Node.js gRPC. Again, we're going to use this at the very end of the course and show you how it works and why Clarify has updated their code to use gRPC. They even have documentation here which explains their reasoning. But we don't need to worry about that now. What you'll see is that they have some deprecated. That means no longer maintained. They still work, but no longer maintained way of doing or working with the Clarify API using JavaScript. Now, we're going to use this at the beginning because it's a great way for us to use what we've learned using RESTful APIs. And RESTful APIs are more common in the industry. And you're going to see more APIs using this method than gRPC. So I want you to focus on this, and then I'm going to show you how it evolves over time. Again, if this is confusing to you, don't worry. We're going to get there. But I do want to warn you, that frustration you're going to feel over the next couple of videos, that's normal. That's part of the process. Just trust me, and we'll get you there. I'll see you in the next one. Bye-bye. All right. That was a lot of talking, and you want to get back to the project, right? Well, I have one more video for you. I know I'm taking a long time to get to us actually coding, but this is probably one of the most important videos that you might have to come back and revisit every once in a while, or as you create the project. Now, in this video, I don't want you to code along. I want to show you how the project looks at the end of this section, because I want to show you how you might have to debug in the next video so that you don't get stuck. So by starting with the end product, I'm going to show you how to debug. And then when you watch the next video, if you encounter any issues, you already know the answers to them. So again, don't code along to this video, but watch and understand what I'm about to show you. Now, first things first. This is the project I'm going to link to at the end of this section. The face recognition brain is going to be turned into SmartBrain project by the end of this course, and we're going to have different versions of it. So we have the SmartBrain version 1, we're going to build a SmartBrain API, then we're going to create the final version that we're going to deploy to production, SmartBrain API and the SmartBrain client app. But for this section, we're just building the initial blocks. So this is what I'm going to link to at the end of this section. So let me show you how everything looks. I've cloned this repo. I've run npm install and then npm start, and I have the app running right here on this tab. Ooh, look at that, fancy. Now we haven't built the sign-in component yet. We haven't done a bunch of things yet. But if we go to the app, you'll see here that I have app.js open, and we've built a few things here, but we haven't coded everything that you see here. Now I've minimized this just to keep things clean, but I want to show you the process of using this repo. So the first thing, when we go here, you see that I need to grab the API key from Clarify. So I'm going to do that. We go to our dashboard. Now you should have created an account already on Clarify. You're going to click on create an app, and you're going to create an app for yourself. So let's just call this test, description test. You can do, obviously, you can name it whatever you want. I'm just going to call it test. You can leave the base workflow as general and then click confirm. And it's all created. If I refresh the page, hey, look at that. There's my app. So if I click over here, I go to app settings, and there is my API key over there. So all I need to do is just copy this API key. So when I go to my project, and we're going to do this in the next video, you're going to put in your API key, your own API key in here. You can't use mine because you have to have your own API key. So if I add this here, I've ran npm install, I've ran npm start, I've created the API key, and I've added it on here. Now the next part is, if we go back to the app, I still have this sign-in component, which we haven't built yet, but just to show you, when we open up the app, we're going to create a route in here that we'll do later on in this section. So for now, I'm just going to change this to home, just so we don't need to sign in and we have the home page available. Very cool. Now, some of this is still missing, again, because we haven't finished the app, but I do have a picture of our friend Tom Hanks. So let's paste that in to see if this app works. And this is what we're building. If I hit detect, all right, I get Tom Hanks, but I have an error. And when you get an error like this, usually you click it, and then you're going to go, let's see over here, let's see what the error was. You see the red over here, 404. If you click, it'll tell you the status. If you go to responses, model does not exist. Why is that? Well, this is something that you're going to encounter in the next video. When you go to app.js, Clarify has actually updated the way that you can call on to their API. So if you encounter this error, if you go to on button submit, again, we're going to code this, so don't worry about it. But I'm going to do the app.models.predict method, which was the old way of using Clarify, with clarify.faceDetectModel. This was the model for detecting faces. This has now changed to using the model ID based on the name that you'll see in your app. So if I go to the docs here, documentation, and I go to making predictions, images, and we go to the models that we want to use. If I click on Clarify Models, and we go to Model Gallery, again, I linked this for you in the last video, so you should already have this. We want to use the face detection model. So in here, we want to use this one, make sure it's by Clarify. Again, you already have the link to this. The model ID is now just this. You just copy this part over here, face detection. So in here, instead of the old way of doing it, we just have to update to this. So let's see if that solves our problem. And grab our friend Tom Hanks. No errors. We do have an error for 4.4 image, but that's because this part is our own endpoint that we're going to create later in the course to our own API. So it's just giving us an error here, but not giving us an error for the app model. And you can see here, I've console logged the response. And you'll see here that, ooh, look at that. I have outputs. If I go to outputs, I have data, regions, and these are the regions of Tom Hanks' face. How cool is that? So this is just a quick note to show you how I read the errors and then how I update it to what you'll see in an upcoming video. So just make sure you do that update because the Clarify API has changed. All right, so now we know that if we encounter that issue, we just need to update the face detection model. We have a few more things to get through. I'll see you in the next one. Bye-bye. All right. I lied. There's one more video, but I didn't want to make the last one too long, so give me a break. I promise in the next video we get to coding. We learned that we have the models that we can use with Clarify. We learned that we can use the face detection model like this to make predictions. But the other thing you're going to encounter in the next video is that I use an old version of the Clarify API. Now, if we go to our dashboard where we created our app, and let's go to My Apps, and this is the app that we're using, the test app. If I go to the documentation, which is the process you would use if you were doing this on your own as a developer, and you go to Make Predictions Images, you'll see that we want to predict via URL, and we want to use the JavaScript REST API. We don't want to use Python. We don't want to do Node.js yet because we're going to do that later on. We don't know Java, PHP. Instead, we want to use JavaScript. But if you look over here, this looks completely different from, well, what you're going to see in the next video. And that is because Clarify has updated their documentation. Again, APIs change all the time. And because Clarify has been a successful company, they are making things better and better. So part of your job as a developer is to stay on top of API changes. Usually as a programmer, things break all the time anytime there's a new update. So when there's a new update, you have to really understand your code and the tools that you're using to be able to make those updates. So I'm going to show you how I would make those updates based on this. Let's say Clarify emailed me and said, hey, we just made changes to the API. So what I'm going to do is go to the documentation, images, and then say, okay, this looks completely different. But luckily, they provide information for us. So I'm going to copy all of this for now, and then work with our existing way of doing things. Again, this is the way I'm going to show you how to do the face detection in the next video because that's how the old Clarify API docs worked. But let's say you're coding along, you got this working, you install a Clarify package that I'm going to show you in the next video. You go to the docs and they're completely different. So what I'm going to do instead is I'm going to copy at the top of app.js right here. I'm going to copy and paste what I just did from the documentation or what I just read on the documentation. So we see over here that Clarify now requires us to create a personal access token. And they have actual comments here that you can read, but I'm going to do this fast for you. So let's remove this for now because we don't need it. First is I need a personal access token. This is actually a new way that Clarify requires us to have a key. So instead of an API key, this is more secure. So what I'm going to do here, I'm going to enter my PAT. And my PAT, my personal access token, can be found if you go to your dashboard, to security. Again, you shouldn't be sharing this with others, but you can create personal access token like so. You can select all scopes and then name it whatever you want and then click confirm. In my case, I've already created it. It's right here. I'm going to copy it and I'm going to paste it over here. Now, as with an API key, this should be secret. Later on in the course, I'm going to show you how to keep this private using things like environment variables that we'll get to. For now, again, I just want to show you the process of what I would do if I want to update the app. So I have the PAT here. What about the user ID? Well, the user ID is actually this over here. So again, if you actually go to your account, your user ID can be found here. So again, I'm going to just add the user ID and then the app ID. The app ID, if I go to my apps, is this over here, the name of the app that you gave. So in my case, test is the app ID. So to identify the app, I'm going to copy the test and then the model ID. This is the same as what we did over here, the face detection model. So again, I'm going to copy the face detection like this, and then the model version ID. So the model version ID, if you go to versions, you can see the model ID over here. But if you actually read further, you'll see that model ID is not required. So if I go all the way down, you see that model version ID is optional. So we don't need to use it. I don't need it. We're just going to default to the latest version of their model. And then the image URL, this is the URL that you're going to provide for the image. So remember, the image URL is some sort of a JPEG image that we provide. In our case, it was Tom Hanks. What I'm going to do just to clean things up a little bit here, I'm going to say const setup clarify and give it an image URL. And now in here, I'm going to just copy this. And instead of the image URL that's static, I'm going to just give it the parameter image URL that is going to be dynamic. Now from here, it says you do not need to change anything below this line to run this example. Okay, so here, let's copy this. We're setting up the JSON that we're going to send to Clarify. So we have the user ID, the app ID, and then the image URL, which we're going to provide. So let's return from this setup Clarify the raw JSON that we want to send. So I'm going to say return raw JSON stringify. Again, I haven't done anything crazy here. I just copied the code from their API. I'm reading through their comments and I'm saying, okay, setup clarify is going to return the JSON. I'm going to name this a little bit better. Let's say return clarify, say request. Might not be the best name, but at least this makes sense to me. Okay, so return clarify JSON is going to return us this. And what does the rest tells us? Oh, we also have some request options that we should include. And it looks like the body raw. Okay, so I'm going to copy this. So now I see that instead of returning this raw, I'm going to convert this to const. So I'm going to return, the request options, method post, headers, accept application JSON, authorize key pat. So pat is, remember, it's kind of like the API key, it's a personal access token. Now it looks like all we're doing is returning the request options. So again, I don't need this variable declared. I can just go like this, return this object. Or if I want to get a little bit more verbose, I can say, hey, just return the request options. So this whole thing returns the clarify JSON request. Let's rename this now to return clarify request options. Okay. So this is going to return for us the method, headers, and the body, which will have the image URL. Now here's the cool part. Now that I've removed all of this, you see that the only thing left from the documentation is this fetch request. And it says that the model version ID is optional. Okay, so I can actually remove the model version ID like so. And this is the fetch we want to do. I'm going to remove the comment here. And now take a look at this. I can go to my on button submit. Again, we haven't coded this, but I just want to show you the thought process here. Remember this part, face detection, predict? Well, they've essentially updated this to have this instead. So we're going to fetch HTTPS API clarify, blah, 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 models, model ID, which remember is just face detection. So we can put here, if we want, face detection. Now the image URL, if you remember, needs to be provided. So this request options is now our function that we wrote. Return clarify request options with the image URL. So I'm going to, in here, return clarify request options with the image URL, which is this.state.input. All right, let's make this a little bit smaller. Yeah, there you go. What you'll see in the next video is I'm going to do this, but according to the clarify API or documentation, I can also do this. So I'm not doing anything different. I'm just using a fetch method to call an API, use the face detection model, and then provided the image like this. So this is the cool part. I can comment this out. This part is from the documentation. If you remember over here, I don't want text, I want JSON. So I'm going to update this to JSON. I don't need to console log the results. We're already doing that here. I don't need to catch the errors because we're going to do that at the bottom over here. So now all I'm doing is exactly what we've had before, except app.models.predict is no longer used. We just use fetch. So let's see if this works. I'm going to save. Usually I never get it right the first time, so let's see. Let me refresh, make sure everything's working. Okay, successfully compiled. Let me grab an image of Tom Hanks. Paste it in. Oh, request options is not defined, app.js.45. So if I go to line 45, I see here is, oh, I forgot to declare it. So const request options, let's try that again. Tom Hanks, let's see how you do. Hey, look at that. Everything still works. Now you don't have to worry about this error because again, we haven't built that out yet, but it all works as intended. How cool is that? So I was able to read the documentation. Now, the cool part about this is that, well, we just did exactly what a client library does. So if I go over here, this clarify package that we install in the next video, we actually don't need it anymore. I can remove this that we're going to code along and not use any NPM packages. We just created the whole thing ourselves. So when you see us download the clarify NPM package, underneath the hood, all it was doing was just that. It was just importing clarify so we can make a nice call without having to do all of this, but we just did it ourselves. So that's kind of cool. We actually lowered the dependencies of our project. And now instead of doing this, we just have a simple fetch. So again, just to prove that we don't need it anymore, if I save, there are no errors. If I, not the apple, if I do Tom Hanks, paste it in, it is working. All right, that was a lot of talking. But again, to recap, what you're going to do is you're going to watch me code along with Clarify from scratch, and you're going to follow along. Along the way, you might encounter some issues, but you've learned how to deal with them, how to read the documentation, and now you know how to debug your own code. So you might have to come back to this video to rewatch some parts, but hopefully this makes you understand a little bit how the API works. Now it's time to dive in, show you how to build this into your app. I'll see you in the next one. Bye-bye. Welcome back. Let's review what we have so far in our app. We've created our app component that contains a few custom React components that we've built. And in the last video, we were able to finally get our response from the Clarify API. If we go back to Clarify, we see that their face detection has a nice little square box that it detects. But if you look at the API and the response that we receive, we actually don't get that square box. All we get are these bounding box. And based on the face and how many faces it detects, it gives you these bounding boxes. And you can read through it over here, but these are just saying the top row is at 22% of the image. So these are percentages that we can use. But in order for us to create our own box like this, well, we need to just see what styles they're using by doing inspect. And as you remember, we can see that they have a bounding box class here. So in our app, we can do something similar, and then we'll just have to calculate based on the response where we can create these boxes because, well, just having the number displayed to our users doesn't mean much. It's nice to have this visual. So let's work on that in this video. If we go back to our app, we first want to say that, well, we're for sure going to add a new state, and we'll call it box. And this box will just be an empty object to start off with. And this box will contain the values that we receive. In the case of our response, it'll be the top row, left column, bottom row, and then right column. So how can we do this? This requires a bit of thinking on our part, but we can start off with creating a function. And this function can say calculate face location. And this calculate face location will receive some data. And for now, we'll just keep it as an empty function. But we know that we want to call this function, calculate face location, based on the inputs that we get from Clarify. So in our case, with the response that they give us, we want to use this response and call calculate face location with the response data. And again, because we're using classes here, we'll have to do this dot. I also think this function looks a little bit messy right now. So I'm going to move a few things around. First off, using ES6, we can just do arrow functions here. That's much better. And instead of using this arrow, we can actually, with a promise, whenever you have a dot then, you can do a dot catch, and that is an error in case something fails. In our case, we can just console.log this error. So this already looks a little bit cleaner, but we need to define, and I forgot a bracket here, and now we also don't need this. Okay, so we know that this is going to get a response, which is the bounding box, but this response will receive what we console logged last time, which is getting the bounding box. For now, we're not going to worry about having multiple faces in the picture. We're just going to grab the first bounding box. Again, if we go back to the Clarify API, we see that depending on the regions, we actually get an array. So if we had multiple people in the image, we'll have multiple faces. In our case, we're just worrying about one, just trying to get one bounding box around a face. So we want to change this response to now say data, and we can just have a constant called clarify face equals this data. I'm going to make this a little bit smaller so we can see. Now within here, what do we want to do first? Well, we're going to want to do some DOM manipulation. So the best thing we can do is say const image equals document dot get element by ID, and we can create an element, or we can create an ID called input image, and this input image that we're grabbing will be here. This image that links to the image URL, so the image that gets displayed in our app. So we can create an ID here, and we'll say image or input image. So now this input image is right here. We grabbed it. And we want to, as you remember, this bounding box is a percentage of the image. So if it's 0.22, that means it's at 20% of whatever the height or width of the image is. In our case, we can say that we for sure want to have the width of our image by saying image.width. And because this is going to be a string and we want to do some calculations on it, we'll wrap it in a number. This way we make sure that it is a number. And then we'll do height as well of the image that we just grabbed. And you know what? We can just console log now to see that we've been doing everything right, width and height. So let's try that. I'm going to save, go back to the image or to the app, grab this sample image, place it in, press detect, and let's look at the console. Get element, oh, I spelled that wrong. Thank God for the console element. I can't spell today. There you go. Let's try that again. Open it up, and we see 500 and 497. All right, we're grabbing the height and the width of the image. That's perfect. And as you know, this is 500 because we set it as 500. Remember, if we go to face recognition, we have width 500 pixels. And the reason that I don't just do 500 here is that, well, if somebody comes along, maybe a designer, and decides to change this, it won't get affected in here. It's always going to be calculating it. All right, so we have the width and the height. We also have the bounding box of clarify, which is right here. So we're going to receive this, and we need to do a bit of calculation. And I'm not going to lie, this took me about an hour, and I decided not to include it in this video because it was just me banging my brains with a little bit of math. So I am cutting to me trying to figure out the math to the solution.
but I'm going to explain exactly how it works. We want to return here an object. And this object is going to be what's going to fill up the box state. Now, this object will first need to figure out the first dot, the second dot, the third dot, and the fourth dot around the face. And then we're going to just wrap it in a border. Again, if we go back to the Clarify API and inspect, we'd see that the bounding box is doing something similar. And we're going to use some of these styles. We'll say that the left column is going to be the Clarify face that we receive right up here. And as you remember, this has a left column property. And now this left column is the percentage of the width. So if we multiply by the width that we have here, well, which is 500, we're going to get the width of the actual displayed image and where the left column should be. So width. And the next one is going to be the top row. And top row is going to have the top row column, or sorry, the top row, not the column. And it's going to have the height. Again, the top row will say that the height of it is the percentage of our image height. Now the right column will be the subtraction of the width from the Clarify face dot right column dot width, or multiplied by the width. So again, because the right column is on this side, we want to get the number, which is the total percentage minus the width starting from the left-hand side. And finally, with the bottom row, we'll do something similar, but instead with height, and it'll be the Clarify face bottom row multiplied by height. All right, whew, that was a lot of math. That's as crazy as we're gonna get with our math. And I'll show you how I came up with these numbers a little bit later on once we have the bounding boxes, and I can show you how you can play around in the console. So now that we have these, we want to fill up the box state with these values. So maybe I can create another function, another method on this class that says display facebox. Not the greatest name for a function, but it's the one that I just came up with. And this is going to receive this return value. And it's going to say this dot set state to equal box. And just a reminder, with ES6, you can actually just do this, but just because this is clearer for now, we'll keep it this way. All right, so we have a few errors here, so let's check them out. Oh, and it's because I did semicolons here. I'm sure some of you were watching this video and saying, why is he putting semicolons in there? I don't like putting on the last one. Much better. All right, so the state is now set with the box. But let's see if so far everything is working. Going back to our on button submit, so when we click the button, we want to calculate face location with the response. This calculate face location is going to run this function. It's going to return an object. And this object is needed by the display facebox method. So it sounds like whatever this returns is this box parameter. So to make things clean, we can just put it right here saying this display face box and wrap this function around. So this calculate face location takes the response, returns this object, and that returned object is now going into display face box. Again, the beauty of JavaScript is that we can use functions like these. And it reads nicely too. Once we get the response, we calculate the inner function, which is calculate face location, and then display face box. God, that's a terrible name, but like I said, for now it's fine. All right, that was a lot. Let's test out our code to make sure that we're on the right track. I'm going to console log here the box object. And if we go back, grab the face again, paste it in here, click and open up the console. We have an object. And all right, we have some numbers. That's good. Let's try and add some CSS so that these numbers appear on the face. It should correspond with the width. But looking at these numbers, it doesn't look too bad. If you remember, the image width is 500 pixels. And if the left column is at 131 pixels, which is probably around here, all right, it doesn't look too bad. Again, let's add some CSS to verify that we're calculating the right things. Now, what we want to do is we definitely want to pass this box state into our face recognition component. So we can just do box is going to have this dot state dot box. And now within face recognition, we now have a new prop that we can use. And this prop can be used by creating a new div. And this div is actually going to be completely empty because we're not displaying anything other than a border around this div. So what I'm going to do actually is I'm going to copy what Clarify has by calling a bounding box class. And we're going to create a new CSS file. Face recognition.css. And just so I don't forget, I'm going to import it right now. And this class, which has the bounding box, will have, well, let's look at what they have over here. I'm just going to copy this actually. Paste it in here. And there's a few things that, as you see, because they're crossed off, they're not actually being used. So we can remove those. You also see that they have the browser prefixes here for now. We're not too worried about using other browsers, so we can delete it. If you want to keep those on there, that's fine too. Now that we have that, let's see what happens. I've added the bounding box around the div. And now, if you look at the div class, you also see that they've added a style, which is what we might want to do with our top, right, bottom, left box properties that we just calculated. So let's do that. I'm going to say style equals, again, we're going to return an object, and this will have top as box. And I don't remember the name, so let's just come back here. Left, top row, left column, top row, right column, bottom row. All right, let's see if I can remember that. Left column, right is going to be box dot. Okay, I definitely can't remember them. Top row, and then it's going to be bottom, which will have right column. Then left, which will have the bottom row. Oh, and I gotta add the box because they're properties of the box object. And you already saw them. I made the mistake over here. You see that left, I have bottom. So let's fix that. We want to have the top row to be the top row here. We want the right column to be right column, and the bottom row to be the bottom row. And then finally, left column. Let's save and see what happens. I'm going to go back to our face. Let's see if I still have, nope, I don't have the link. Let me copy and paste it. Look at that. It's working. Let's just inspect this. And first of all, how cool is that we got this to work and it's wrapped around the face perfectly. But I want to show you how I figured this out. Now, when I first did this, and again, I'm sparing you for an hour of me trying to figure out the math behind this, I initially had something where the box was a little bit off. And all I did was going up and down this way and figuring out where the box should be. And based on that, looking at the math and saying, okay, so that makes sense that the left column should be the left column percentage times the width, because now it's calculating the total width times the percentage of where the left column should be. And then let's say, for example, bottom row. Well, I know that the bottom row should start at the bottom. So the percentage that I get of the bottom row, I multiply by the height, and then I have to subtract it from the total height because the calculation starts from the top, not from the bottom. But you can play around with this, and as you can see, by pressing up and down arrows, you can adjust these. I'm really excited that we got that working in the first go. That looks amazing. Just to test this, let's throw another picture to see if this box moves around with the picture. You know what? Let's do something like Brad Pitt. And I said Brad Pitt instead of Brad Pitt. All right, so a picture of him where he's not looking, he's not dead center. How about this picture? This looks like a good one. Let's select it, go to our app, enter it, detect. Whoa, how cool is that? It's detecting the face. All right, just because this is a lot of fun, I'm going to pick one more. Let's do a hiker. Maybe we'll do a climber. And let's see if it can detect this face. That's going to be pretty tough. That's a pretty big picture. Let's see. Look at that. It detects the face. Even though the face is very tiny, it detects it. This is very, very cool. All right. I want to emphasize here that I made it look very, very easy. And one of the myths that I really want to bust here is that as a developer, just because I'm experienced doesn't mean I can do this quickly. I've definitely practiced this and made sure that I don't waste your time while you watch this video and that I keep the errors. And if I do anything by mistake, I do it intentionally to show you a point. But like I said, it took me a while to figure out how this box works, mainly because I had to do a bit of math and look at how Clarify does it. But the power comes with simply the response that we get from it. By using this response, I can now add anything here. Maybe I wanted to replace this with an emoji, like a smiley face emoji. That's easy to do. It's simply adding a CSS style. And just to make sure that this is responsive, yeah, everything works beautifully. You now have an app that you can show off to your friends. But there's a few other things I want to fix before we get on to working on the backend. And that is, I want to make sure that the sign out feature works and we have a sign in form. So in the next video, we're going to do just that. I'll see you in that one. Bye-bye.
Welcome back. I want to show you something really cool. And this is going to allow you to customize your app. The reason I picked Clarify for our project is because I wanted to make sure that all of your projects, all of the students that go through the ZTM course, all our projects look different. Because who wants a project that looks the same or does the same thing, right? You want your own creativity, your own individual project that you can call your own and impress employers. So I'm going to show you how to customize this app. Again, we still haven't built all the features. There's still lots of options for customization, but you can do something like this. So Clarify has many models, as we discussed. You can go through the model gallery and find different ones. I'm going to show you two other ones that are fun. One is color recognition. So in here, if I go back to our app, I can change the model ID to something other than face detection. Again, you can change it in here or in here, up to you, whichever way you call the API. If I do color recognition and go back to the app, I copy a picture of an apple, not Tom Hanks, apple this time. If I hit detect, the response I get, and again, you don't need to worry about the errors. This is just an error because it's trying to create a bounding box around the face because that's how we built our app, but it's not working because, well, we put a picture of an apple. But if you look at the outputs, check this out. Data. It has colors, and it'll give you colors that it thinks the picture is. It has 65% confidence that this is the color in the picture. Let's take a look at this. What is it? All right, white, mainly because, well, there's white there. Let's find a better picture. Let's use Tom Hanks this time. Let's see what color this picture is. If I go here, outputs, data, colors, 50% confidence that it's this color. Let's see. What color is that? Black. I mean, that kind of makes sense. That's a lot of black in here. You probably could do cooler colors than that. All right, so we can do color detection. This is an even cooler one. There's also the general image recognition. This one is really fancy. If I use this model ID and I save, check this out. I'm going to post the apple in here. Let me clear this. If I go to the data, it's got concepts. And in here, whoa, look at that apple. 99.4% confident that it's an apple, that it's juicy, that's a fruit, that's a food. Wow, that's pretty cool. What about Tom Hanks? What do they think of Tom Hanks? If I paste it in here. All right, what do we think of Tom Hanks? Concepts. Portrait, business, man, people, adult, indoors. Wow, it's pretty cool. As you can see, using Clarify, you can modify what your app does. Super cool, right? All you need to do is just pick the model that you want. And all I did was the response JSON and then console log the response. From there, you can use the response whichever way you want to do whatever you want in the app. Very, very cool. Hopefully this way we can all build apps that do different things. And I look forward to seeing what you come up with. We still have lots to go, but hopefully this gets you excited at the possibilities. More stuff coming. See you in the next one. Bye-bye.
Welcome back. It's time to create a sign-in form and maybe even a registration form because for new users, you want to register them. So let's work on that. We first want to perhaps create a sign-in and a registration component. So let's do that. I'm going to create a new folder, call it sign-in, and this folder will have a new file called signin.js. And again, using our best friend copy and paste, we can use that and call this sign in. And we don't have any CSS for it. And no props yet. Within here, we definitely want to have a sign-in form. And luckily for us, because we're using tachyons, well, if we search tachyons form, they should have, oh, it looks like they have a sign-in form just for us that we can use. All right, this looks awesome. We can just copy and paste this code. And again, because we have tachyons, the classes will be automatically applied. So let's do that. Fix the indentation a bit. Let's save. And you see here that the syntax is wrong. Well, that's because with JSX, we could have gotten away in when we, let me make this smaller. In HTML, we didn't necessarily have to close the input boxes. But here with JSX, we have to make sure that the input tags are closed off. So now in our case, we have 3 inputs, I believe. So we can save that. And there's still something off. Let's see what else we had. And we have one more input in here. All right, you see the highlighting is fixed. Let's just make sure this works by adding the sign-in component to our app.js. And then finally, we can just put it at the top for now to make sure that it works. Let's see what happens. It's compiled successfully. Going back and, all right, we got the form. It doesn't look too bad, but there are definitely a few things off. We don't want this bottom stuff and we need everything centered. Well, one thing I want this to kind of have a card underneath it. So if I go back to tachyons and I do tachyons cards, let's look at product card. All right, I like the look of this product card, but I just like the boundaries of it. I don't need to copy the contents. So I'm going to just copy this article tag and add it in here. Close off the article tag. And let's see how that looks. All right, we got the boundary box at least, but everything's kind of pushed off. Again, we're going to start removing some things that we don't need. We don't need the forgot your password. We don't need the remember me. Let's save. Go back to that. And again, we want to make sure that this is centered. And we actually want to change the classes here to, again, I did Command Control G to have all these multiple cursors, and I'll just say class name. And we actually want to remove this center over here. We already have it up here. All right, things are starting to look a little bit better. I want to make a bit of a shadow around the border. So again, maybe change the border radius to 3. I'm going to change some of these values. I'm going to add my favorite shadow. And I don't think I need this. Let's see how that looks. All right, that's better. Look at that border. That's looking very nice. And maybe we just want this a little bit bigger, and this should say register instead of sign up because, well, we want to ideally have another form for registering. So we'll say register here. And then for sign in, we'll say F1. Save that. Go back. All right. That doesn't look too bad, actually. And if I type things here, everything looks good. Perfect. So we have the sign-in form. This sign-in form, well, we don't want it to show this app is active. Ideally, we have a sign-in form, and once the user signs in, then they're able to access the homepage. So let's do that. It sounds like we need a bit of state. If I go to app.js, and this is a problem that is very common in apps, and there are libraries that you can use, but for us, I want to build this from scratch just so we have a better understanding of how things work. We can create a route state, and the route keeps track of where we are on the page. In our case, we want it to start on sign-in. So when the app initially loads and the constructor gets run, sign-in or route should be sign-in. So now that we have this sign-in, well, it sounds like a conditional statement, right? We can just say that if, and I can't do an if statement here because we're inside of a return statement. But because this is just JSX, we can wrap things in curly brackets. And now it's a JavaScript expression. So we'll wrap this in curly brackets, and we want the navigation there no matter what. If this.state.route equals sign-in, if that's true, then I want you to return the sign-in component. Otherwise, you can return the logo component. And let's just change the spacing here just so it looks a little bit better. Let's save and see if that works. There you go, I've added that. We see that we get an error here saying, well, JSON AJAX elements must be wrapped in an enclosing tag. Remember, because we're returning multiple elements here, that doesn't work. We need to wrap them. Yeah, that error message is a little bit tricky, but you'll get used to it after a while. So we want to wrap this in a div. Let's save. Let's go back. All right, let's look at the console. No errors, but it's still showing sign-in. So let's check to make sure that we did this right. If this.state.route equals sign-in, and as you can see, I've spelled that wrong, and that's why it wasn't working. If I save, there you go. We get our sign-in. And if I change this to something else, well, in that case, we get our home screen. Amazing. Just simple conditionals in JavaScript, and we have ourselves a route. Let's expand on this. Let's do sign in. And now, if the user signs in, well, we want to direct them to the homepage. So let's create a function on sign in. And this prop will have, we'll call it on route change. So when route changes, it's going to be this dot on route change, and let's write that function. We can say on route change using arrow functions. And let's think about this. For now, we can just say this dot set state to home. Doesn't mean much, but it changes the sign-in route to home. So let's get that working. I'm going to save. Oh, I'm going to wrap this in curly brackets because it's an object, yeah. And now if we go into the sign-in component, we can say, for this input, we can just have an onClick event handler. So let me add this on a new space just so you can see it better. Make this bigger a bit. There you go. We'll do an onClick. And onClick, this sign-in will receive the on route change event handler, and we'll just say on route change. We'll save. Let's go back. I'm going to click sign in, and it's working. All right, we also want to click on sign out, and it should take us to the sign in page. So again, we have the route change. But this time, on the click of the sign out, which is the navigation over here, we want it to go to route. So how can we do that? Well, let's go to the navigation component, and we want to say on the p tag that there's going to be an onClick, and the onClick event, which we haven't written yet, but we do have the on route change. So based on that, I can pass that in as a prop. And going back to app.js, we can pass in to navigation on route change, this dot on route change. But there's an issue here, because once I sign in and I click sign out, well, nothing happens. We're never changing the route to sign in. Ideally, when we click, we change the route to sign in, so that this statement over here evaluates to true and we get the sign in form. So it sounds like instead of us just statically entering home to on route change, we need to dynamically say that our route is going to be what we give it. We need to change the on route change in sign in and on route change in navigation. So let's go to sign in first and say that on route change, home. Now, we don't want to actually run this function. The way we have it now is that we're going to run this function when it gets rendered, but that's not what we want. We want it to run whenever onClick happens, and then onClick will call this function. So the way we do that is we can do an arrow function. And this arrow function will just have an on route change home. So it's just a function that's going to get called. Here we're just defining the function. Let's do the same thing in navigation as well. In navigation, on route change, we'll now pass a parameter, but instead of home, it'll say sign in. Let's see if that works. I'm going to sign in and sign out. Sign in and sign out. Awesome. We're not going to worry too much about getting an error because we haven't entered anything. For now, we just want to make sure that the routes work. All right, let's also build out the register. For a new user, we want them to have a register. Maybe it's also asked for the name of the user. And just to keep things simple, we will just add a new folder in components. And this is going to be register. And this is going to be very similar to sign in. So we'll have a bit of a code duplication, but again, we're just building it fairly fast, so it should be fine for now. So copying this from sign in, we can just copy everything from sign in, go to register, and now change the sign in to register. And the register, maybe we'll add another field. Maybe that field will have at the top just the name. And we'll say for name, type text, and name will be just name. ID, we'll just say name. We actually don't need these properties. It just came with the form that I copy and pasted from Tachyons. But it does the job for now. It should be good. And we don't need the register link at the bottom. Let's save. And if we go back to the sign in, we also don't really want this to be an anchor tag. We want to do a route change. So we can just maybe do a p tag. And this p tag will have the onClick event as well. And onClick, it will say that from sign in, we want to go to register. Perfect. And then finally, if we go to app.js, we want to import this component. register and register. And register is defined but never used because we need to add it to our render. Now, this is a little bit tricky because we kind of have to do a few more conditional checks. We'll move this a little bit around just to have cleaner code. I'm going to say if state.route is home, in that case, I want you to render our home screen. And otherwise, I'm going to have another expression, so I'm wrapping it in curly brackets. And this other expression will have another ternary that will say this.state.route equals sign in. If it's sign in, then we'll return the sign in form. Otherwise, we will return the register form. And I know there's better ways to do it. We could have just pulled this out over here or done it in the return statement. But for now, we just want this to get working so we can test it out. We have sign in. If I click register, I'll go to register, but we need to change the title so we can actually see that. So let's do that one more time. Let's go back to register and we'll change the title to register. And let's go back. We're on sign in. If I click register, I go to register. And if I click sign in, I'm finally in. And let's finally also change the input type submit or the value to register. Let's save that again. Go back, register, clicks on register. I don't know if you also noticed that we're not getting the cursor when we click on register, so let's fix that. We'll go to sign in, and we'll say that on this p tag, we'll say that it's a pointer class. There you go. Whew. All right, so we're getting our form, which is good. The last thing that I want to fix is the sign out. I want to be able to have sign out only when I'm at home, and maybe when I'm on the sign in or register, I have the two navigation tabs over here. That's fairly easy to do. We can go back to navigation, and in navigation, we can say that if is signed in, a variable that we don't have yet, but we can create one. I just want you to think about how we want to design this. So if is signed in the user, in that case, we want to display this, right? Otherwise, we can display, and I'm showing you how to do this without the ternary, the way that we did it in the app.js. I just want to show you both ways. If the user isn't signed in, then perhaps we should have two navigations. One that says sign in, and another one that says register. And over here, I see that I'm returning this entire thing instead of what I should have been doing is returning the individual. So here I'll say return. Wrap this in a bracket. And we have the first return, and then if is signed in, then we'll do return. Let's save that. Ooh, I made another mistake here. We don't need the two nav things. We actually just want the middle p tag. And here, just add the two links. So the sign in and register. So we can remove this because it was giving me an error because I was returning more than one thing. All right, looks good. We want to make sure that the on route change, if we click on sign in, it'll go to home. If we click on register, again, it will also go to home. If I click sign out, it'll go to sign in. And then finally, is signed in doesn't exist yet. So it looks like we need to add a new state. And we'll call this one is signed in. And to start off, it's going to be false. And this is something that we can easily do in the on route change. On route change, we can perhaps add another if statement, and we'll say if route equals sign out. So if we're trying to sign out, well then we should set state of is signed in to false because we're signing out. Else if route equals home, well in that case we want to set state of is signed in to true. And you might be thinking, do we want to not authenticate and make sure that they have access to getting home? And that's something that we're not going to worry about for now. We just want to get it working. So if the route is signed out, then is signed in will be false. If the route is home, then, well, they're obviously signed in. So it's going to be true. And no matter what, we still want to change the route. Let's see if this actually works. I go back. I click on register. Oop, I'm going to home instead of going to register page. So I made a mistake here. If I go into navigation, obviously if I click on register, we want to go to register. And if I click on sign in, we want to go to sign in. Let's save that. Let's try that again. Sign in, nothing happens because we're already here. Register, nice. Sign in, register, perfect. If I click on register here, I go to register. If I click register, I'm at home. And we see that we need this to change to sign out. And that is on the home page. So we can go back to app.js. And it's a simple fix. We can go back here. We want to actually pass the prop here of is signed in to be this dot state dot sign in. Oh, that's not it. Is signed in. Let's save. So if we go back here, we see that it's not working. And that's because, again, this is why it's so tricky with JavaScript. I made false into a string. So when it checks is signed in over here, false technically is true in JavaScript because it's a string, so it exists. If I go to here and I do boolean false, it'll say that it's true. So let's go back to that. I'm going to say is signed in. This should be false, a boolean. So now let's see if that works. It's going to register. If I click register, it's home. If I click sign out, I am signing out. But see how this isn't changed? Because I made another mistake here. When we click sign out over here, we ideally want to go and say sign out. And when we sign out, we sign out properly. All right, we got ourselves a nice working app. There's a few cleanup materials that we can do here, such as removing the console. We're also using this dot state a lot when we can use destructuring. So I can just have is signed in, image URL, route, and box destructured. So now I can make things a little bit cleaner by removing this .state everywhere. There you go. Oh, and I have to add const here. All right, perfect. This looks pretty good. On button submit, on input change, everything is looking nice. We have our calculate face location. There's obviously a few things that we can improve upon, but for now we have a working app that does exactly what we need to. It does face recognition, and it works nicely. I also want to see the console, make sure that we don't get any errors. And we see that we have two things here. One is invalid DOM property 4. Did you mean HTML4? It gives us a nice error that says add signin.js. And that is because, again, we're using JSX, and 4 is a JavaScript word. So even though in HTML you can use for labels to attach them to input, in JSX we have to do HTML4. So we can do HTML4, HTML4, save that, and we'll have to do that in the register as well. And that works. But when I click sign in, I get the form submission canceled because the form is not connected. And that is because with HTML, remember when we worked on forms, it automatically, if there is an input or a button, when there's an on submit event where there's type submit, it will automatically try and send those forms. If I actually change this to a div, and I save that, if we go back to register and I click register, I don't get that error anymore. Again, because in future videos when we create the backend, we won't be necessarily sending a form. We're going to be sending it through JSON, which is more dynamic. We can customize things a little bit better. We can just not worry about HTML forms so that we have full customization with JSON. So we can do the same here as well. And again, signing in, no errors, everything works as intended. If the form part was confusing, make sure you check out the HTTP JSON and AJAX section. Like I said before, forms automatically submit or try to submit things. For us, we're not submitting anything yet. We're going to create our own server where we're going to be able to sign in our own users and register our own new users. There's a few things that we can clean up and we don't need to worry about because we have a working app. And now I want to start diving into creating a server so that we can actually sign in people and sign out and have a server that this website interacts with. I'll see you in that one. Bye-bye. Welcome back. It's time to learn Node.js. Now, Node.js, we've kind of used it in previous videos, but we haven't really explained it. So throughout this section, we're going to learn what it is and finally use it to build a server. Now, I may have mentioned this before, but Node is JavaScript that runs on your machine. You see, up until Node was created, you could only run JavaScript in the browser because the browsers were the only ones that had a JavaScript engine like V8. And Node.js was created with the V8 engine in order to be able to run JavaScript anywhere, including your computer, including on robots, and anywhere as long as you had Node.js. And as a matter of fact, we've been using Node this entire time in our terminal. When we ran commands that NPM gave us, like create React app, well, that was using Node. We were running JavaScript outside of the browser. And Node.js is probably the most popular for building servers. It's really, really fast, and more companies are using it now as a backend server because of the way that it's built. Node.js is probably the server of choice for any web apps or mobile apps out there that want to create an API or a server. And it's also really, really good at building chat applications and real-time communication. Anyway, as we've mentioned before, you probably should have this on your computer by now, but if not, you can download Node.js. I like using the LTS version, but as long as the version that you're using is higher than 8.9.3, this demonstration will work for you. Node is really, really good at making sure that everything is compatible. Again, if you're using a Windows operating system, then Node provides that for you in the download section as well. And again, to check Node, it's very easy. We just do node-v to see that we have it. And if you do have it, you'll have the version number printed for you on the console. One last thing before I show you some Node commands. Like I said before, Node can be run anywhere. And one of my favorite things to do with Node, other than build servers, is to actually create robots using JavaScript. This Johnny5 is a JavaScript library that you can use with Node. And if you have something like a Raspberry Pi, it helps you build functions using JavaScript that robots can perform. So highly, highly recommend it. After this course, if you want to explore more, Johnny5 is one of my favorite things, and it's surprising how easy it is to build a robot that does whatever you want it to do just using JavaScript. But anyway, let's go back to Node. In your terminal, if you actually type in Node and press enter, you'll see that the prompt changes now. And I can run Node in the terminal. If I do console.log hi, I get hi. If I do 4 plus 5, I get 9. And if I do boolean 3, oh, I spelled that wrong, boolean 3, I get true. As you can see, we're just running JavaScript. But there is a bit of a difference here. If I type in window, I get a reference error. Window is not defined. And let me clear this a little bit. This is because when we run Node, we don't have the window object. The window object was provided to us by the browser. And as you know, Node, well, there's no browser that's running it. Instead, Node comes with something called global. And you can see that this global has, just like the window object had, a bunch of things that we can use. But it won't have browser-specific things. For example, we won't be able to have global.fetch. It's undefined because, well, it doesn't exist. That was provided to us by the browser. We also don't have the document object, if you remember. If I do document, again, I get a reference error because, well, there's no document. So that's something to keep in mind. Node comes with its own properties and methods that we use. But other than browser-specific things, we can do anything we want with Node. One of the global objects that we have is something called process. If I press enter, again, I have a ton of stuff. And in Node, process means this process. What I'm running right now in the terminal is the process, what the computer is doing. All right, and let's just clear this. Now, if I do process.exit, I exit this process, and now I'm back to my terminal. Now that we have Node in our power, we're going to start writing some scripts and show you how we can start writing actual JavaScript, not in the terminal, but in Sublime Text. I'll see you in the next video. Bye-bye. Welcome back. Let's expand on our Node knowledge from previous video and actually create a script file that we can run. Let's just do the touch command here again to create a file, and we'll just call it script.js. You'll see over here on the left-hand side that I have script.js in my Node folder. Now within this folder, I can now do anything in JavaScript. I can say const a equals 5. Oh, and that's not the folder that I want. We want to open this, and we'll say const a equals 4, const b equals 5, and then we can just console.log a plus b. If I save this, in order to run this script, all I do is node and then the script name, script.js. And because we're in the directory, it'll know what script.js is, and it'll give us 9. How cool is that? Now, you also see that it exited. It didn't stay in the program. And that is because at the end of the file, once it reads everything and executes it, so the last thing it executes is console.log, it runs process.exit and exits out of the file. Let me show you something. If I did something called a set timeout, which we actually have in Node, if I do node global.set timeout, I get a function. Okay, so if I do set timeout, I can run a function, again using our arrow functions, and within here I can do console log. And set timeout is cool because it allows you to say, hey, when do you want this to be executed? And that's the second parameter, and I'll say 3 seconds. So if I save and I do node script.js, 1, 2, 3, and there you go, 9. And then process exits. Node is smart enough to run through this. Once this is done, ends the process and comes back to the terminal. Very cool. And again, within Node, we can actually use things that might be useful for us based on what global objects we have. For example, one of the most popular ones are __ dir name. If I save this and run node script.js, I get my directory, Node. And I'll show you why that's useful when we start building a server. But as you can see, we have the power of the browser and running the scripts that we want right here in our terminal. I'll see you in the next video. Bye-bye.
Let's talk about another feature of ES 2020. And this one is called global this. And the global this is a global variable that we now get. And because I have the latest version of Chrome, I can see that it works. And this points to the window object. So global this, does it equal window? Yep, global this is pretty much the window object that we get as part of our browser environment. Remember, the window object is what gives us things like set interval, set timeout, or any of the features that the browsers allow us to do. So why did we need a global this that is pretty much what we already had with the window object? Well, the neat thing is that this global this works outside the browser as well. Let me show you. Now, if we had Node on our computer and we run the command window to access the window object, we'll get an error. Window is not defined because window is part of the browser. But inside of Node, Node doesn't really work as a browser. It doesn't really know what window is. Instead, Node uses global, right? The Node version of window is the global object. Now with ES20, they wanted to unify different platforms outside of the browser so that there's a global variable that each one of them can access. So this, the global this, now exists in Node. Now, if you look over here, it's the exact same thing as the global object that Node has. So it's still not really the window object. However, the global this object now exists as both part of the window and Node, so that you can have unified variables across different platforms, different systems. So although global this has different properties inside of a browser than it does inside of Node, we're able to have a unified code base if, let's say, we want to run our app both in Node as well as on the browser. Now, keep in mind that if I exit out of here, the reason I'm able to use the global this inside of Node is that I have the latest version of Node, or at least a version that's higher than this. So you might not have global this work in Node unless you have a later version, more modern version that has implemented this new feature. All right, let's take a break. I'll see you in the next one.
Now going back to my example here, let's add a new file and we'll call this script2.js. Now the script2.js can have a constant called large number, and let's just say that's 356. And if we want to export this and say export default large number, and now within script.js I do import large number from script2.js. Let's make this a little bit smaller. And now I change this to large number, and let's just do a plus b. If I run node script.js, I get an error, unexpected token import. And that is because Node has yet to implement the new ES6 feature of import statements. And there are ways around it, and you can add packages in order to allow you to do this. But I'm going to show you the common JS way because most servers that you'll encounter will have the common JS way. And over the years, this and this will become more prevalent, but you already know how to do this from the front end section. So nothing is different here. In order for you to get familiarized with common JS, we're going to use the require form. So how can we do this using the way it works in Node 8.9, which is the version that we have? Well, we'll have to do a const large number equals require. Again, this might be familiar. And then within here, we have to give it the file path. With require, we now have large number. And we also want to export it now. And the way exports work with CommonJS is you do module.export. And that is because, let me just clear this and show you. If I do node and I do module, you see that module is a global object that we have access to. And using module.exports, I can say what objects I want to export in this file. In our case, it will be large number. If I save this and now run our node script, I'm going to exit the process first. Let me clear. If I run node script.js, I get object 5. Why is that? Well, because now we've exported this object. And the way we want to access it here, we're exporting a global object, which we can name whatever. In our case, we can say script2. And in order to get the property of script2, well, we'll say script2.largeNumber. And now if I run this, I get 361. And this can be named anything. It's just a variable that you're declaring. So we can just call it C large number, and it still works. It's a bit of a different style than we used to on the front end. And that's only because we haven't implemented Node hasn't implemented the import and export with this version of it. But it will come eventually. Just don't get scared if you see it this way. Once you get used to the syntax, it's pretty much the same. All right, I'll see you in the next one. Bye-bye.
I've got some exciting news for you. And no, the exciting news isn't that I'm now using VS Code instead of Sublime Text. I still love my Sublime Text code editor, but just to change things up, I'm going to use VS Code for now, and I'm going to talk about ES6 modules in Node. You see, up until now, we had to use the require syntax, which is what we call the common JS syntax with Node. Originally, Node was created with this syntax in mind because JavaScript wasn't created with modules in mind. They never had the import-export syntax that we had with ES6. So because Node was created before we even had that, they had to create their own module system, which is how we got require and this common JS syntax. But as of Node version 12, they now have ES6 style module imports and exports. So the good news is that if you're watching this video and you have the latest version of Node, then congratulations, you can now start to change from require to using import-export keywords. So let me show you, based on what we've just done and what we've learned about modules, how we can convert this to ES6. So the first thing we can do with script2.js is to, well, actually you can remove this entire thing. And we can just simply say export const large number. So now this gets exported. So I can save that. Next, in here, instead of the require syntax, let's comment that out and let's say import. And in here, we'll import doing destructuring the large number that we exported. So remember, we did export large number, and we're going to say from script2.js, grab large number. So this object destructuring simply says out of the script2 object that we're going to import, just grab the property large number. So I can say from, and in here, dot script2.js. So now that I've imported large number, and I did object destructuring, I don't need to call script2.large number. Instead, I can just simply do large number. So will this work? Well, let's test it out. I'm going to open up the terminal here. And in here, I got to make sure I'm in the right folder. So I should cd into the ES6 folder. And in here, I have the script and script2.js. Now, if I do this, do you think it will work? Well, the first thing I want to do is check my Node version. So if I do node-v, and you should do the same, what's the number that you get? In here, I see that I have a pretty high Node version. As a matter of fact, it's higher than version 12. And if you remember, with version 12, we got ES6 imports. So this should work, right? Well, let's test it out. I'm going to say node script.js. Oh, syntax error. Cannot use import statement outside a module. Why is that? I mean, I have the right version. Luckily, Node gives us some hints. Warning. To load an ES6 module, set type module in package.json or use the MJS extension. And this is a little gotcha. Because Node was created with this common JS import-export in mind, we need to actually specify how we want Node to read these files so we know that we're using the ES6 syntax. Because remember, it's different from a browser. So we have two options here. And I also want to show you how you can find this out on the documentation website for Node. Usually what you would do is Google ECMAScript 6 Node.js. you'll probably get to the Node.js documentation. And we can see here we have modules, ECMAScript modules. And let's go to enabling. And if we click on enabling, we see over here, all right, there you go. We need to add the MJS file extension. Inside of package.json, we have to update the type field. So if I click on the type field, I'll read about it here and I say, oh, import statements of JS files are treated as ES modules if the nearest parent package.json contains type module. So this is a good way to learn how to read the documentation. Remember, the answer is probably always inside of the documentation. So let's follow their advice. What if I rename these to MJS and this to, if I now run this, do you think this will work? Actually, I have to fix one more thing, right? I have to make sure that the syntax while we're importing is MJS. For fun, let's see if I can do it without the file extension. Let's save here and run this. Cannot find module. So we actually have to specify the file extension. And if I run this again, hey, check that out. Everything works. Our ES6 imports works, and we just followed what they've recommended. Name your files MJS. But there was another option too, right? The package.json option. So let's rename this back to .js. Some people really don't like the syntax MJS, and they prefer this method instead. So again, what we'll do is we'll run this again and make sure we change this to .js, back to .js. And if we run our code, it'll give us an error because, again, we have to add type module inside of package.json. We don't really have package.json, right? But we can just run the command npm init and then -y to say yes to all the options to simply create our package.json file. There you go. So in here, all we need to do is just simply inside of package.json, wherever we want, add type module so that it reads the package.json and says, oh yeah, they're going to be using ES6 modules. So if I save this and now go back and run my code, look at that. It all works. How cool is that? Now go ahead and play around with ES6 modules. As you start working with more and more Node.js code, you're going to see more import statements than require statements like we have before. However, because a lot of code bases still use the require syntax, if you go on NPM, for example, and try to download packages, a lot of them still suggest that you use the require syntax. And that is because you're not sure that everybody has the latest version of Node. Some people might be running a Node version that is lower than version 12. In that case, the code isn't going to work. And that's why for the rest of the course, and even for the final SmartBrain project, I've left our Node files with the require syntax so that anybody, any student taking this course can run those without any errors. But feel free to update them if you ever want with ES6 imports. But for now, it's always a good idea to keep the CommonJS syntax to make sure that if your code is being run on different systems and you don't have control over the Node version, well, then you can make sure that the require syntax is going to work for everybody. I'll see you in the next one. Bye-bye. Welcome back. We're going to talk about ES 2022 again. Now, if you remember, I showed you that we can do this cool @ method now with ES 2022. But then I left you on a cliffhanger and I said the best part of ES 2022 is this new feature called top level await. And it's now time to talk about it. Now, do you remember how in the previous lectures we talked about async await? And I gave you this exercise where you had to, well, solve the below problems, and you had to use the async await feature. Now, during those videos, I told you that in order for you to use await, you have to wrap it in an async function. Your ability to use await depended on the fact that we use this async keyword. Without it, we would get errors. Well, guess what? That is no more, because in ES 2022, we have top-level await. What does that mean? Well, let's copy this first chunk of code. I'm going to open up the browser, and remember that the Chrome developer tools usually has the latest version of ECMAScript. That means we can most likely test out these new features. So in here, I'm going to copy and paste the code over here, which uses the async function. Now, before, we had to use the async function. But what I'm telling you is with the top-level await feature, we no longer need that. We can just use await without this. So let's test it out. I am just going to remove this because we don't need this. We just need the async one. And well, I am just going to completely erase the function that's wrapping it and just use this const response await fetch. So let's see. Is this going to work? Let's find out. I'm going to press enter. No errors. That's good. And now if I do data, look at that. I get my 10 users. How cool is that? So with top-level await, we can clean up our code a bit. Now, there are still times where we might want to declare an async function. It's nice. It's very descriptive, right? We know right away that this is an async function. So there's still use for the async keyword. But there are times where you don't really need this. And by just having the await keyword at the top, it cleans up the code a bit. So what we're going to do, and what your exercise is going to be, is I'm going to provide for you the solution file that we used in the async await exercise. And now I want you to convert this where you remove all the async keywords from here and just use top-level await. How cool is that? I love this feature. But the power of this feature really comes into play when we start talking about Node and Node modules. So we're going to do this exercise, but remember that this top-level await, the true power of top-level await, is going to be explained in the Node modules. It's going to be really, really cool. So again, we'll come back to this. But for now, let's do some exercises and move on. I'll see you in the next one. Bye-bye. All right, we have an exciting lecture because for the final time, I'm going to bring up ES 2022. Now, we've had 2 lectures before on ES 2022. We talked about the @ feature that works on arrays, and then we talked about the top-level await and how you can now use the await keyword without that async keyword wrapped around it. Now, the true power of this top-level await can finally be demonstrated with this lecture that we just did. Now, we talked about ES6 modules and how now we can just import things really, really nicely, and we use script and script2.js to demonstrate it. How can we use top-level await to expand upon this? Well, remember, await helps us await something like a fetch function, which returned a promise. But we can also use it on things like import. What does that mean? Well, remember how we use the response await fetch and we use the JSON placeholder users, and then once again we did data await response JSON, and then we got the users. So we were able to use await on the fetch function. But we can also use await on imports. So what we can do is actually have imports later in our file and have them conditionally import things. So for example, if I do something like if well, I don't know. I'm just going to say if true, or if 1 equals to 1. Obviously, it's going to say true for now, but I'm just giving you an example. So if 1 equals to 1, I'm going to await import, and I'm going to import script2.js. So let me remove this or comment this out and see if this still works. It actually won't, because we have to extract the large number because we're exporting it, remember? So I can do something like destructuring here to say large number. And now if I replace this with large number, I save, and then right here we run the node script.js. Let's see what happens. I'll get an error. And this is a bit of a trick. So what we need to do is actually wrap this in brackets. So kind of like what we did with the require function, but because it's not a top level import anymore, we have to use it as an import function. So if I save this and run this again, and why do we get large number is not defined? Well, this was a little trick. If you remember, we're declaring a variable inside of these brackets. So if you remember the lecture on scope, it's not a global scoped large number. So what we can do is say let a, and let's just say a is large number. So if we go back to a here, like we had it before, save. I know this is a little convoluted, but hopefully it explains the topic nicely. If I run this again, look at that. It works. How cool is that? So the cool thing with the top level await is that now I can include modules conditionally. Maybe I say that, hey, import this module if something is true. If a condition isn't met, then we don't want to waste resources importing a module at the top of our file. Only import it if we actually need it. So hopefully you get to see the power of this top level await. Now we don't need to get into the details here. There's lots of cool things that you can do, like code splitting with it. But this is a cool new feature that really allows us to do some powerful things in JavaScript, and especially while working with modules. As a fun thing, if I do 2 here, let's see what happens. Undefined, because we didn't import the module. Very, very cool. So there it is, ES 2022 top level await. Super powerful, and you're going to start seeing it more and more in code bases moving forward. I'll see you in the next one. Bye-bye.
Welcome back. In this video, I want to talk about the 3 kinds of modules that you can have in Node. We've seen that we have this type, which we already know about, which is a module that you create yourself, like Script2, and has its module exports, and you give it the path to the file so you can find it. There's also something called built-in modules. And built-in modules are modules that come already pre-installed with Node. For example, one of the more popular ones is the FS module. And this module, if I console log, is a module with a whole bunch of things, once again, but it allows you to read the file system. That is, if you had a text file and you wanted to read through the text file and extract out how many times the word hello was said, well, you can write that by simply using the file system module and using something like read file or read file sync, which will output, if you do something like read file, it will output the contents of the file, and then you can do whatever you want with it. Another popular one is the HTTP module, which, as you can guess, is the module that we'll use later on to build a server. And you can read up on all these modules, but those two are probably the most popular. In our case, as web developers, we're really concerned with the HTTP one. These modules are without the path. They're just simply exactly like that. And then finally, the third type of module, again, the one that we know, is something from NPM, a package. And one of my favorite packages to use with Node is something called NodeMon. And NodeMon is really, really nice because, well, if I clear this and install NPM install, and I'll have to do npm init first actually to make sure that I have a package.json file. And if I pass the -y, it'll just say yes to all the prompts that I get beforehand. There you go. I have my package.json. And now within this package.json, I'm going to say npm install nodemon -- save dev. If I go to package.json, I see that now I have nodemon in dev dependencies. And we haven't seen this before. Up until now, we've done either -- save or nothing at all and automatically put it in dependencies. Dev dependencies are dependencies that we only use when we're developing. When we actually release this app or this server, it won't be included because nodemon is just for, again, for our enjoyment while we're developing. Now let me show you what nodemon does. Nodemon now can be used because it's in node module, and if you go to bin, you see nodemon here. Well, because it's in the package node modules.bin, I can use the command such as start and say nodemon. And Node is smart enough to know that if I run nodemon, it's going to look in the .bin folder and find it there. If it finds it there, which it does, it will run the command. So let's see what happens. If I clear this and do npm start, I get a bit of an error because, well, we have some weird files in here. So let's just go back to our original example. Let's save, run npm start. And we have a clean exit, but you see that something is still running. If I change this now to 6 and I save, it'll watch those changes for me. It keeps listening to changes and it will output everything. Again, if I change this, so I don't have to keep running the node script.js command. Very cool. So we'll be using nodemon a lot, and it's one of my favorite things to use, again, so that I don't have to go back and forth. And if you make any mistakes, well, it will let you know right off the bat. All right, perfect. That's it for now. I'll see you in the next one. Bye-bye. Welcome back. I think it's time to create our own server now. So let's create a new file called server.js. And in order for nodemon to listen to server.js, let's just type in nodemon and then server.js. Now, if I save this, nodemon will listen to this as long as I say npm start. As I've mentioned before, Node comes with its own HTTP module, and that's what we're going to use to create our server. And it's very, very simple to use. We simply grab the HTTP module and then create a server by defining it, saying HTTP create server. And this create server will create an error function. And within here, for now, let's just do console.log. I hear you. Thanks for the request. And then finally, we have to do server.listen and give it the port number that we want to listen for. So let's do 3000 for now. But again, you can do anything. You can do 3001 if you want, but 3000 is nice. Let's do node server.js. And it looks like it's just hanging there. But let's go to port 3000 on our local host, that is our machine, and see what happens. If I open up a new tab and go to localhost 3000, nothing's happening. If I open up the console, nothing's there. But if I go back, I see, I hear you. Thanks for the request. And that is because, remember, server.js is running in Node. It's running here in the terminal. But it's listening to connections. So when I hit refresh here, or I press enter and try to connect, it will be listening and it will run console.log. And you can see that the second I hear you, thanks for the request is here. If I refresh 2 more times, well, again, I get 2 more. But right now, the browser is just hanging there because we're not doing anything. We're not responding with anything. You can see at the bottom, it says waiting for localhost. We're just console logging on our end, but we're not giving any response. Let's do that. I'm going to remove the console log and use the parameters that create server gets us. So anytime we try to connect, we have a request and then a response parameter that we can use. And let's make this a little bit smaller just so we can see. And within here, we can do something like response dot set header content type. We're letting you know what kind of content we are going to send, and it's going to be text HTML. And this is just a standard way of declaring content type. And we'll say response end with an h1 tag that says hello. If I save this and rerun, well, again, we have to restart our server. So let's get NodeMon involved in here so that it listens to file changes. I'll go to package.json. I'll save this and now run npm start. See that everything is running. Let's go back to our server.js file. If I go back and refresh, I get hello. If I go to the network tab, I see that localhost, I get a 200 response. If I click on this, I see that the response was h1 hello. If I go to headers, I see that it was a 200 status code and the content type was text HTML. Very cool. I can also listen to requests. So for example, in here, I could have said console.log requests headers. I could have also said method, and finally something like URL. A request gives us a lot of information about the request that we received. And just so we are clear on what each one of these are, I can say headers, method, and URL. If I save this and rerun, I see that I get headers, our localhost 3000. We see that user agent was Mozilla Macintosh, so that's what we used. We used an Apple to make that request, all right. And the method was a get method, and URL was just the backslash. Let's just comment out the headers for now and show you how things change if I now enter localhost profile 123. I get method get and URL was profile 123. So we get information about the request that the front end made, which is very cool. Now, with our response, we responded with text HTML, but You remember JSON, right? We talked about how useful JSON is when doing AJAX requests. Can we do that here? Of course. If I go and change content type to application JSON, and you'll just have to get used to this, but this is the way you say that the content type is JSON. Now we can send a JavaScript object such as user, and we'll say name John, hobby skating. Now this user I can pass here, but remember, in order to transfer between the wires, we need to use JSON.stringify. And make sure you check out the JSON video if that is confusing to you. But again, we're changing this object into a JSON string so that we can send it over the wires. If I save, and let's go back and refresh, I get, look at that, a JSON response. Again, name John, hobby, skating. And if I click on the network tab here, I see that the content type is application JSON, and the response is in JSON format. So on the front end, we'll run JSON.parse, and then this in order to convert it to a JavaScript object. Very cool. We've just created our very first server. But this HTTP is pretty bare bones. As you can imagine, building servers is something that everybody does that has a website. And there are many tools that we can use now that are more elegant than running HTTP. And the most popular and the best one to use with Node.js is something called Express, which we're going to talk about in the next video. I'll see you in that one. Bye-bye. Welcome back. As I mentioned before, developers are really good at making sure they don't keep doing the same thing over and over. And if there's anything that is done over and over, they build a tool for it so that it becomes simpler. Well, building servers was one of that. It's something that everybody uses. So people use libraries, just like we used React on the front end, on top of JavaScript, to make our lives easier and build faster, more robust servers. And there are many libraries that people use with Node to create a server. But the most popular, hands down the best one right now, is Express. And I have here the State of JavaScript survey. It's a famous survey that gets done every year at the end of the year that asks developers what their favorite tools are, what front-end tools they use, and I highly recommend that you check it out. But you can see here for the backend, the library that is most popular is Express. And this purple bar means I've used it before and would use it again. There's other ones like Koa, Meteor, Happy, but the usage is very small. Express is just a tried and tested. There's plenty of tools and information online for it. So if you ever get stuck, you're able to find an answer to your issue right away. So Express is the way to go. So let's learn some Express and show you how much easier it becomes to create our own server. So we're going to delete the server that we built previously in the last video and install Express. Let's do npm install. And again, through npm, we have the Express package. And now we have Express available to us. So let's grab it. The way you create an Express server is very simple. You simply do Express require Express. We have to do a const app, and then to create that app to run Express, we simply do Express. And then finally app.listen 3000. And that's it. We have Express running. Let me do npm start. And we see that our node server is running. And if I go back to localhost 3000, I have cannot get. And that is because, well, again, we're not doing anything. But in just 3 lines, we have a server. And I want to show you that Express has a great guide to getting started and ton of information of how to use it and documentation for it that you can check out on your own. But for now, let's build our own. Well, Express is really good at doing rounding. If you remember, in our localhost, we got cannot get. To do a GET request with Express, we simply do app.get. And the first parameter is the path. We'll just do the root path. And the second parameter receives a request and a response. And in Express, instead of writing everything out, the common way of doing it is doing rec and res. And in here, we can say response.send. And we'll just send a hello, just like we did in our previous video where we used the HTTP module that comes with Node. So let's check that. Let's see if that works. I'm going to save, refresh, and I get hello. If I open up the console here in the network tab and I refresh again, I see that the response is hello. We see content type, text HTML that was converted automatically for us. I can also, instead of send just an HTML, so instead of doing something like h1 and h1, which gives us an h1 hello, I can also now send JSON. Const user again, and this time the user name will be Sally. And her hobby will be soccer. And I need to add an equal here and then pass in user. If I save that and go back and refresh, look at that. It automatically does the JSON stringify for me and returns a JSON content type, an application JSON content type with the response that is JSON. Very cool. So you can see the power of Express even just from this simple example. It takes away a lot of the repetition and makes our life a whole lot easier. Now, we've only done get here, but you can also do post request. So for example, if I did post profile, well, now if I refresh, I get an error because now I've made the request method, which was get from the browser, but here I only accept a post request from profile. If I do profile here, I cannot get profile, because even though we are going to the proper URL now, we're doing a GET request. Anytime we refresh the browser, it's a GET request. And in order to do that, we need to actually send some data over. And I'll show you how to do that in the next couple of videos. But just to show you how Express works, I can keep adding these routes. Let's do get profile that returns getting profile. And if I do another get, this time to the root URL, and this one I'll just say getting root. If I save this now and refresh profile, I'll get a 200 OK with the response of getting profile. And if I do no profile and just the root URL, I get root. And the way Express works is it checks each one line by line. So for example, it will check, hey, did the GET request have the root URL? Did the GET request have profile? Did the POST request have profile? And if it matches any of these, well, it will run whatever the function inside of it is. If I do a URL that doesn't exist, I get a 404 not found because, well, we did a GET request to this URL that doesn't exist. So using this, we can use the GET method, the POST method, the PUT method, and the delete method that we're going to actually demonstrate in the next couple of videos. But as you can see, it's a simple matter of saying, if you go to this route, do this. If you go to this one, do this. And everything is just logical and trickles all the way down. All right, I'll see you in the next video. Bye-bye. Welcome back. In this video, I want to talk about an important concept in Express, and that is middleware. Let me show you how it works. If I run the server here, I just have a simple server that sends test. Express has a concept of middleware. And if I do app.use, this is a generic Express middleware that I can enter in here. And what middleware does is, as the name suggests, as the request is coming in, it's going to pass through this use function and then trickle down to whatever we get, post, put, delete. And this middleware is going to do something to the request that we just had in order to perhaps make it easier to work with down here. Let's demonstrate that example. App.use receives request, response, and then something called next. And within this function, we will just say console.log h1 hello. If we save and go back here and run localhost, it's hanging here. Even if I open up the console, nothing's happening. If I go back, I see that hello gets triggered because I'm console logging it, but it never reaches here. Well, that is because in order for the middleware to keep passing data through, it needs to call next, the third parameter. So now by calling next, if I refresh, I receive test. So the middleware, the way it works is we use app.use. It gets the requests of the website. The request comes through. We can do whatever we want with it. In our case, we're not really touching it. We're just console logging hello. And then we hit next, and then Express keeps running through these. And although you might be thinking, why is this useful? There are many, many cases that I'll show you later on why middleware is important. And middlewares are great scripts that people have pre-written that you can add to your server. But you'll see that more in the next video. I just wanted to show you the basic concept of middleware, something that receives ahead of time before it gets to the routes, the request, modifies it, and then passes the next function to keep it going. I'll see you in the next one. Bye-bye. Welcome back. Let's try and get this post request to work that we couldn't get in the previous video. Now, in order for us to test something more than just get, well, we can use the terminal, but there's a really nice tool that allows us to make these requests to a server and see what we get back. And it's called Postman. If you go to www.getpostman.com, it is one of the best tools if you're ever working with the server. It's free, and you can download it for your operating system. Just simply click on whichever one you want, sign up, and once it's loaded, then you can open it up, and you'll have something like this. And don't worry, it's very, very simple to use. We simply have here the requests that we want to get, and you'll see a few that you've never seen before, and don't worry about them. These are very, very rarely used. We see the ones that we care about: delete, put, post, get, right there. And you simply enter the URL that you want to have this running on. So in our example, let's do npm start again. And while the server is running, let's just go to profile, get profile. And then in here, we want to say local host 3000, that's the port that we gave it. And we'll say profile. So we want to do a GET request over here. If I click send, I get getting profile. It gives me the headers and the body, which is great. But now because we have this tool, we can also do a post request. So let's say that we are no longer sending the user. We want to send a response. And from this response, we want to return whatever user that we submit to profile. So let's start off here first. We're going to change this to a post. And with a post, remember that we can actually add things to the body. And you see over here that there's a couple of options. Form data, the XWWW form on URL encoded. We have raw, and then binary. Now, don't let this scare you. These two are forms through HTML. If you usually do an HTML form tag and do a GET or a POST request, you can just click on this and you can see here a key value. So I can say name equals Andre. And now when I send this, I get Sally and soccer. Well, because, I haven't saved this yet. Let's go back to what we had before and send that again. We see that the post request is working. And if I want to access this information, I simply do request.body. But let's see if this works. If I click send, I get undefined. And that is because Express only gives you a little bit. You still need a few packages if you want this to work. If you ever want to access request.body, you need to use a middleware. And the middleware that we want is called body parser. And you'll use it in most Express servers, so you'll just get used to it. It's npm install body parser. And now this body parser, what it's going to do is it's going to grab whatever information we receive and parse it, just like JSON or forms, into something that we can use. In order to actually use it, we know how a middleware works. We simply at the top say app.use. And body parser will come with a body parser that will just require with the package that we just installed. In app.use, we simply do body parser dot URL encoded, which is how we're able to get this. And we just have to pass it a parameter extended to false. Let's try that again. I'm going to save. I'm going to npm start. If we go back and send again, we see that, there you go, it's working. Name is Andre because we've sent our key value with form data. So if you're building a server for a form that gets submitted, you'll use this. But as you know, there's also JSON that we can use. And the way we use JSON is we click on raw, and in here, we can send whichever things we want. In our case, it's going to be JSON. And with JSON, we can now say what we want to send. And if we ever do any wrong syntax, it'll tell us that this is wrong JSON. But let's just say for the profile, I want to add a new user. And this user will be called, remember double quotes here. We'll have user, and this user will be called Jenny. And Jenny will have a hobby of tennis. Everything looks fine. That's JSON. If I now send this, I get an empty object. Again, because we've only told it to parse URL encoded, body parser needs to also know about JSON. Again, in order to do that, we say app.use bodyparser.json. If we save that and send again, look at that. We have user, Jenny, hobby, tennis. So now we can add that user by maybe adding it to our database and then sending a response, success. Let's try that again. We get a response, success, that we've posted Jenny tennis. In this way, we can also do put, which is very similar. We just send the data, but put is used for updating if we want to update perhaps Jenny to have a different hobby, and delete to delete maybe the user. Something that we'll get into the next video. But as you can see, Postman is great. It's a great way to test out your server before you connect it to your front end. Something that we'll definitely do in this course in our final project. Very cool. I'll see you in the next one. Bye-bye. Welcome back. In this video, we're going to talk about RESTful APIs. Now, what is that? A REST API defines a set of functions which developers can perform requests and receive responses via HTTP protocol, such as get, post, put, delete. Something we've talked about. Remember how I said a web browser sends a request and just hopes that the server returns what the browser asked for. Google servers can send us whatever it wants. It doesn't have to follow the rules that perhaps the web browser sets. With RESTful API, we're able to create an API that is RESTful, something that follows the rules that everybody can agree on so that we have compatibility between different systems. So a RESTful API is an architectural style, and it's an approach to communications. It's an agreed upon set of rules so everyone plays nicely. A RESTful API uses get to receive a resource, put to change the state or update a resource, a post that creates a resource, and a delete to remove it. And that's something that we've already talked about. And the RESTful API is a way to define our server so that it specifies what it can provide and how to use it. And in other words, the URL parameters should make sense. For example, if we're doing /profile, well, we expect that if it's a GET request, we're going to get a profile. If it's a POST request, we're going to add a profile. If it's a put, perhaps we're updating the profile, and this URL makes sense. And you can think of this as the noun of what we want to receive. The HTTP request is the verb, and everything after the slash is the noun. Now finally, REST APIs are something called stateless, meaning that calls can be made independently of one another, and each call contains all the data necessary to complete itself successfully. A server doesn't need to keep memorizing things. Each request that comes in has enough information that the server can respond with, regardless of who that person is. So in this example, let's build a small little app that has a RESTful API. Let's make this a lot smaller. There you go. We have our previous example. We'll start the server and talk about some of the things that we can do here. Well, when we look at a GET request, this GET request, let's actually remove this as well, just so it's not too messy. This GET request will have a request object that we receive. Now, this request object can have a few things. We can have request.query. We can have request.body, which we saw in the previous video. We also have request.header, again, something that we've seen before, and also request.params. And this is probably the most used properties of request. So let's go through it one by one. Request.query is what we get when we do a GET query. For example, within here, if I do a console.log request query, well, I can go to localhost, and in here, something that we've already talked about, I can add a question mark to say that this is a query string and say name equals Andre and age equals 31. I press enter, go back, and I see here that I have name is Andre, age is 31, because I have access to the query string. We also have request body, which again, we've talked about using something like URL encoded or JSON body parsers. We can add that middleware to receive whatever the request sends in the body. We also have request.headers. So if I console.log request.header, well, this time using Postman, I can say in the header, and it has a nice headers tab, we see that we have content type application JSON, which automatically does it because the last request was a JSON request. But I can put in anything here. I can say name is Andre, or this time, just to change it, we'll say Sally. If I send this, oh, and this is a delete method. Let's make sure it's a get method. If I send this, I see that now request.header have all these headers, but also name Sally. Very cool. And then finally, we also have something called request.params. And if I console log request.params, this is a syntax where you use the parameters of the URL. If I do the semicolon and then let's say ID, I save this, and now we have access to whatever the parameter is of the URL. So let's just say 1, 2, 3, 4. And I'll remove the header for now. If I send, I now have ID 1, 2, 3, 4. All right, awesome. And you can have as many parameters as you want, and you can nest them. But we have access to our request information, which is fantastic. Now, when we send a response, we also want to have a bit of an option as to what we want to send. Well, with a response, we can say that with sending, we also want to respond with a status. Let's say a status of 404. And we can say send not found. If I refresh and send now, I get not found, Again, not found with a status of 404. Again, if I go back to my browser and refresh, I have in my network tab a 404 status. All right, perfect. And again, you customize so that we have a RESTful API, the get, post, put, and delete to follow the rules that the web browsers expect. Now, one last thing. Up until now, we're just sending data back and forth, but what if we wanted to serve something called static assets? That is index.html, CSS file, JavaScript file. That's more realistic, right? Usually we want an index file and having our app run. Well, that's very easy to do. We can create within this project, let's just do a new folder called public. And this name might be familiar to you because when we did create React app, public was there and it held all our static files. So in here, let's just do a new file, index.html. Now within this public file, we'll just do a quick HTML document that says hi. And within here, I'll say it's working. In order to get Express to send static files, we can just remove this for now, just to keep things clean, and do another middleware, app.use. And this comes with Express already. We do express.static, and within here, we give it the file path. In our case, we know that we want to get the dir name, which we've seen in previous video, which is the directory of where we are. In our case, it's Node. And we want to go to the public folder. So we do public. This is going to print out Node, then public. So now if I save this and go back to our GET request, I get it's working. Let me make that bigger so you can see. And if we open up our console and our network tab, I refresh, I get, let's do a hard refresh, I get 200. I get text HTML, and the response is my HTML file. And if I had CSS link here, it will load the CSS in my public folder. If I had a JavaScript file, then it will load it because within the body we can add a script tag. And this is a server that we just built that serves simple static assets. And as soon as we want to have something like an API where we interact with it, we do get, post, put, delete, that's when we start using our methods that we learned previously. Very cool. Now that we have this basic foundation, we're going to build our server for our app. The app that we build in our final project, our image recognition app, well, we're going to build the backend for that now. I'll see you in the next one. Bye-bye.
Hello, everybody. Welcome back. And in this video, I want to show you something that got me really excited when I first started learning Node. And hopefully you get just as excited as I am as we go through this video and then do a little bit of a challenge. It's going to blow your mind. At least it did for me when I first started learning to code. Now, in the previous video, we talked about something called the FS module that comes with Node. And this is something that is built into Node. And the way we get it is, well, we just do const. Well, actually, we need a file first. So let's do a touch script.js. We'll create a new script. Perfect. All right, we can close that because we don't need this. And in the script.js that we have in this folder, awesome Node, we can have const fs equals require fs. So fs here stands for file system. And if you have Node downloaded, you have access to this by just doing this. Now, why is this so exciting and so useful? Well, because FS, file system, allows you to access our file system, which again, doesn't sound that exciting, but let me demonstrate what happens and why this is useful. So bear with me here. I'm going to do a bit of coding and then I'm going to explain exactly what is happening. So we're going to use the FS read file. It's pretty self-explanatory. We have a blank parameter, and then we have error for error, data, and this is an arrow function. So the second parameter is a function, and this function has either error or data. So for the error, I'm going to say if there is an error, we'll just throw error. Or we can just say console.log error to really shove it into their face. All right. Now, if there wasn't an error, we'll just say console.log, and we'll just log out whatever data is. All right. Let me add the semicolons and save that. So what did I just do here? I just imported the FS module that comes with Node, and the FS module has a method, read file, that, well, it looks like it reads some sort of a file. The first parameter is actual file that we want to do, so the path to the file, which we don't have yet. So let's create one. I'm going to say new file, and we'll call it hello.txt. And with hello.txt, we'll do our classic hello there. And exciting stuff, so exclamation marks. We save that, and now we can say that we want to read the file hello.txt from the current directory hello.txt. Now, this read file method is going to find the file with the path. Okay, so here it is. It's going to read it, and then if there's an error, it's going to spit out an error. If there's some sort of data and everything's successful, it's going to spit out data. With the way we can run this file in Node, well, first I have to save it. We'll say node script.js, enter, and I got buffer. What is that? And that is because we have to do a little bit of encoding. And what that means is if I do this toString, let's just try this and show you what I mean. And I get hello there. So the read file reads the file, as the name suggests, and it's going to spit out whatever it's reading, data. Now, why do we have to put in the toString here? Just so you know, toString does something by default. If you don't add anything, it's going to use the encoding called UTF-8. And UTF-8 is a type of encoding. Let's just run this to make sure that this is still the same. Yep. So UTF-8 is a type of encoding that we have that's pretty standard with HTML5, and pretty much everybody uses it on the web. It's a way for us to have characters, whether they're Latin characters, ABCs, or we have Korean, Japanese, Chinese characters. They're all represented by a number, and UTF-8 is a way of encoding these numbers to make sure that we can read them. It's actually quite a complex subject, so I recommend the Wikipedia page that talks about UTF-8. For now, just know that UTF-8 is a type of encoding that is pretty much standard across the web. You might have also seen ASCII, and ASCII was, before UTF-8 existed, ASCII was mainly for Latin-based languages, so the ABCs, and UTF expanded that to include many more languages from different parts of the world. All right, that was a little bit of a tangent that we didn't need to go on, but as you can see over here, we have hello there, and we're able to read the file. All right, very cool. Let me just add one other method to your repertoire. Let's also do fs.readFileSync. And readFileSync works a little bit different than the previous one. And sync stands for synchronous. So let's see what happens. I'm going to put in hello.text once again. And this time I'm just going to leave it like that. And let's just say that this is going to equal the file, and we'll just console.log the file. All right, let me save that and run this. All right, we know once again that we got this because we need to do toString. So let's do that. I'm going to toString. I'm going to save and run this again. All right, I get hello there. But just to distinguish them, let's just say that this is number 1, and this is number 2. I save this, run this again, and whoa, what just happened? We have 1 coming after the 2. Now, if you've watched the asynchronous synchronous video in this course, then you might understand what's happening here. If not, I'm going to do a quick synopsis, but I do recommend you check out that video. Now, read file is asynchronous, and that's why it has something called the callback function. It is saying, hey, I'm going to read this file, and when I'm done with it, you just keep going on with your business and keep reading line 3, line 4, line 5, line 6, all the way to 11. When I'm done, I'll let you know, and I'll either give you an error or some data. Read file sync, which is synchronous, says, I'm going to read this file, don't do anything, just wait here. When I'm done, I'm going to assign it to file, and then you can keep going. So as you can see here, what happens is we read the file, and because this is asynchronous, it's going to run this and come to line 10 and run the fs read file sync. And the read file sync, because it's saying, hey, wait until I'm done this, is going to print out hello there. And then the asynchronous code is going to say, hey, I finished reading the file, here's the data, and it prints out down over here. Again, I really, really recommend you check out the asynchronous synchronous video. But for now, hopefully that makes sense. Now, looking at this, which one should you use? Well, for a simple case like this, we can use whichever we want. But you may see a problem with the second one, especially if we're building something like a server. If we have a massive file that has something more than hello there, well, if we're doing read file sync, what happens is we're going to halt or pause the execution of our file, and it's going to read the entire text. And the program is just going to be waiting for that to finish. Versus the read file, which says, hey, you can keep going ahead. I'll let you know when I'm done with this. So when you're building a server, and let's say an Express server with routes, well, in that case, we want to use read file if we're reading any sort of a file or a text file, whatever it is, because that way we're not blocking the execution and the program can keep doing things. All right, so one last time, just to clarify things, I'm going to label these as async and sync. So once again, if we run this, we have sync and async hello there. But very cool. We're able to read a file in both instances, which was kind of cool. Let me show you a few more of these and then tell you exactly why this is so exciting and how we can use it to do some really exciting things. So let's say the hello there text is kind of boring and we want to add to it. Well, we can do something like this. fs append file. We give it the file we want to append. So in this case, it's hello.txt. And by the way, if this doesn't exist, it'll actually just create the file for us. And the second parameter will say what we want to add. So let's say we also wanted to add maybe a space and that says, "This is so cool." Another exclamation mark. And finally, third parameter takes an error, and this error will just say that if there is an error, let me make this smaller so you can see. We'll just say if there is an error, we'll just console.log. Oh, cannot type. Error. All right, perfect. So let's run this and see what happens. I'm going to run the script. And I get hello there because these ran first. But if I go to hello text, look at that. We just wrote to a file. And now we have, this is so cool. So if I run this again, and let me clear this just so we have more space. Look at that. I get hello there, this is so cool. Hello there, this is so cool. If we go back to the hello.txt file, oh boy, we've added even more. This is so cool. Text. So that's pretty cool. We just added a few more lines to our file. Let me remove that just so it doesn't get too annoying. I'm going to save it and come back. All right, so we learned the append. Let me just comment this out so that it doesn't interfere with any of the other ones. Let's do a write this time. And let's create some space here so we can see. With the write, as you can imagine, write file. And we'll just say that this file will be called by.txt. Very original naming by myself. And we'll just say sad to see you go. And once again, we'll take an error. And this error will say if error console.log error. All right. So let's save that. Run the file or run the script. And look at that. By.txt just got added. If we click on it, we have sad to see you go. We just created a new text file. Very, very cool. By the way, just so you know what happens, if let's say I misspell the read file and now it's hell.txt, well, if I run this, I'll get an error, and you can see that because it errors out, I get the error message error with a lot of R's. All right, a little bit of a segue there, but just in case people were asking or you were thinking about that. All right, whew, I'm getting tired. So let's do one last one, and then I'm going to tell you exactly why this is so cool. The final one we're going to do, again, let's make some space here, is going to be the delete. So with the delete, we can do fs.onLink. I know it's the naming is a little bit off here, but onLink, and we'll say the by text. And notice that I was able to just do by.text here, but just to keep it consistent, I'll just say by text with the / before it. And with this one, again, if there's any errors, we'll just log. Oops, I forgot to do the if. Perfect. Now, let's see what happens here. And just for fun, let's just add a console.log here after it's done deleting, and we'll say inception because we're saying bye to the bye text. Mind blown. All right, let's run this. I'm going to say, and we'll comment out the write file here because we don't need to write it. We already have the bye text. Let me save. And now if you look at the bye text, let's see what happens here when I run the script. Look at that. The bye text was just removed. Inception just happened. Awesome. So that was very exciting for me. Hopefully it was for you as well. But why is this exciting? Well, because now we're able to use programming in JavaScript outside of just web browsers and outside of just building websites and servers. What we can do now with this knowledge is we can make our lives easier. You can think of cases, maybe you want to read an Excel file. And there are things that you can use using read file and using NPM modules that you can read, let's say, columns in an Excel and do some math. Or maybe you have an Excel sheet with all these emails and you want to send out an email to, let's say, 100 people on this list, but you also don't want to be caught spamming people by the Google filter saying that, hey, this account is spamming because they just sent 100 emails in 2 minutes. Well, using something like Node, you can create perhaps something that every 6 hours sends out 5 emails. Another thing you can do, if you had a robot, for example, something similar to a file system, instead of having reading from the file, you can read from the robot, maybe through wireless, maybe through wires, and get an input of some data that the robot has. Maybe it detected a cat. Well, using that input, you can do something, you can respond, maybe send you an email saying that the robot just detected a cat, and send that email out or send that output. And that's what we call input-output, where you're getting an input from another source, another machine, and then you are also outputting something for consumption. That is really, really exciting because it opens up the world where you can create tools for yourself. You can automate things. You can literally do anything that your mind can think of. And I know this is still early and you're still at the beginning of your developer career, but this is the first step into understanding how you can use programming to solve problems and make your life more efficient or maybe just a little bit more fun. So in the next video, we're going to do something fun. We're going to use what we've just learned and we're going to help Santa out on a coding challenge. I'll see you in that one. Bye-bye. Welcome back. I have a fun little challenge for you. And this challenge comes from one of my favorite programming websites on the web, and it's called Advent of Code. And Advent of Code happens every December. Programmers from all over the world, doesn't matter what language they write in, you can do these problems with any language that they want. And you're supposed to solve for 24 days until Christmas these difficult problems using code. So we're going to actually do something fun here. We have Advent of Code from 2015. I know that's a little bit old, but I really, really like this question. I think it's going to be really, really good practice. So I'm going to leave for you this challenge. And there's 2 parts to this challenge. So think of it as you need an answer to the first part and the second part. Now, I'll share the link to this challenge so you can actually read all the rules, and you can even get the input for your puzzle right here. And yeah, don't worry, that looks confusing, but once you read the question, you'll understand why that is. The exciting part is that in the next video, but make sure you don't watch it before you finish it, in the next video, I'm going to show you what I would do if I was solving this logic problem using programming. And this way, you can compare what you do versus what I do. Doesn't mean that my way is correct. There's many, many different ways to solve problems when you're programming. But as a fun little challenge, you're gonna figure out the solution to this problem using our FS module, using Node, and using JavaScript. And then I'm going to show you what I do, and we're gonna see whose code is faster. And the way we're going to compare our code is we're going to do something like this. Inside of our function, whatever that function may be, you're most likely going to read the file that they provide for you, which is this over here. Right after you do that, we're going to say console.time. And we can give it any label we want. So let's just say fun challenge. Now console.time, when we hit this line, is going to start a timer. And it's only going to end when it sees the console.log or time end. And we have to give it the same input or the label as the first time we called it. So fun challenge. Now this way, well, this is what happens if we run it. Oh, and we get a bit of an error because we're deleting this file, which we don't want to do that. Let's clear and try that one more time. Fun challenge took 0.319 milliseconds. Well, that was really, really fast because all we're doing is really console logging. But using this, let's see how fast your function solves a problem. And then I'll show you how fast my solution solves the problem. And we'll have a little bit of a competition. So I'll see you in that one. Bye-bye. All right, hopefully everybody had a chance to solve the advent of code, Santa's little puzzle that he has here. I'm going to show you now what I would do if I was reading this question, or if I was looking at this logical problem, which again is something that in interviews you get asked a lot. And in your day-to-day, when you solve complex problems, they're usually these small chunks of logical questions that are asked and you want to solve. So I'm going to go through what I would do. Doesn't mean it's the only way, but what I would do to solve these problems. All right, by now you've all read the question and what we need to do. So after reading the question, I would get my puzzle input, which I have here. I'm going to copy all of this, and right here, I have my awesome Node folder with nothing inside it. I'm just going to create a santa.txt file. And in this text file, I'll copy and paste the directions that, well, we have no idea what's going on. Let me close that. Now, reading the question, the first thing that I want to do is I want to make sure that I have a script file that I can run. All right, now before I start coding anything, everything in my head needs to make sense, and I like to keep things organized. So the very first thing I usually do is I comment and say that, from reading the question, we know that there are two parts. There's question number 1, question number 2. So we're only going to focus on the first one, which first one is what floor does Santa end up on? And the second question is, well, if we go here, the first character that causes him to enter the basement. So we want to say, when does Santa first enter the basement? All right, so now I have everything clear, and we also know that there's a few rules. The rules are that this character means that it, or not it, Santa should go up one floor. And I also know that this character is the opposite and should go down one floor. And I know this is silly, but it's really important for you to write things out and understand what you're doing and what your goals are. We know that we want to solve this question using these parameters that we get from our input, which is, well, gibberish for now. All right, so question number 1. I always like starting it off with a nice function, and we'll just say question 1. And within question 1, I'm going to do our read file. So let's go to the top here and do const fs equals require fs. All right, and we've done this before, so this should be fairly simple. It's fs read file. We're going to read the santa.txt file, and the santa.txt file will get an error or data. And within here, I'm going to ignore error for now. I'm sure it's going to work, so I'm just going to say const directions are going to be data.toString. And that in itself means that the directions variable now has the directions that we want. So let me just run that to make sure that it's all okay. And you saw over here that nothing's printed because this function was never ran. So let's do that. We're going to say question 1. Let's run it. All right. Looks like we're printing out all this information, which is exactly what we want. Those are the directions. And this is another thing. I like doing things step by step, making sure that it all works before I write everything out and then, oh, something's wrong, but I don't know what's wrong. I go one step at a time, logically talking it out in my head to make sure that it makes sense. As I'm writing this, everything flows like I'm speaking. We have the first question, we're reading file Santa, and from the Santa text, we're getting the directions. All right, so what do we want to do next? Well, we saw in the output that these, well, it's just one big string, but ideally we can split them. So if we split them, we can analyze each one by one, like an array. Maybe we can map over an array. So a sneaky way of doing this is we can just say const directions array, and this directions array will get split up into arrays by doing split and splitting it just like that. And this is just a little bit of a shorthand little trick. So again, if I console.log directions array, there you go. I have everything in an array. That's a lot of items in the array, but everything is split out individually now. All right, next step. So I have each array. So we want to read each one of these because each one equates to either up one or down one. And well, we want to map over this. We want to go over each one of them, but we're accumulating something, right? We're saying 1, then if we have 2 floors up, that's 2. If we go 1 down, that's 1. So we're adding and subtracting constantly. So in that case, we can actually do reduce. So with reduce, I can say const answer, in this case, will be directions array dot reduce. And this reduce takes the first function. So the first parameter is a function, and this function takes the accumulator. And I'll just do ACC for now, just because it's shorter. And then the second one is the current value. Let me make this smaller so you can see. And this is a function that we're going to do some stuff here, but the second parameter is what we want to start off with in the accumulator. So we're going to start off with 0. So Santa's on floor 0, on the ground floor. Within here, we can just say if current value, because reduce maps over each one of these items, and if the current value triple equals, and let's say this, which is up one floor, if that's the case, well, we can just return accumulator plus equals 1, which is shorthand for doing accumulator plus 1. So this adds 1 to the accumulator. So if the first item is this little bracket here, it's going to be 0 plus 1. So Santa's going to move up 1 level. And then we'll say else if current value equals the opposite bracket, then we do the exact opposite. And we're going to return accumulator minus equals 1. So it's going to go down 1. All right. So just out of curiosity, let's run this and see what happens. I'm going to clear and run this one time. And we get nothing because, well, we haven't said anything. So let's just console log at the end of this. We have the answer. So let's just console.log answer. And we'll say that the answer, or we'll just say floor. So if I run this again, oh, I get a bit of an error. And that's because I forgot a comma over here. Silly me. Let's run that again. Let me clear. And I get floor 280. And that's the answer. That's where Santa ends up. He ends up on floor 280 if he keeps following the direction until the very end. Very cool. So again, just out of curiosity, let's add time to figure out how long this takes. And we'll say console.time. Whoops. Whoa, my auto tab is not working well today. And we'll say Santa time. And this Santa time within this function, until we get the answer, we'll say Santa time end. If I run this, our function runs 437 milliseconds. So pretty fast because we're not doing anything too crazy. So curious what you got here. Keep in mind that this really depends on the type of the machine you're on. But again, pretty fun to think about how to structure your code. So it's, first of all, it makes sense. It runs nicely. And also, you want to make sure that it's efficient. And looking at this, we're not doing anything too inefficient. All right, let's move on to question number 2. And question number 2, let's make space for this. Question number 2 asks, when does Santa first enter the basement? So that is, well, using this loop over here, as Santa starts to get direction, when does accumulator go into the negative number? Now, I can simply copy and paste this into question number 2 and just maybe add an if statement here. Maybe I can say if accumulator equals or is less than 0, then, we can say console log the answer, and that works well. But again, thinking about the question, this reduce is going to map over everything. And you remember, this is a pretty big array that we're creating out of the directions. So if Santa on the first move goes into the basement, and then we still go through every item in the array, that's a bit of a wasted time, right? So we want to think about the problems in ways that make sense to us and are efficient. And that's something, again, that you want to practice is, does it make sense in your head? If you're supposed to do this manually, would you go step by step through everything, or would you just stop when Santa enters into the basement, into the negative number? So let's find a better way to do question number 2. Again, with question number 2, I'm going to say function question 2. And within here, we'll say fs read file once again. And this read file will read santa.text. Again, this is the same as above, so I'm just going to do this quickly. And the very first part, which is the directions and getting them into an array, that's the same. So I'm just going to go copy that. Again, getting the directions, making it into an array by splitting it. And now I'm going to add a little function that I think is better than reduce in this case. So I'm going to say the answer equals direction array dot sum. And sum, what it does is it's going to look through the array, go step by step, and if it finds something that matches, it's going to stop looping. So with directions.sum, I'm going to have the current value, and this current value, so that is the item or the bracket that we're getting. So this current value, again, we're going to do this if statement, current value and current value. We're going to add one or subtract one. So again, I copy and paste it down here, but again, we don't really have ACC in this function, and because we're not really using a reduce. But we do want to keep track of a counter to see when Santa is going to enter the basement. So outside of the function, I'm going to say let accumulator. Let me just be more descriptive this time, and we'll say 0. And this accumulator is going to get incremented based on the directions. All right, so using that, let's see what my console log answer will be. So we'll say again, basement entered at, and we'll say answer. And let me just remove question 1 for now and just run question 2. Let's run this. Basement entered at true. And we made a mistake here because what we want to do from sum is we want to return something. We want to return when a goal is met. So at the end, we're going to say return accumulator. And when the accumulator is greater than 0, remember return ends the function. We're going to say stop whatever you're doing. And then that's going to end the function, but we want to know when does Santa first enter the basement. So that is at what number of directions does Santa enter the basement. So we also need a counter. So this counter is going to be equal to 0, And I've missed a bunch of semicolons here, but that's fine. And we're going to increase the counter every time it goes through an item. And now the answer, well, not this, but the answer is going to be the counter itself. So if I do counter, save. All right, and let's run this. And I actually made a mistake here because it's still 0 because the counter is being incremented after the return statement. So current value, let's actually name this current item. It's a lot more descriptive. Current item. This is being returned before he even hits the counter. So in our case, unlike above, we don't really need the return statement. We're going to save, run, and there you go. And the answer in this case is 1,797. Awesome. So again, to test it out, let's use our Santa time to copy from above, and we'll just put it at the top for time, and at the end for time end. Let's see how fast that function runs. We have, again, quite fast, but if I did reduce, which in our case, that's what we use for the first question. So let's just go through that. We see that, well, the first round of Santa time, which is question 1, is, let me just add a Q1 in here so we can see. And Q2, I'm going to add that to make sure the labels match. Let's do that again. That's a lot better. All right, so we see that question 1 definitely runs a little longer than question 2 because the first time around we have to loop through everything. The second time around, it's a lot less time. Just for fun, again, I always like testing our assumptions. So if the first direction was to go downstairs, let's see what happens. All right, so that's a little bit faster than before. Not by a lot because we're still kind of doing a bit of calculations, but still a lot faster than going through this many items. Just in case you're wondering why, in this case, question 2 ended before question 1, and not so in the other cases. Again, remember that read file is asynchronous. Whichever one returns first gets returned. All right, hope you have fun with the challenges. If you've enjoyed this, I recommend you keep going through the Advent of Code, and hopefully as a group with our community, when December rolls around, we're all ready to follow Advent of Code for this year. I'll see you in the next one. Bye-bye.
Welcome back. In this section, we're going to continue working on our final project, the face recognition app that we've built. And we have the front end mostly done for it. But now we need a server, something that the front end can communicate with so that this app can live on more than just of our laptop. We can actually deploy it. And if you remember our app, we have a sign-in. And the sign-in also links to a register that we can register the users. And if we just had the app the way it is now, there's nothing interacting with it. Every time we log into the app, we can just create a new user, a new password, and sign in, no problem. But if we build a backend for it, we now have the ability to interact with it. We can even include a database so there's memory and we can have actual users that our backend will remember. And we'll get to the database in the next sections. But for now, we worked on Node and Express, and we should be familiar with how they work. It's fairly nice and simple, right? We're simply creating URLs and endpoints and providing a response to the front end. So that's what we're going to work on in this section. If we go back to our app, just looking at this app, we can figure out what endpoints we might want to have. We definitely want to have a sign-in endpoint. We want to have a register endpoint. And every time we log into this app, well, we'll have some sort of a profile. We want our name and our rank displayed. And ideally, this rank will change based on how many faces or how many URLs I've submitted for my profile. So here's the fun part. We actually won't be really touching the front end for the first couple of videos. Because the way you want to build an API server is you want to figure out what the functionality is that we want and test it out on something like Postman. So over the next couple of videos, we're going to be using Postman and just creating our server. And with Postman, we're going to test our server just like we did in the previous section, get all our endpoints working, and then finally we're going to connect it to our front end. It's going to be a lot of fun. Now, over here, I have renamed our front end project to SmartBrain, but that's the React app that we've been working on. And I've also created a folder called SmartBrain API. And it has absolutely nothing in it except for a package.json. So I just ran NPM init, but it's something that we're already familiar with, so I won't bore you with it. And then I've installed a couple of packages that we've used in the previous section. The Express framework, so that we can build a server really nicely. NodeMon, so we can run NodeMon in our scripts and make sure our server is running. And we also have Body Parser, which we used to parse and have access to the request.body to read JSON and form data. Other than that, well, there's no JavaScript file. So let's start off by creating a server.js. And now that we have server.js, in the scripts, we can just say that npm start. And again, it's JSON, so I got to wrap it in curly brackets. And this start will just say NodeMon server.js. And now every time we run npm start, our server will run. But we have nothing yet. So let's get our basic skeleton of our Express app. And this should be familiar to you by now. We'll just have a const express equals require the Express package. We'll then create our app by running Express. And then finally, we'll have app.listen, and we'll use port 3000. And within the listen, we can actually send it a second parameter, which is a function. And within this function, it will run right after the listen happens on port 3000. And just to make sure that everything is running smoothly, we'll just say app is running on port 3000. NodeMon kind of does this for us, but I like having it here regardless. All right, so just to test this, if I do npm start, we have NodeMon server started, app is running on port 3000, just like I've set it here. All right, so now that we have app running, let's just create a basic route to make sure that everything is working nicely. We can just create a app.get at the root route. And again, as we've done previously, this will get a request response. And in here, we'll just do a response.send. This is working. Let's save and go back to our Postman and do our localhost 3000, and we'll just do a root. And we get this is working perfectly. So now that we have this set up, I like planning our API. And this is something as a developer you really want to do. Before you just start coding, you want to make sure that you have an idea of what your API design will look like. So let's think about this. I'm going to wrap this in comments, and we can work on it one by one. We want to have a root route that perhaps for now we'll just say responds with this is working. We also want to have a sign-in route because, well, we want people to sign in. And this sign-in will most likely be a post request because we're posting some data, some JSON, the user information. And it's going to respond with either success or fail. All right, we also have a register, and the register again will be a post request because we want to add the data to the database, or in our case, a variable in our server, and with our new user information. So perhaps this one, instead of saying success fail, we will return the new created user to make sure that everything is working. And we will say that this is the new user object that will return. Okay, we also want in the home screen to have an ability to access the profile of the user. So perhaps we'll have a profile with an optional parameter of user ID so that each user has their own home screen. And this will most likely be a GET request. We just want to get the user information, and this will return us the user. And because we want to work with the ranking, or anytime a user posts a new photo, we want to make sure that their count of how many photos they've submitted goes up. And maybe we have a way to keep score, a variable that increases by 1 every time a user submits these photos, and then checks against other users to see who has submitted the most and give them a rank. Perhaps we can have a image endpoint that, again, will be a post. Or maybe in our case, because we're updating the score, it should be a put, because the user already exists, and we want to make sure that there's an update on the user profile. And this will just return the updated user object, or perhaps whatever we've updated, in our case, a count of some sort. And you also might be wondering here, with the sign-in, if we're not creating a new user, why are we doing a post? And if you remember, anytime we're sending a password, we don't really want to send it as a query string, do we? We want to send it inside of the body, ideally over HTTPS, so that it's hidden from man-in-the-middle attacks and it's secure. Looking at this might change as we go through the project, but we have an idea of what we want to create. So in the next videos, we're going to start creating these endpoints and testing them with Postman to make sure that they're working. I'll see you in the next one. Bye-bye. All right, let's start building some actual routes for our app. We have a good plan in place, and we can start implementing these based on what we know. And again, the way we're going to test these is using Postman. We don't need to worry about the front end now. We want to build our server to be working properly, and only at the end, once everything is working, we can plug it into the front end. And we can also let the front end team know, hey, these are the endpoints that we expect. And this is what we will respond with. All right, so I think it's time to get started. the very first thing we want to tackle is the sign-in. So let's think about this. I'm going to do app.post for sign-in. And when we do the sign-in route, we're going to have a request response. And here, just to test that everything's working, we'll do response.send sign in. Let's save. Go to Postman, do localhost, click send. I always like doing incremental steps to make sure that everything is working and getting those small wins every time as we're working. So I have it saying this is working. Well, that's because we did a GET request to the root instead of doing sign in and then a post. And we have cannot post sign in because apparently I can't spell. There you go. A bit of misspelling on my part. There you go. Signing. Perfect. Now I want to show you something that we're going to use moving forward. Up until now, we've done send, which can also send JSON. But Express comes with a built-in JSON method on response that we can use. And it has a bit of added features when responding with JSON, and we want to focus on using that. So from now on, I'm going to be using this. And there's a slight difference in what we receive. We receive a JSON string this way. All right, so let's think about sign in. We're not going to necessarily just say sign in and that's it. We want to check whatever the user enters on the front end. It's going to come back here in the response or in the request, and we want to check it with our current list of users to make sure that their passwords match. So it sounds like we need some sort of a database. But for now, because we haven't learned about them yet, we're going to create a variable. And this variable is going to be called database. And it will have users. And this users property will be an array of objects. And this array of objects will have ID 1, 2, 3. We'll have name John. We'll have email as john@gmail.com. We'll also have password. We'll say cookies. We will have entries, which is what we're going to use to track scores. So entries means how many times John has submitted photos for face detection. And then finally, we probably also want to keep track of when John joined our app. We can do that by doing new date, which comes with JavaScript. It will just create a date when this part gets executed. And you'll see later on how this is going to get displayed. All right, and let's create another user because we are in an array after all. And this user will be called, well, we'll have an ID of 1, 2, 4. It'll be Sally, Sally@gmail.com, and her password will be bananas. Perfect. Now, looking at this for sign in, we're going to get a request. And within this request, we're going to have, remember with sign in, we want to make sure that we use post. So we're going to have access to request.body. And it sounds like a conditional statement, doesn't it? If we do an if statement and we say request.body, well, what we're going to have on the body. Before we do this, let's go back to Postman and think about what we're going to send. When we do sign in, we're going to do a post request. In the body, remember, we're going to be sending JSON because we aren't using an HTML form. We're going to hit raw and then JSON, application JSON. And now that we have JSON here, we have this box where we can enter what we want to send with our body. Again, it'll do validation for us, and we'll say that as the sign-in form on our front end we have email, which will be, let's say we'll have john@gmail.com. So we can imagine that John is entering our website and using the sign-in route, the sign-in form, and his password will be cookies. We're going to send this information from the front end. Again, we're just pretending that John is logging in so that we have access to it here. So let's add that if statement. If request.body.email equals whatever we have in the database. So let's say database.users, and we'll just grab John's. Although we should be looping through this for now, we just want to make sure that it works. We'll grab John and we'll check against the email entry in the database. And request.body.password equals whatever we have in the database. If that works and that is true, then we'll respond with a JSON that says success. Otherwise, we can say we'll respond with a response status 400, and we'll say error logging in. All right, let's give this a go. I'm going to save. Come back here, sign in. Let's click send. And I get a bit of an error. Read property email of undefined. This is a little tricky. Why isn't it reading the email property? And I want to show you this error because it happens a lot and it's something that people forget all the time. Remember, when we're sending data from the front end and it's using JSON, well, we need to parse it because Express doesn't know what we just sent over. In order to be able to use request.body, well, we need to use body parser, don't we? So let's do that. I'm going to import body parser and require it. And if you don't have this in your project, then you'll have to NPM install it. But in all Express apps, you're going to see this. So it is one of those packages that you should never forget and pretty much every Express app comes with. In order to use this, if you remember from our previous lesson, we just do app.use because it's a middleware, and we'll do bodyparser.json. And we should do this after the app variable has been created. All right, let's save that and try that again. I'm going to click send. And we get success. Look at that. If I change this to now just say cookie, click send, I get a 400 bad request with error logging in. Let's make this a little bit bigger so you can see. How awesome is that? We got our sign-in working nicely. All right, that's pretty nice. We could do a for loop here, for each maybe, to check in case Sally registers. But that is a bit of a hassle, isn't it? Imagine if we had hundreds of users and we used a for loop in the sign-in to check against all the users and all the passwords. And this is exactly why one of the reasons that we use databases is, well, databases are really, really good at grabbing and checking against different inputs versus a variable or an array here where we have to loop through everything. So for now, because this is working, let's keep it the way it is. Let's do the next one, register. If you remember, register will be a post request And again, we'll get a request response. This request response register means a new user is going to be created. So we're not going to be doing any checks like this because the user doesn't exist. We want to grab the request.body and enter the new information into our database. In this case, we have a database object that has users and an array. So we can do database.users.push to add to this array. Let's do that. I always love starting off with what the request is going to look like. So going back here, we see that when we create a new user, if you remember the registration form, we get name, email, and password. Let's go to Postman and create those. I'm going to say post register. And here we get email, password, and also name. And we'll say that the name is Anne, her password is apples, and email will be ann@gmail.com. And we're going to be sending that through JSON. Oh, and see how it gives me an error? That's because I get a comma. Again, Postman is just awesome for this. Going back, we want to create a user like this. So let's just copy this, what we have here, and say that we want to create a new user by saying database.users.push to add to the users array. And within here, we'll add an object, which is what we just copied. But we don't want to add John again to the users, do we? No, we want to grab whatever we get from request.body. In our case, using destructuring, we can just say email, name, password from request.body. And now, on the database, we can just, for now, just statically add the ID of 125. Name will be the name that we get. Email will be email, again, that we get. And then finally, password will be what we receive. And entries will be 0 because, well, Anne will be a new user and she will start off with 0 entries. And joined will be new date because it will generate, whenever this is run, it will generate the timestamp of that day and time. Let's save this and see if this works. I go back here, click send. Oh, I get a loading and it's just spinning. I'm going to click cancel request. And you know why that is? Well, because we haven't sent a response. Express now is just hanging in there because we haven't returned anything. We haven't responded. So always remember to do that. In our case, we'll say that response.json will be the user, the new user that was created. Perhaps if they're registering, we want to grab that info and display it in the profile page. In our case, we'll say that we want to grab database.users and we want to grab the last user, which we just created. And that's simple to do. We just do database.users.length, which is the length of the array, minus 1. Again, it grabs the last array or last item in the array. Let's save here and go back, click send. All right, look at that. We have Anne with 0 entries, a new timestamp for when she registered, and now we have a new user. Let's go back to the root route here, and let's just return for now the database.users to make sure that we see what users we have. I'm going to save here, go back, and just do a GET request on the root route. If I click send, oh, I made a bit of an error here. I can't spell. Let's try that again. If I go back, click send. All right, I got John and Sally, but where's Anne? Let's go back to our request again, and Postman gives you the history of your requests, so you don't have to keep writing them. You can go back to register, look at the body, and let's send Anne again. All right, we've registered. Now if we go back to our GET request and click send, all right, Anne's there. We got 3 new users. But what just happened? Well, this is another good case for why we need a database. The reason that Anne wasn't added the first time around is because I changed the root route to include database.users, which means the NodeMon had to restart. The server had to restart and start over. And because these are JavaScript variables, every time we restart the server, this gets run all over again. So the database initiates with just the 2 users. Again, we don't really use variables to store information that we need to what we call persist, that is, to last and be memorized by the system. Databases are really, really good because they run on disk somewhere out there in the world, and they're really, really good at keeping this information and not going down. Or if they do go down, that they have backups, so that users always get added and we don't lose any information. We'll get to databases and we'll actually implement this with a database. But I want to show you right now the pain points of not having databases. We had to loop, or we would have to loop through these users if we had to check sign in, or we had to always keep in mind that whenever the server restarts, we lose all of our data. All right. Well, things are looking good. There's definitely a few things that we can improve on here, but we just want to build the skeleton. We have 2 more endpoints left, and we're going to tackle those in the next video. I'll see you in that one. Bye-bye. Welcome back. Let's finish setting up the last 2 routes in our server. We first have the profile user ID, which is a GET request. That is, we want to get the user for their homepage. Let's do that. I'm going to add another route. This time it'll just be a GET request, and it's going to accept profile and an ID. Remember that if we do it with this syntax, that means we can enter in our browser anything, and we'll be able to grab this ID through the request.params property. All right, we will again do the same thing, request response. And let's add a space here to keep things clean. And within this request response, we want to, first of all, grab the parameter ID. So let's do const ID will be coming from request.params. And what should we do here? Well, in order to get our users, we want to loop through our sample database and find the matching ID. If it matches, we want to return the user. All right, we can't avoid it any longer. We have to do a for loop here. The way we do that is we can just do database.users. Although I like using map for this case, we're just looping through the users and we don't really need to create a new array. It's just a database. And we want to keep that constant, so we'll just say for each. And if you remember, for each will run through the users one at a time. And we'll say that if user.id, which is what we'll get from the database, equals the ID that we received from the params, if that's the case, we will respond with JSON that user. We'll just send the user of the matching ID. Otherwise, we will respond with JSON, no such user. And we can even say that it's a status of 404, which means not found. All right, let's see if this works. I'm going to save. Go back to our example. Well, we know that we have 123 and 124, and because the server restarted, we won't have an. We want to grab profile 123. If we click send, I get 200. Okay, all right, we got John. If I do 124, I get no such user. If we go back here, Sally should be here. How come we're not getting her? And we see here that we get an error here. Can't set headers after they are sent. That is because we're looping through this. And instead of returning from the loop, because once we find the user ID, we don't really need to keep looping. So here we should just be sending a return response JSON. And if the user isn't found, well, we don't necessarily want to do that in the loop, do we? We want to say that for each, if this user is found, return response JSON. And we'll say that a variable found, which will default to false, will also get updated with true. And it'll have to be a let because we're reassigning it. So found will equal to true if we find it. And I know there's better ways of doing it, but again, I think this will illustrate a point. We could also do a map or a filter to see if we actually find a person with an ID. But for now, let's just do if isn't found, so the opposite of found. In that case, we'll just respond with status 400 JSON not found. Let's give that a go. All right, I get Sally. If I go 123, I get John. Perfect. And just for fun, let's register. And again, I'm going to hit send. And her ID is 125. So if I go back to profile and do 125, I get Anne. How cool is that? Awesome. So we have this endpoint working, and we have one last one, which is the image. And this one, we just wanted to update the user to increase their entries count. Every time they submit an image, we want to increase their entries. Let's do that by creating our final endpoint, which is app.post. And we'll call it image. We'll get a request response. And again, here we will have to find the ID of the user again to update their entries. In this case, we can just copy what we've done before. And anytime we need to copy some sort of a function, well, it's a good time to actually pull it out and create your own function so you can use it in both of these. But for now, let's just copy and paste. And instead of actually having params, in our case, we will receive the user's ID from the body. And now we want to say that, we want to copy this bottom part as well. we'll say that if the user ID matches, in that case, we will respond with the user dot entries. And this entries we want to actually increase. So we'll say that user dot entries plus plus. Remember, that's the short form of me doing +1 and reassigning it. So we'll just do plus plus. And now the entries of the user should increase, and then we'll respond with that. If that doesn't work, if the user wasn't found, in that case, we'll just keep it the way it is. User was not found. Let's save that and go back to Postman. We'll say image. And within this image, we will have a post request, which means a body. And we can just pass the user's ID. In our case, we'll say ID 123, which is John's ID. And we'll click send. I get 1. If I click again, I get 2, 3, 4, 5. And if I go back to the root, which returns our users, and change that to get, I get John with 5 entries and Sally with 0 entries. Let's make sure it works for Sally as well. If I do 1, 2, 4, I get now entries of 1. And going back to the get users, I get John with 5 entries and Sally with 1 entry. Amazing. We got ourselves a nice API server. It can definitely improve. There's a few things that we obviously want to change, such as sign in to not just have it for John. We have a few repetition of code that perhaps we can extract this out into a function. But I wanted us to have something working, something that we can use so that we can connect it immediately with our front end. We can finally delete our commented out section where we planned what our API is going to look like. Good job getting this far. I'll see you in the next video. Bye-bye.
Hey everyone, this is me from the future. Just letting you know that in the next video, we're going to talk about this package called Decrypt Node.js. Now, if you go to this page now in NPM, you'll get a little warning here saying that this package has been deprecated and that they recommend you use something else. You either use Decrypt or Decrypt.js. Now, both of these are implementations of something we're going to talk about, which is Decrypt. And I'll link to this resource so you can actually find out about the difference. One is in JavaScript, the other one is in C++, another programming language. However, for this project, because this is our own personal project, we're going to use Decrypt Node.js still. And the reason I do this is because Decrypt Node.js was specifically created so it works both on Mac and Linux as well as Windows. Because with the other packages, based on whatever your operating system is, you might encounter some errors. So if you want, you can use those packages, especially when you have a real-life app that stores user passwords. But in our case, I want us to use Decrypt Node.js because although it's no longer maintained, that is, it doesn't get any updates, it will guarantee that it works on all systems for this lesson. So I still recommend using Decrypt Node.js. If you want, later on, you can upgrade or change the package to Decrypt, Decrypt.js. Most of the time, these will work, but I want to avoid anybody having issues so that we can get this project ready and deployed. I'll see you in the next one. Bye-bye.
Welcome back. Security is a very, very important thing on the web. And as developers, we have a responsibility to make sure that whatever user information we get, we handle it with care in a secure fashion. And up until now, I've shown you how to do a simple sign-in setup. But I haven't really shown you a secure way of doing that. And in this video, I'm going to talk about Bcrypt Node.js. And Bcrypt is a library that is very, very powerful. It allows us to create a very secure login. Now, what does that mean? Let me show you. Up until now, we had password just in plain text. In real life, we are never, ever storing passwords as plain text like this, just like a string, into our database. This is exactly how companies get hacked and passwords get released of users when they store it like this. We want to store passwords in something called hashes. And I'll get to what that is in a second. But I want to change the database around to show you a more realistic look of how things will be stored. You see, in our database, we can have something perhaps like login. And this login will contain an array of objects that has an ID. Let's just say 987 with the hash, which will be empty for now, and then a email. And this email will just reference john@gmail.com. This is something that we'll get more into as we talk about databases. But I want to show you, I want to demonstrate this point to you. In order for us to handle the sensitive information, that is, if John, let's say, enters our site and wants to do a sign-in, he's going to give us his email plus his password, which is cookies. Now, he is trusting us with this information. And the very first thing we want to do is, well, we're definitely not going to add it as a query string in a GET request. We're going to add it to a POST request, so it's in the body of the request. We also wanted to send it over HTTPS. That is something that requires a certificate, and we're not going to get into that. But we definitely want to include it through an HTTPS request so that it's encrypted. When he sends cookies, it's going to get jumbled up, and nobody in the middle can see this. Or they'll be able to see it, but they won't understand what it means. And only the server, once it receives this password, can actually understand that this stands for cookies. All right, so one is HTTPS. The second thing is, how do we store that password? Well, we store it in a hash. And Bcrypt, the package that I was just talking about, allows us to do this. Let me just download this package and show you how it works. There you go. Now with Bcrypt installed, you can see over here that it has a few things we can use. I'm going to copy and paste this and move some of this stuff around. I'm actually going to put this at the bottom. Bcrypt gives us a way to hash a password and a way to compare passwords or hashes. But what does that mean? Let's go one by one. If I grab this function and in our sign-in, or sorry, I guess in our register, because that's when we give our password. In our register, when we run bcrypt.hash, and instead of bacon, this is what we pass as the user's password. If we pass the password here, Well, we have a couple of parameters that they give us, and these are options that we can enter. For now, we'll just leave it the way it is. If I console.log the hash that we receive in this function, so bcrypt's going to hash the password and then return this hash, we're going to just say hash. All right, so let's just see what happens here. I'm going to save. I'm going to run npm start. Going back to our Postman, if I do register with Anne, I'm going to click send. And again, bcrypt is not defined because I haven't included it here. Let's do that. Let's do const bcrypt equals require bcrypt Node.js. Let's save that and try that again. I'm going to click send. If we go back to the console, do you see that? We just got a hash. And that is what a hash function does. A hash function takes a string and jumbles it up in a way that there's no way I'm going to be able to figure out that this stands for the password cookies. And hash functions are one way. That is, you can enter cookies and you'll get this, but you'll never be able to go back. And the other quality of hash functions is that if I now do this again with password, I guess the password for Anne was apples. If I click send, I go back, I see that the hash, the first time and the second time, are different. And although hash functions actually always return the same thing for the same value, bcrypt is a little bit more secure than that and adds a bit of other magic to make sure that it's impossible to ever figure out what the password is. But now we can store this hash, this jumbled up value, in our database in here for the login. And anytime we do sign in and we want to check if the user's password match, well, now let me remove this. We have, let's go to sign in, and at the top, we can compare the hashes. So grabbing the hash that we had before, let's use this one, or let's use the latest one that we got. I will replace this. It's going to look pretty ugly, but I'm going to replace this hash with this long string, and I'm going to compare apples because that's what Anne's password is. If I compare apples to this hash, let's console.log first guess. We'll have the response again. That is what we receive after bcrypt does this. And the second time around, we'll also do a console log with the wrong password, which is veggies. And this will be the second guess. Let's go to do a sign in. It doesn't really matter what it is because we're not really worried about a response. And I get an error saying hash is not defined because I haven't updated this hash to what we just copied before. So let me do that. There you go. Let me go back, click send. If I look back here, I get first guess is true. That is, apples equals this hash that they gave us, but veggies does not equal the hash that they gave us there. Let me close that a little bit. And bcrypt is really, really powerful. We're going to use this when we actually implement a database to our registration. Using bcrypt, which is a tried and tested hashing package, we can safely store users' information, users' passwords, into our database. And nobody, even if hackers access our database, they'll have a very hard time getting the user passwords. They may be able to get their email addresses, but never our passwords. And we'll implement that in our database using Decryption. But I really want to emphasize this point because security is really important. Always send any sensitive information from the front end to the back end using HTTPS in a post body. And if you get something like a password, the way you store it into the database is using something like Decryption to generate a hash. And every time a user signs in, check that hash with whatever the user inputted. In the next part, I've left for you a security article that I wrote that may be a little bit advanced, but I think covers the best way for you to store user passwords. Something that is overlooked quite often, but again, very, very important if you want to be that top developer. I'll see you in the next one. Bye-bye. Welcome back. It's time to finally integrate our server that we just created using Node and Express to our front end, which was built with JavaScript and React. Let's start both of these servers. And I want you to think of these as two separate computers because in real life, most likely, these would be two separate computers somewhere that are running separately. And they're communicating, well, through HTTP. I'm going to run NPM start here. And with the React app, I'll run NPM start as well. And you'll notice it will probably give me a warning or a suggestion. It says something is already running on port 3000. And it even tells me exactly what's running there. And because they're both trying to run on the same port, we can just run them on different ones. So I can change my server to run on something different than 3000, which is the default for Create React app. Or I can just say, would you like to run the app on another port? I'll click W or Y, and now it will create localhost 3001 as my front end. Awesome. So we have our app here. If we go back, we have the app and the server both running, and we want to finally connect them. If you remember our diagram here, we're finally bridging the gap between the two. Two separate instances communicating together. Let's get started. As we know with our React app, in order to communicate with the backend or the outside world, we can use fetch. In our case, we can say component, and let's just do this at the top. There you go. Component did mount a lifecycle hook that comes with React, so we don't have to do arrow functions. And we'll say that here we want to fetch, and let's do localhost because this is our computer, and port 3000. We'll have to do HTTP here. Localhost 3000. And remember the syntax is doing .then. We'll get a response. And we'll have to run response.json on that. So we can read it. And then we'll get data. And a shorthand way of doing this is if you actually do console.log, the data will automatically get entered into here. So I don't have to do data equals that console log data. It's the same thing. So let's try this out and see if it works. If you remember, if we do the base root route in our server, well, the root is just getting the users from the database. Let's give that a go. I'm going to save. Not getting any errors, which is good. If I go to localhost and refresh, and open up the console, I get failed to load localhost 3000, no access control allow origin header is presented, blah, 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 blah. And this is an error that is a security feature, really. You'll get this error because with Google, what we're trying to do right now is we're trying to communicate with the outside world using HTTP, but Chrome doesn't really trust whatever we're accessing it. They have no way of knowing that our server is secure. Maybe it's some hacker that is secretly trying to make a request from your webpage to their website that downloads some bad software on your page. And that's called access control allow origin. And for us to test this out on localhost, we need to do something called CORS. And you can see over here in the error message, set the requests mode to no CORS. And I'll link to information about CORS here. But what we want here is we want an NPM package, once again, called CORS. And just like body parser, it's one of those common ones that you'll see everywhere. I'll show you exactly how to use it. You see that it's a middleware that we just simply do app.use CORS. So let's install that. I'm going to npm install CORS. And now that we have it, we can just const CORS equals require CORS and simply do app.use CORS. Let's save, run npm start again. Let's go back to our app, refresh. If I open up console, I get an array of 2 users. How awesome is that? It's working. So let's work on the sign-in. We're going to send the sign-in information from the front end to the back end. And the way we have sign-in set up right now, it's only going to check for John. I've minimized this so it's a little bit cleaner. It's going to check for John. And let's put back the password for now to cookies. And Sally's password to bananas. I'm going to save and now work on the sign-in route. All right, now that we know that fetch is working, we're going to actually try and get the sign-in endpoint to work. So let's think about this. If we go back to our sign-in page, well, this component has 2 inputs, the email and the password, that when we click sign in, we will have to send through request body. We will have to send that to the server. The server is going to check if the user exists and then give us a response. So let's do that. I'm going to remove component didmount from the app because we don't need it anymore. And although we can create our fetch function in here in the app.js, because sign-in is its own little component, and the rest of the app after sign-in doesn't really care if it succeeded or failed, I like keeping sign-in's functionality within the component. Now, what that means is that we want to turn this into a smart component so that it has state. That is the state of input of email and password. So let's do that. Let's convert this into a class sign-in, which extends React.component. And this will have a render method that receives all of this. I'm going to minimize this just so you can see it. this, oh, we forgot the bracket over here. Make sure we include that as well. Perfect. And we want to close off the bracket here. And we do receive some props, which was on route change. So we'll have to do this dot props dot on route change and this dot props dot on route change. Or instead of doing that, even nicer is to just do it here by destructuring. On route change equals this dot props. So everything should be compiling fine, and we still have the sign-in page. Now, in order to get the input values from these two, we just create an on email change function, and that will listen to the on change event of the email, and we'll say here that this event we will set state for, just so we know we're clear, we're going to say sign in email, and this will be event.target.value. And on password change, we'll have again another function that will update a state that we'll call sign in password. And we'll need to create this state. So we will do our constructor super, and then this dot state equals sign in email, which will be an empty string for now when it initializes, and sign in password, again an empty string. Now, in order for us to use props, we also want to pass props here. Let's save. And if this is working the way we expect it to, we can now create an on submit sign in event, which will now use the state to fetch. And for now, we're not really sure what we're going to fetch yet. So let's just console.log this.state.sign-in password. Or actually, let's just console log this.state. And if you're wondering, can we really have more than two smart components in an app where this has state, then app has state? Well, yeah, absolutely. You want to organize your app in a way that makes sense. For example, sign-in is its own enclosed thing. So using sign-in, even though it's a child of app, it can have its own state. As long as this state is just concerned about sign-in, then it is a good way to do this instead of constantly updating app.js and making app.js grow to many, many lines. All right, so we have console.log. Let's see if on submit sign-in works. Let's go to submit bottom. Before we do the on click to change route to home, we are now going to instead do this dot on submit sign in, and within here we will run the on route change, which is this dot props dot on route change, and let's check that out. Let's save. Go back to our app. I will open up the console here. I'll type in test@gmail.com. Test. Sign in. And I see that I get sign in email empty, sign in password empty. And that is because we've created these, but we haven't added the events onto the inputs. So let's do that. For the email on the input, I'll say on change. And you know what? Let's add these on new lines just so it's cleaner. Otherwise, it can get pretty messy. There you go. And now I can say on change, and on change will take this dot on email change because this is the email. And the next one will have a similar thing, except instead of having on email change, we'll have on password change. Let's try that out again. test@gmail.com. Test, sign in. All right, we have this information, which is great. Now we can send this to our server. And we can do that by simply on submit running a function, a fetch, which we've seen before, for HTTP, our localhost, port 3000, and doing a sign-in. Now, fetch by default does a GET request, but what we want to do here is a POST request, as we remember. So the way we do that is in the second parameter, we can pass an object here that describes what the request will be. In our case, we'll have a method of POST. It will have headers, and headers accepts an object. In our case, we want to say content type. And because it has this line here, we have to wrap it in quotes. And we'll say that it is application JSON. And now we will say that the body will contain what we have in the state. But remember, in order to send it to the backend, we can't just send a JavaScript object. We have to JSON.stringify the object. And the object is going to be email, which is this.state.email, or sign-in email. Let me copy that. And password, which will be this.state.pass. It'll be sign-in password. All right, let's see if that works. I'm going to save. And in here, I'm going to say john@gmail.com and cookies. If I click sign in, I get 404 not found. Let's debug this and see what happened. Well, first off, I did not spell sign in right, so let's try that again. And give that a go. See if that works. Oh, and we want to say cookies here. Sign in. All right, we have sign in bad request. If we look over here, we get a response error logging in. And that's the error that we gave on the server. So it looks like something in our request is not working. Let's take a look. And this had to be headers, not header. That's a mistake on my part. Let's try that again. John, let me just console it here. john@gmail.com. Cookies, sign in. All right, let's go to our network tab and see what the sign-in route responded with. It said success. So we were able to sign in because, well, we entered John, a user that we have, according to our very simple sign-in form. However, if we want to change this to now say that response status is 400, error logging in, and if that errors to not let us sign in, Well, in here, all we have to do is instead of doing on route change, we can do a .then. And remember that this .then response will have to do response.json. .then, and we'll say that the data that we receive, and we'll just keep this simple here. If data equals success, which is what we receive, in that case, well, we will do a route change. Let's save that. All right, let's give that a go. If I don't enter anything here and click sign in, I get a post bad request. And if we look at the message that we receive, we have error logging in. So using this information, we can create maybe an error display here. But it's not letting us log in. In order for us to log in, we have to use our John example and make sure that our emails and passwords match. That works. Let's try that one more time. If I do John, cookies, sign in, and everything is working. We're getting no errors. Nice, this is working. All right, so we're only just using John for the users, but ideally we can actually filter through everything and make sure that it exists. Now, as I said before, we're not going to be doing this here because this is something that databases are really, really good at. But I wanted to show you how this would work with emails and passwords matching. All right, so we have sign in working. Let's also get register to work. And register is very, very similar to sign in. So in the next video, we're going to tackle that. Welcome back. Let's implement more routes into our front-end app. We've just done the sign in on the front end. So now let's also work on the register. And we already have a nice framework of what we want to do based on what we did with sign in. We can again convert this to a class that extends React.component. And this will render this return statement and we also want to have a couple of routes that for now we're just going to completely copy from sign in. And here we'll just have, for registration, we can say email, password, and then finally also name. And we'll have to add another method here that will be just for the name. And this will be called on name change. And we'll have to change the values to name, email, and password. Awesome. We'll save that and we'll have to actually start adding these to our component. The first thing we want to do is we want to use destructuring to get our component or our on route change from this.props. And let's add on password change on all the other inputs. Again, creating these on a new line. Whew, All right. And again, we want to create a fetch method here. So looking at sign in, we definitely want to do a post. So we can just copy this for now. Again, not a big fan of copying and repetition of code, but I hope this gives you an idea of some of the things we can improve on as we improve our app later on. Now on submit sign in, again, we will want to do this instead of the on route change. So let's do on, and we'll have to do this dot on submit sign in. And I forgot this keyword in all of these as well. All right. Now I see that we're missing the email from here. That shouldn't be there. All right. And we will want to make sure we send the email to this.state.email. We'll do password. And finally, we'll do this.state.name. And on route change, we don't need it over here anymore, do we? On route change, we want to go to home once we're registered. But remember, if we go to our server, our register returns the last user, so our current user. This data will be the user. So let's just say user. So if we get a user back, we will route change to home. And we also probably want to update the user profile on the front end. But if you look at the front end, we don't have a user profile yet, but maybe we should. So let's add that. I'm going to say user, and it's going to be an object that contains email, which is an empty string. And we can just copy whatever we get returned from our database. In our case, it'll be all these values. We don't need the email because we have it down there, except everything will be empty to start off. And we don't need to return the password. So email is removed. Entries will be 0 for now, and joined will just be an empty string. Ideally, when we register, we can update these. So what we can do with register is that we will have a route change, but perhaps also call a function called update user or load user, which we don't have yet. And we can perhaps pass the user object to this. And because this is something that the entire app needs, I think we should build it in the app component. So we'll say this.props.loadUser, and we'll go back to app.js and create that function. We'll say load user, and it will just update the state with the user that we received. In our case, it'll be these values. And all these values will come from the user parameter. And let's just change the name here just so we don't get confused to data for now. Data.id. We'll have name here. We'll have email. Entries. And then finally, joined. Oh, and I have the syntax here a little bit off. There you go. All right, if we go back to register, we have on route change, saved successfully. So we're loading the user and then also changing the route. That was a lot of work without testing the code, so let's check it out. Let's see if this works. I'm going to go to register. I doubt this works the first time, but let's see. Wes at gmail.com. Oh, that's the name. So we'll say Wes at gmail.com, and password is 123. I'm going to open up the console here just to see what kind of errors we get. I doubt that it works the first time, but we'll see. Register. All right, we have a couple of errors here. Load user is not a function. And that is because if we go to app.js, load user is never passed into register. So let's do that. Register will also receive load user like this. And it'll have to be this .load user. All right, round 2. Let's see if this works. One, two, three. All right, we're able to sign in, but we have a bad request. Let's see. Our information looks good, email, name, password. And the response we got was error logging in. And that's because if we go back to our register page, well, we didn't change this to register, did we? That's silly of us. We changed that to register, save. I'm gonna get tired of writing Wes's information here. And register. All right, no errors. Let's see what the response was of register. We get the response. Wes is user 125. Password is 123. Entries is 0 and joined on this day. Again, we don't really want the password. We shouldn't really be returning the password. But that's an easy fix. We just simply remove it from the server.js. How cool is that? We have our self-registration. And if we actually go back to just a root route, or if we go to localhost, let's go on this side over here, and just go to the root route, we refreshed again, so Wes is not there, but if we register again, this is exactly why we cannot wait to have a database. Let's try that again. And look at that. We have Wes as our user. Very cool. And now there's a bit of repetition, right? We just pretty much fetch in order to connect with our server, and both parties want to make sure that they send the right data and the server responds with the right data. There's definitely a lot of cleanup that we can do, a lot of errors that can happen. For example, if I entered a invalid email and password or username. But I think you're starting to get the point. All right, I'll see you in the next one. Bye-bye. Now, if we look at profile/ID, well, this isn't really useful for going to home, is it? Because once we sign in, we have our user information. And perhaps profile/ID will be useful for us to grab our profile and perhaps update our name or our email. That's something that perhaps we can incorporate into our app in the future. But the one I really want to focus on is this. Our last route, which is image, which allows us to increment the number of our entries. So let's work on that in this video. Every time we submit on the front end, we want the user to hit this route so that we can increase their entries count. Let's give that a go. If we go back to our React app, we can go into our app.js and we have our clarify API. That's when we do on button submit. And this is specific to that home screen of ours. Looking at this then, what we would want to do is if clarify gives us a response, in that case, on top of displaying and calculating, as long as we have a response, in that case, we would want to fetch the local host route at 3000, and this time run image. This is a post request. So in order to do a post request, and actually let's do this as a put request. I think that's what we planned on initially, and because we're updating the user's information, put will be a better use of it. But it will work both ways. It's just a way for us to keep with the standards that put is the way to update things. And a put request works the same way as we've done before. Instead of putting the method post, we will actually have the method as put. Again, same thing, application JSON as our content type. And we want to send within the body, well, do we request any information? The only thing that the put request needs is ID. So let's do that. We will just send ID, which we have of the user when they sign in. And that is this .state.user.id. Let's see if that works. I'm going to save. Go back to our app, sign in as our best friend by now, John. I'll click sign in. And let's find a face again. Do this face this time, view image. If I go to here and I click detect, I get the face, but our current rank isn't updated. And if you remember, our rank is more of the entries. So let's change the wording there so it doesn't confuse us. Your current entry count is, and we want to update the entries. If we go back here, once we send this, we want to say that, again, .then, we'll get a response. And this response will go through the motions of running JSON. And finally, we'll say count will now have to be updated by using set state users ID or entries to the count number. Let's try that again. Going to sign in as John. Cookies. Let's copy and paste that face again. Detect. Let's look at the console. Let's just go through the network and see what we had. I see that the image, the payload that I receive is 1, 2, 3. When we look at the response, we have 2. All right, so it looks like everything is working. We've sent this twice, but it hasn't been updated. Let's look at our, oh, and we want to make sure that it's user, not users. And let's try that again. We have john@gmail.com, and it'll be cookies. If I click sign in, all right, your current count is 3. If I add another picture, look at that. I get your current entry count is 4. But you see how the name gets changed to undefined? Well, it's because the way we have it here, you see how this.setState just changes the entire user object? That's not good, is it? Because we need to make sure that user is still the same, but we're just updating the user object. Now, the way to get around this, because like I said before, we're just changing the user object, we can use something called object.assign. And you can read up on it. It's part of the JavaScript spec. But you get the target object. In our case, it's this.state.user. And the second parameter is what you want to extend it with. In our case, it's the entries and count. If we do it like this and save, and let's do john@gmail.com, cookies, sign in. We had to restart the server, so now it's at 0. But if I add a picture, look at that. John, your current entry count is 1. And there you go. The name doesn't change. So we can sign out, we can register, we can sign in. We have our endpoints working. And using this, you can imagine how you can expand your app. You can add a delete, for example, to profile/ID to delete your account. You can add a put method to update your account. There's many things that we can do. But I hope you saw the power of the server and the front end finally connecting through fetch to create some real functionality. I'll see you in the next one. Bye-bye. All companies store data. From a simple record book of a small business, maybe even on a journal or a piece of paper, to massive companies like Amazon that need computers to store petabytes of data. Now, in order to store this information, pretty much every company, and sometimes individuals too, need something called a database. We saw in the last section how hard it was to have our server remember a new user. Every time the server crashed, the variable would get reset and then it would start all over. Or if we wanted to do a login or a sign-in check and iterate through the emails and passwords, doing a loop through JavaScript, that's inefficient. That's where database come to the rescue. So let's ask ourselves, what is a database? A database is a collection of data. And what we mean by data, there are many forms of them, right? There can be numbers, there can be dates, there could be password hashes, there could be user information. Databases allow us to organize this data in a way that is useful to us. And it makes data management easy. And something came out of that. And it's called Database Management System, or DBMS for short. It's a collection of programs which allows us to access databases and work with data. And it also allows control access to database users. So a DBMS is something in this box. Something that allows us, a tool, a piece of software that allows us to communicate with the database, store information that's useful for us, and also allows us to update, insert, delete, look up whatever is in the database. And this idea of a DBMS really started to take shape in 1960s. And now it is at the forefront of many exciting things. There's an entire industry of engineers that just work with databases because it is so important. Now, there are two types of DBMS that are really popular right now and that we're going to talk about in this course. And these two types are represented really well by Postgres and MongoDB. Let's talk about the first one, which is relational database. And this is probably the most popular. As you can see on the right-hand side, you see that all of these are relational databases. Postgres, Oracle, SQL Server, you may have heard of MySQL, SQLite. These are all types of databases that have this relational database tag to them. And the beauty with them is that they're all pretty much similar. They all follow a same standard format. Relational databases consist of two or more tables with columns and rows. So in this case, users is a table, and full name, username, text created at are columns, and whatever values they have here are rows. Each row represents an entry, and each column sorts a very specific type of information, like name, address, or phone numbers. And then the relation between tables and fields is called a schema. In a relational database, the schema must be clearly defined before any information can be added. And if this is confusing right now, don't worry, we're actually going to create these databases so it makes sense to you. If we had Twitter, for example, you can see over here the types of tables that we would have and how we would organize it. We would have a users table, a tweets table, a following table. And we can connect all these information, for example, by connecting different pieces of the table. For example, the username will be the same in the users table as it is in the tweets table. That way, we can say that the username in the tweets table is the foreign key of the username in the users table. And then from user will be the foreign key of username in the following table. Now, things like full name or ID, something that identifies each row in a table, is called a primary key. And we'll go through that later on in this section. All right, so all these databases, we're going to learn about PostgreSQL, but they're all pretty much the same. So once you know one, it's fairly easy to pick up the other ones. How do they actually communicate with a server, with the backend? Well, all relational databases use something called SQL. And SQL allows us to communicate, just like HTTP did, between the front end and the back end. With SQL, we're able to communicate with the database and modify or get or update however we want. And we'll have a video on this topic as well. All right, so that's relational databases. What about the second type? The second type is called a non-relational database or a NoSQL database. And once again, there are many, many different types of databases with some cool names like CouchDB and Hypertable. Now, a MongoDB or a non-relational database lets you build an application without having to define the schema first, unlike a relational database. If we go back to relational database, this schema or these tables have to kind of be predefined, right? We need to know how our app is going to look, make these tables so that once the app is public, we can start entering user information and tweets and followers. With a NoSQL or non-relational database, we can just define it as we go. And they all have different ways of storing this information. So each one is very, very different. And this is another powerful reason to use a non-relational database is that if your data requirements aren't clear at the outset of your project, and maybe you have a massive amount of unstructured data, you may not have the luxury of developing a relational database with a clearly defined schema. They offer instead a greater flexibility in that a non-relational database are more like folders, just assembling related information of all types. Now, MongoDB is something called document-oriented. It stores information as documents. Let me illustrate this point to you. I have my desktop here with two folders. One is a relational database, and here I have users, tweets, profile, following. And you can think of relational databases with this type of storage, where this folder lives somewhere on a computer that stores this information. And anytime we need to ask a database for something, well, we grab the users. And if we also want to grab the tweets of the user, we find the user that we're interested in, then find the tweets of the user that we're also interested in with the foreign key that links to the users. And we can also find however many followers that user has. We grab that information and display it on our web app. MongoDB, on the other hand, will actually have each user as a document. So if I wanted to grab the first user, well, I just grab this document and it has all the followers, the tweets, the profile, everything is in this one document. And you might be thinking, MongoDB looks like a better choice than having this way of doing things, right? Well, it depends on your need. And that's why databases is such a complex topic. It really depends on your situation. You can see this MongoDB way being very useful if you had something like a profile, maybe a LinkedIn profile. But if you needed something where you're working with just following data or just tweets data, maybe with the tweets, you want to see what is the average tweet size. Well, it's really easy to just grab this file and calculate that versus this way where you might have to extract it from each one of the users. So it really depends on your needs. Let me show you another diagram that might be useful. When we look at relational versus non-relational databases, you can think of relational as each table has a blog post, a blog tag, a blog comment, and it links these tables to give you the blog information. Versus a non-relational that stores this entire blog post in an entry and has comments, tags, categories, and all other related data just in one single place. So what does MongoDB use to communicate? If we go back to our example here, we had SQL for relational databases such as Postgres. Well, MongoDB has its own what we call query language. And it is just the MongoDB query language. But they both aim to do the same thing. That is to communicate with the database, provide an easy way for the server to communicate with the database. And in this section, we're going to be talking about that. And we're going to finally connect the dots and show you the power of databases once they're connected to a server. I'll see you in the next one. Bye-bye. Welcome back. We're going to start setting up Postgres on our computer so that just like we did with servers and front end, we're going to have a terminal that's running our front end and a back end that is running our server, but also another terminal that is running a database. Because as you remember, these are just computers running somewhere. In the same way that we ran our server on our computer, we can also run our database on our computer. And in this video, we're going to get us set up with Postgres. Now, MongoDB has gotten popular. However, nothing beats a relational database for really developing your knowledge of databases. Once you understand relational databases, it gives you really good tools and mental models to work with MongoDB. MongoDB is very simple. You can think of it as a JSON data structure where we just have JSON that looks like an object and we store that information there. With SQL and relational databases, it's more complex than that. So if you understand this, you are miles ahead when it comes to understanding databases. So we're going to be focusing on that because the principles are still the same for MongoDB. All right, so let's get Postgres set up on our computer. The first thing we want to do is download something called a GUI, so a graphical user interface, for Postgres. And this exists for pretty much any database out there. I like pSQL because it's free. It's really, really good for Mac, and it's very light and simple. I'll also make sure to add notes on how to download something like this and Postgres in general if you're using a Windows machine. But otherwise, just click on the download link. It'll be completely fast. Just open it up and you'll have something like this that I'm going to be using throughout the course. But there's many, many options. You can take a look for it. You just search for Postgres SQL GUI. And once you have pSQL installed, you'll have it in your application folder and you can follow along. Now let's go back to the terminal. In order to have Postgres installed, there's many, many ways. And again, I'll provide some notes on how you can do it. But the best way, especially on Mac, is to use Brew, which we've already talked about. Every time you do something with Homebrew, again, it's a way to download packages from the internet on your terminal. You always want to make sure that you do a Brew update to make sure that everything is updated. And also a Brew Doctor, which just makes sure everything is working on your system. Let's clear that. Perfect. Once you have that set up, we're going to just say brew install Postgres SQL. And this will install for us Postgres. And you see over here that I already have Postgres installed, but if it's your first time, it'll run through the commands and then actually at the end tell you exactly how to start using it. But in our case, I'll just tell you. It'll be much easier. To start Postgres, you need to do brew services start Postgres. And don't worry, this isn't Postgres specific. Any database that you're downloading, you're essentially downloading the software, and then you want to start the service. Each one has its own commands, but it's as simple as Googling and figuring out how to run the database. So we've started Postgres SQL. It looks like I've already started the service. And just to show you, if I actually do stop here, it will stop the Postgres service. And let's do start again. And you can see that it's starting. Now, in order for us to use Postgres, we need to create a database. And the way we do that is to use the create DB command that has come once we've installed Postgres. And here we can call it whatever we want. So let's call it test. It's going to create the DB, and there you go. Here's the cool part. If I go back to my pSQL, open this up, let me close this. I have over here pSQL, and it asks for the host, which is the link to where the database is located. In my case, it's located at my local host, right? It's running on my computer. So you want it to be localhost, and the port number, this is the default port number of 5432. Remember how we had port 3000 and 3001 for the front end and back end? It's similar to that. It's opening up a port for it to listen to the database. And this is the standard port for Postgres that you'll see. So when I did the started Postgres and create DB, the default of 5432 was already set. I can actually set what port and change it up, but we want to keep everything standard, so we'll keep it the way it is. If I now go to the database and we called it test, so again, we'll do test database, hit connect. All right, we're connected to the database, but there's not much in here, is there? But at least we know that we're connected to localhost test. And another way to connect to this, remember this is a GUI, a graphical user interface. And I'm showing you this because it's really good for demo purposes, but I want you to get comfortable working with the terminal as well. In order to do the same thing we just did with the GUI, we can type in PSQL, again, which is a command that we'll get when we install Postgres. And we'll say which database we want to connect to. In our case, it'll be the test. And there you go. Just like when we run Node and it changes terminals, now we're inside of Postgres that's running on our computer. But we don't know any commands yet, do we? So in the next video, we're going to learn some SQL commands and finally create some tables in our Postgres database. I'll see you in that one. Bye-bye. All right, so let's create a table. If you remember to go to our Postgres database, we simply write PSQL and then our database name, and we'll enter the database. And now we can communicate with it using SQL. Now let's create a table. How can we do that? Again, SQL comes with some language syntax that we can use. And to create a table, we can use something like this. We say create table, which is an SQL command. We enter a table name, followed by brackets. And then we say what we want the column 1 to say with the data type, column 2 with the data type, column 3 with the data type, and then ending it with semicolon. Let me just press enter and see what happens here. I get an error. Data type does not exist. And that is because data type is referring to what Postgres or our relational database knows. We have to say ahead of time what type of data column 1, column 2, and column 3 hold. If we go back to our Chrome browser, we see that for Postgres, we have a few data types that we can hold. String data types, numeric data types, and date and time data types. And each one of them have different things. For a numeric data type, we have integer, which is a 4-byte integer. We have big int, which allows for a bigger number. And all these different things, we have even money, which is currency value. And the reason we have to give this data type is because of the way databases work. They're optimized to make sure that as long as everything is the same in their column, they're able to work really, really fast to perform actions. In our case, let's use some of the most common ones. We can use text for the first column. So let's do that. I'm going to press the up arrow and get create table. I'm also going to name this table. Let's call it users. And column 1 will be name. Data type can be text. Column 2, we can say that is age. And data type for an age, well, if we look down here, we look at numeric types, we want to use something like small int, which is a 2-byte signed integer. It means that a max for a small int, if I go to small int max, we see that the max range is 32,762. Well, nobody's going to be that old, right? So we can use small int for now. Let's do that. I'm going to say age is small int. And finally, the third column will just have birthday. And birthday can be a date data type. And we can just have date. Let's press enter. And I get create table. Let's look at our PSQL here. I'm going to minimize this. And if I click refresh here, I see that we have users. Look at that. And we have columns for the table users, that is name, age, birthday. It tells us the type and the length. So now we have our table. Awesome. There's also a way to do it here. If we do \d, I get list of relations. And look at that. We have our users table and the owner, which is me. Very cool. There you go. We've created our first table. Now that we have this, we can start entering some information. And by the way, you might be asking, how many times do we run these commands? Well, ideally, once you create your database and it lives somewhere on a computer, somewhere in the world, you only run this once, right? You create a table of what you want your database to look like, and the rest is just filling in and inserting information and reading information off of it. So this is the command that we're going to set up when we create our own database to set up our schemas. And then after that, it will just run on its own and it will be able to communicate with the backend. It's going to be very fun. By the way, before we get into the next video, I want to show you one more command. We learned the /d shows us our tables. If I do /q, we exit out of here and we're back to the terminal. All right, I'll see you in the next one. Bye-bye. Welcome back. Let's go back into our database. We've just created our users table, but now we want to actually insert some information. How can we do that? Again, using SQL, we have the insert into command that we're able to insert into whichever table name we want. We're going to specify the column and then the values of each of those respective columns, and always ending in a semicolon. I also want to emphasize that with SQL, the capitalization is just a standard, but if I made this lowercase, it will still work. It's case insensitive. So looking at our database, we have name, age, and birthday. Let's insert something. We'll say that we want to insert into users. Column 1 will be name. And then we have age, birthday. And no, you don't have to insert every time into every column. You can just change the name if you want. All right, name will be Andre. Value will be 31. And then birthday we'll say is, if you remember the day syntax, if I open up here, is this, year, month, day. So I simply do 19. I'm going to make myself really old. We'll say January 25th. Press enter. I get insert. Awesome. If I do /d again, I see my table. But how can I see the value that I just entered? Well, first let's check here. Let's check with our GUI. Click on content, select users, and look at that. Name, age, birthday. I have Andre, 31, with my birthday. Very cool. Now, how can we grab this information? Again, a SQL syntax is select, and we want to say what we want to select. In our case, we can say name, age, birthday, from, and then the table name. In our case, users. Semicolon, press enter, and look at that. I get Andre, age 31, birthday. If I want to just grab the entire columns without spelling out everything, imagine if we had tons of columns, we can use the wildcard symbol of star. That's Shift 8 to get star, and I get the same thing. Very cool. By the way, with PSQL, we can actually run these queries here. See how it already has select? I can say select star from users, and it even gives me nice coloring. Press enter or press semicolon and run query. And look at that. It gives me the table for me. And it also has the history, which is really, really nice. Let's add a few more users here. I'm going to insert, this time, somebody else. I'm just going to change a few things. 41 and Sally. Inserted. If I select star from users, I have Andre and Sally. Going back here, run query, I have Andre and Sally in the database. How cool is that? All right, we know how to create a table, we know how to insert into a table, and we know how to grab this information. We can already start picturing what powers we can have now with our final project. But there's still a few more things we want to learn. For that, I'll see you in the next video. Bye-bye. Welcome back. I've added one more user here, so we have a little bit of a bigger database. But let's say we have a problem. We realized that we're working on this project and, oops, we actually needed to also include a score column. How can we add another column to a pre-existing table? We have SQL for that. We can use alter table. And using this format, we can add a new column. So let's say that in the users table, we want to add a column that is score, and data type, we want, let's say, small int, a score that can be over 30,000. So let's say max score is 1,000, so small int will be fine. I press enter, and now we have altered table. If I refresh here, go to users, I see that I have scores. But we have a problem now. We have scores, but it's null. There's nothing for these users. What if we wanted to just update the information here to include the scores? Let's try and do that. To update, we have the update table name. Oh, and we have 3 rows, which we don't want, but for now, I just want to show you. We have update table name. And then we want to say set whichever column we want to equal a value where the column equals some value. That looks confusing, doesn't it? Let me show you what I mean. I can say update users, and in the users, I want to set score column to equal, what do we want it to equal? Let's say that we want Andre to have a score of 50. We can say update users, set score 50, where, which is another keyword, name equals Andre. It reads pretty nicely, right? Update users, set the score to 50 if the column name is Andre. Looks like we got an update. If I now do select star from users, I see that I have Andre with score 50. And you know what? We also want to update Sally and John. But they both have the same score of, let's say, 100. How can we do that? We can say update users, set score to 100, where name equals John. But also, we can say and name equals Sally. If I press enter, I get an update. If I go up to select users, you see that I did not get an update. And that is because and, just like we did in JavaScript, means that name should equal John and Sally. And we don't have that. It should be Sally or John, right? So we can just press up to get our all command and change this to or. We have 2 updates that just happened. And if I look up users, look at that. I have Sally and John with score 100 and Andre with 50. Looking at our GUI, if I refresh, look at that. We have our table with our new scores. Very cool. A few more commands that I want to show you in the next video. So I'll see you in that one. Bye-bye. Welcome back. While you're gone, Amy just joined our user base with a score of 88. Perfect. Now, let's learn a few more SQL commands that are useful. What if I wanted to grab all users with names starting with A? With SQL, it's super fast and super easy. We can simply say select all from users where name, and this is a new one we're learning, like. And like allows us to add a condition. In our case, we can say A and then the percentage sign, which means anything after A. If I click semicolon and enter, look at that. I get Andre and Amy. Let's try this on our GUI as well and show you what we can do. If I go over here, just copy and paste this. And if I change this to lowercase and run query, well, I don't get anything because it has to be uppercase, right? We're searching for A. There you go. Although with SQL, our commands can be lowercase or uppercase, when we do searches, we want to make sure that the case matters. And that is why mostly when we store information in databases, we want to make sure that there's some consistency. So when we save these information, such as inserting, maybe in the server, we lowercase everything so that we don't have this issue. What if I wanted to do all names ending in Y? If I do percentage Y, run query, I get Sally and Amy. Amazing. Okay, what if I want to do something different? Let's say I want to get everything sorted in order, maybe from the highest score to the lowest score. Well, we can select all from users, and we can order by the column we want to order by. In our case, it'll be the score. And if we want to do ascending or descending, let's do descending first. Oh, and I spelled descending wrong. It's DESC. Press enter. And look at that. I have Sally and John as the top score. If I do ascending, ASC, I get low score, Andre. I'm not doing too well in this game. Very cool. Are you starting to see the power of SQL? Remember all the looping that we would have had to do if we had usernames? SQL is really, really good at grabbing this information. You saw how fast this is. Even if this was hundreds of lines, it'll be really good at grabbing information, updating information, maybe ordering it. It is extremely powerful. Pretty much since the 1960s, it's been just the language of choice for databases because it's so good. All right, awesome. We're starting to learn more and more. A few more to go. I'll see you in the next one. Bye-bye. Welcome back. Now, SQL can also have functions. And I'm going to show you 3 of the most popular, most common ones in this video. Just to check what we have in our table, well, we have users. And if I do select star users, oh, I forgot to use from, we have our users. Now, let's say we wanted to get the average score of the users. We can do that by saying select average and give the column name inside of average. Let's say score from users table. So you can see that our function, just like in JavaScript, has the function name and then the brackets around the column that we want. Let's press enter. And look at that. Average is 84.5. Very cool. What other functions do we have? Let's say we wanted to get the sum of everybody's age. I can invoke the sum function and find out that we have an accumulated sum of 132. And then finally, there's also count, another useful one. And if we want to find out how many users we have in our database, we can just say count name. And we have 4 active users with our game. All right, we got to work on that to increase that number. Perfect. There's a few more functions that you can use, but these are probably the most common. You can already imagine some of the power that comes with these values. I'll see you in the next one. Bye-bye. Welcome back. Now we've gone over a few SQL commands and you should feel pretty comfortable with most of them. But there's one thing that I've kind of omitted until now. You remember here when we spoke about relational databases, I mentioned something about a primary key and a foreign key. How these tables are linked with one another with some values, like username. Well, we're going to start introducing this idea of connecting the tables and how we can do that. The first thing I want to show you is this command right here. I want to create a login table with create table, which we've seen. And now within here, I have a few things. I have an ID that has data type serial. Let's look at what that is. We see that the data type serial is an auto-incrementing integer value. Okay. And this auto-incremented value, every time a new user is created, it'll go 1, 2, 3, 4, 5. So it's a unique ID that we can assign to each user. However, this is for the login table. So that is, we're creating an ID for each login entry here. And you see that it says not null. Not null means that this, well, has to be a filled in property. Remember when we had the users table and we didn't have the scores and we had null here? Well, if we do not null, that means that that's not possible. And then we also have primary key. And setting primary keys when you're creating a table is one of the most important things. By saying that the ID here is the primary key, it's saying that this is what I want you to access when I'm looking for things. And databases are really, really good when you set a primary key to grab this information. And as you know, primary keys are only one per table, usually something like an ID or something unique like an email. By setting this as primary key, we now have a really, really fast way of selecting or grabbing information. If we look at the second value here, the second column, we have secret, which is a variable character of 100. Let's look at what that data type is. For the string data type, variable character has a size. And we can say the numeric characters to store. So we're saying that the secret value, in our case, this will be the hash, will not be greater than 100. And it also is not null. That is, this always has to be filled when we're inserting something into this table. Otherwise, it's going to fail. And then we have name, which will be text that we've used before, but it also has to be unique. And the unique keyword says that if a name already exists, well, then we can't insert into it. So let's run this command and see what happens. Let's refresh. We have the login table now with ID, secret, and name. Let's enter some information in here. I'm going to say insert into login. We don't need to now insert anything in the ID because that's actually done for us. Because it's serial, it'll just automatically increment. But for the secret, we can say that secret will be a hash and the name will be some sort of a text. Let's format this a little bit. Values, and we'll say some sort of a string. We'll just say ABC here. And the name will be Andre. Let's run the query. Let's go back to the login, refresh, go to login, and we see that Andre has been inserted with ID of 1. If I go back to the query and add a different person, let's do Sally, and her password is XYZ. Run the query, and now she should be in there. And you also notice that her ID is now 2. What if I enter this again? I get an error. Duplicate key value. Violates unique constraint, login name key. Because we've said that we want unique for name. Very cool. Let's enter the last one. And this will be John. Because that's what we have in our users table. So we have John, perfect. And if we go to login, we also have John with his secret, which is LOL. And notice here that it's 4 instead of 3 because we ran a command, but we failed to do this. But it doesn't really matter because as long as these are unique, these are the primary keys. This is the one thing that we make sure that is unique at all times in our table. But by doing this, we've created something interesting. We have Andre, Sally, and John that also live with Andre, Sally, and John in the users table. When we design databases like this, we can now have Andre, Sally, and John referencing the users. And if I wanted to grab Andre or Andre's secret, which is ABC, in that case, I have a foreign key, which is this. This name column in the login is the foreign key that references the, in our case, the primary key here, because these are the unique identifying values in the users table, that is Andre. In the next video, I'm going to show you how we can finally connect these two together. I'll see you in that one. Bye-bye. Welcome back. In the previous video, we've created a login table. Now that we have these two tables together, I want to show you the real power of relational databases. Going back to our drawing, the most important part of relational databases is this idea of schemas, of having tables that are just concerned about storing information specific to them, such as users, tweets, and following, and connecting them through a primary key and a foreign key. I'm going to show you how to do that. Well, we've already done it, but how do we grab information from it? If we go back to our table, we remember that we ran our query we've created the create login table here, and we created a name variable that, when we planned this, was going to match whatever the users table had. And we can use something called joins now with our queries. And this is a new word in SQL and probably one of the most powerful. Because we don't necessarily want to have one massive table with hundreds of columns, hundreds of rows. Databases aren't designed to just have, just like an Excel sheet, tons of rows and columns and have all that information in one place, because it's not efficient. It'll be a lot slower. It'll be really, really hard to manage. And the bigger and bigger your company grows, it's going to be really, really tough. A good way to design a database is to have these small little tables that are just concerned, just like separation of concerns, concerned with their minimal needed information. And if something else is needed, we can just join tables together to grab information. Let me show you what I mean. We have over here our test database. And let's do /d to see. All right, we have 3 files here. We have the login and users, which we created, but what is the login ID sequence? Remember how we created a primary key? The way relational databases work is when you create a primary key, it creates another file that contains this primary key. And you can see that the type is sequence. Now, this is a file that most likely we won't access, but internally, Postgres is going to make sure, because we set this primary key, it's going to be really, really fast to grab data from the login table when we request it. But let's say I wanted to get information from login and users. Perhaps I want to get Sally's information, but I need her birthday, score, age, as well as her secret. By using joins, we can do this. I can say select star, so everything, from users. And now if I do join, I can say another table name that I want to join with the users, in our case, login. And we have to say on, what are we going to join it on? How is it going to know what matches with login? Because if I go back here, how's the database going to know that I want to match the first line with Andre, the second line with Sally, the third line with John? The on keyword allows us to make sure that we match on something. In our case, it's the name, the primary key here, and the foreign key here. So let's do that. On users.name equals login.name. Semicolon, let's do that. And look at that. We have name, age, birthday, score, but also ID, secret, and name all together. We've just joined these values and they all match because we've done login.name and user.name. And with joins come great power now. We can have small little tables based on what we actually need. And anytime something specific is needed, we just join tables, and you can do multiple tables, multiple joins, in order to select the information that we need. All right, I think we've done a really, really good job understanding SQL and the power of relational databases. I'll see you in the next one, and good job getting this far. Bye-bye. Welcome back. Now, we have our tables here, but what if we wanted to delete something? Let's say Sally decides to, let's try that again. Let's say Sally wants to just not be part of this app anymore, and she's going to remove her user. Well, she can send a request, and on the back end, we can simply do delete the table name, users, and then we say, which user? Well, we can use the where keyword, and here say name equals Sally. If I press enter, oh, and with delete, we actually have to do delete from. So delete from users where name equals Sally, and we have one delete. If I do select star from users, there you go. Sally's gone. All right, I think we're done with this example. Let's delete these tables. How can we do that? We can just drop table and say login. Login has been removed. And then drop table users. If I look at what tables we have no relations, no tables. All right. Good job getting this far. I'll see you in the next video. Bye-bye. Welcome back. I am so excited for this section because we're finally combining everything we know into one place. By the end of this, we have a unified understanding of how everything works in the world of web development. We have our front end, SmartBrain here, with the sign-in page. And we have our app built in React. We also have our server running on port 3000, listening to requests. But now we don't need this database anymore. We can create our own Postgres database now and have the server interacting with it through SQL, updating everything, and then responding through Express back to the front end. It's going to be so much fun. I'm so excited. But before we actually start to code anything, we have to design our database. Let's create a database, and we'll call it SmartBrain. All right, perfect. Now that we have our database created, I want you to think of these three separate things as their own individual computers that when we deploy is going to be different parts. We have our server living on a computer. We have our database living on a computer, and we can actually connect here to it. And we also have our app in a separate computer as well. So let's close this quickly and connect to our database, to our local host, and we called it SmartBrain. Click connect, and there you go. But no tables yet. To get started, as we did when we created our API design for our server, we really want to think about how our database would look. And we're using relational database here because, in my opinion, and in moving forward, relational databases are really, really good. Although databases like MongoDB are really easy to get started with and they're dynamic, you don't have to think too much about when you're starting off. I think relational databases offer a really strong way to think about how your app should be structured and how everything and all the pieces come together. It's a really, really powerful tool that I see the industry shifting back to more and more. Whether you use Postgres or MySQL or SQLite, all these databases are pretty much the same. They're super powerful, and we're going to do the exact same thing with our app because we're not necessarily storing information like LinkedIn or Facebook where everything is a document model. We have users that are interacting with each other, but within our app, we can have different things. We can have login information. If we expand our app, we can have maybe information about the type of images that they've submitted. Now, looking at what we've built, there's definitely a few things that we want to create. If we go back to our database example here, we have our users table, which we're going to have to create. But remember what I said about passwords and the way we store passwords. We don't necessarily want to create a user object or a user table with all these columns. We want to separate things out and connect them through foreign keys. So we're going to create a users table and then a login table and have those tables connected through perhaps the email field. Let's go back to our GUI and create these tables now. I'm going to open up the query. Let's remove this from now, our old query, and let's create our users table. As you remember, it's create table users. I have brackets around here just so it's clean. And within here, I'll say ID is going to be serial, and this will be our primary key. We will also have name, and the name will give it a variable character of 100. We'll just assume that nobody's name is going to be more than 100 characters, which, again, I don't think we will. Otherwise, our database will give us an error. We can also create an email field, and this will be a text. We also want to make sure that this is a unique email. Otherwise, we don't want to register the same user over and over. And it cannot be null. It must always be there, because this is what we're going to use in our login table. We also know that we want entries. And the entries can really be quite a big number. If we have a really dedicated user, well, then that person can keep submitting those photos. So let's just do a large int here. Oops, and instead of large, it's big int. There you go. With big int, we will also say that we want the default, and this might be new for us, but default value should be 0. Unless we somehow insert with entries and a number, if we don't specify what we're inserting the number with, it should be default to 0. Finally, we also want to get the time that they joined our app, and we can use a timestamp data type for that. And again, we want to make sure that this is not null either. All right, let's run this and see if it works. And I get an error at or near, and that's because I added a comma at the end here. Let's try that again. There you go. If I refresh, we have our users table. Amazing. So we have the users table, which we're going to store all this information. And we also want to make sure that we store our login information, the email and the hashes. Because remember, we're never storing plain text passwords. Let's create that. I'm going to go back to the query, remove this and change it to login. And this login will now have an ID, once again, of serial. And the serial data type will just increment. It'll be a primary key. And we'll have a column hash that has a variable character of 100 once again, because we know that bcrypt always gives us a certain length hash and it'll never be over 100 characters. Not null. We absolutely need this information. And then finally email, which will be the same as the users table. And this email will be a text. It must be unique and definitely not null. Let's run the query and refresh. All right, we got ourselves our tables design. So now that we have these tables, we understand what our data is going to look like. This is going to be a database that will persist no matter if the server goes down. It's going to make sure that this data stays put. Now that we have these 3 pieces running, we can start to work with the server, remove the database variable, and actually connect to our database. I'm excited to show you how we're going to do that in the next video. Bye-bye. Welcome back. Let's connect our database to our server. And in order to do that, there's tons of tools. As you might have known, yes, we're using NPM again, a node package that allows us to connect to a database. There's many options, and in this video, we're going to work with my favorite, connects.js. It works with Postgres, MS SQL, MySQL, MariaDB, SQLite, Oracle, pretty much any relational database Connects works with, and is super simple to use. I absolutely love it, and you're going to love it too. Just to show you there's different options, there's something like PG Promise here that, again, is very popular. And you can see it here that it's very easy. You just import it and do .any and do your SQL statement. And you can pick whichever one you want. Although PG Promise really allows you to write simple SQL queries, Connects is just a really good tool that if you're ever working on a project, I would recommend. So I'm going to use Connect.js to do it. And if you go into installation and Node.js, of course, they have good documentation of how to install it. In our case, we can just npm install Connects. I'm just going to stop the server for now and run npm install. Let's open up the package.json file, make sure that it's working. There's Connects. And they also say that we need to install the Postgres or whichever database we want. In our case, we want Postgres. So we're going to npm install PG. All right, we have Postgres installed as well. Amazing. Again, the reason that I love this library is it makes things so simple. You can see over here that in their document, it tells you exactly what you need to do to connect to the database. So let's copy this. Go to our server.js. Let's import by doing const connects equals require connects. And in here, we'll just copy and paste. And we can remove the variable and just use it like that. Now, this syntax might be confusing to you, but all it's doing is, if we remove this, it's just doing connects and running the connects function that we just had. So let's just keep it like that because it looks better. We want to update our client to Postgres. So again, if we do Postgres, it'll be PG because that's what we just downloaded. And then we have to tell it where this database lives. And we would modify this according to where we set up our database on a hosted platform. But for now, we have localhost. And localhost is the same thing as this number. 127.0.0.1 is home. There's a funny t-shirt that I saw a developer wear once that says, there's no place like 127.0.0.1 because it means localhost. And it was a play on there's no place like home. I thought it was funny. Anyway, this is the same thing as localhost, so we'll just keep it like that. And we have our user. In our case, if you remember, and we go to our database, the user, I guess, will be me. So I'll just do my name. There's no password to our database, so we can just leave it blank. There's actually no user either, but for now, it's fine. And the database, if you remember, is called SmartBrain. Now, if I actually exit this and start over, you see that it's the same thing that we're entering here. We're just saying where the host is, the user, password, and database. And because we were able to log in here without the user and password, well, we don't really need that information. Let's give that a go. I'm going to save, do NPM start. All right, I'm not getting any errors here, which is good. Let's go back to the page here. And copy and paste just a simple, maybe select statement to make sure that everything is working. If we go back to the left-hand side over here, we have the query builder and select. So let's just grab something from our database, even though we don't really have anything. You see that we just have connects.select and then whatever we want to select from the database. All right, let's do that. Let's do connects.select star from users database. I'm going to save. And I get an error, which is good. It's reading here, but it says unexpected token because, well, I have to wrap this as a string. Let's try that again. And you see here how I get connect select is not a function because here I have to assign this to a variable. And the way we do that is we can just say const database equals, just like we had before, connects.select. But let's just do Postgres for now. Save and change this to Postgres. Let's save. And now there's no errors. That's awesome. If we perhaps console.log now and save. All right, we get a ton of information here, but it looks like it's responding with something. That's perfect. It looks like we're connected to the SmartBrain, but this isn't exactly how we return information from connects. And we'll get into that into the next video. But for now, we've connected our server to our database. I'll see you in the next one. Bye-bye. Welcome back. We left off in the last video with this console log of the connects query that we just did. Now, this on the right here is what connects does. It builds our SQL statement for us. So what we just console logged was the query statement that Postgres or connects created for Postgres. You can see over here that the builder is an object that has all the information we need to speak with the SmartBrain and do this query. If I actually want to access something from the users, I will have to do our friend.then, because this returns a promise and we get our response. In our case, it'll be data. This data, again, we don't have to do JSON because we're not sending it through HTTP. We get back a data, and if we just console log this data, let's see what we get. Save, and go down, and it's an empty array. That's a good sign. We don't have any users yet, but we're getting a response. So let's do that. Let's create a statement to insert users when they register. I'm going to change this into the DB variable, just so it doesn't get confusing, and we'll just keep that as database. All right, let's go to the register endpoint, and I'm going to minimize this database because we're going to stop using it and delete it afterwards. And if we go to register, we see that now instead of doing the database.users.push in the variable, we can just use connects. We can remove this and do db dot. Well, we'll have to insert, right? Let's look at the connects docs and see, and we see clear methods, insert. All right, look at this great documentation. We can just find out exactly what we need. In order to insert something, we have the insert method with the data and what we want to, what is going to get returned. We can just copy and paste this. Okay, so we can just do db into users. We want to insert, and it just reads so nicely. I love connects. We want to insert an object, and this object is going to contain whatever we had in the user's information. So we want to insert an email, in which case it will be email. We have the name, which again is the name that we receive from the body. We also have the password, but remember in our table, we don't have the password under the users. So we'll leave that blank. And if we go back to our table example here and connect back to here, we see that users ID is automatically generated, name, email, entries defaults to 0, so we don't have to enter anything. And joined is the date that they've joined. So let's just do joined, new, date. And once we insert, let's just do a .then console.log to see what we get back. I'm going to save. We don't get any errors, which is good. And we can go back to our app. Actually, just because it's faster, instead of doing register through here, we're going to open up Postman. And Postman already has all our previous commands here, which I love. So let's click on the register endpoint with the body of Anne, apples, Anne. Let's click send. All right, we get a response, but remember, we never changed the response. But if we go back to the server, we get result, insert. All right, it looks like it worked. If we go back to the database and do select star from users, how cool is that? We have Anne, who has been entered as our very first user with default entries of 0. Amazing. It's like magic. How simple was it to just use connects and Postgres and create our first database? All right, in the next video, we're going to work on this response. I'll see you in that one. Bye-bye. Let's look at what we just did in the previous video. We've made our database communicate with the server, and we've registered our first user, which was Anne. But now we want to respond to the front end with this new user, Anne. So how can we do that? Well, if this is success, in which case we want to do a .then, which we have here. If we get a response, in that case, we want to send a response.json, and this response.json will respond with, well, what should it respond with? Luckily for us, Connects, again, is built with this in mind and has a feature that is, or a method that is called returning. So instead of us doing another select statement and grabbing Anne, we can just say returning all. So this says that users insert Anne and return all the columns. Let's see if that works. If that works, I can just place the response here. Let's check it out. Going to save, open up Postman. I'm going to add a new user. We'll just say Anne with an E. Hit send. Look at that. I get an array that is Anne. Amazing. Looks like it's working. If I go back to the database and do select star from users, there's 2 users. But the one that I received is just Anne. Let's create a new user. I'm going to create John. Cookies. We'll remember this guy. Click send. We get John. Amazing. Let's check with the front end to see that this actually works. If I go back here, let's just change this into user, just so it's more descriptive. So we're returning the user. But we also want to make sure that it's not an array and we're returning the object. So we'll just do user, the first one. Because when we register a user, there should only be one. And we also want to make sure that if in case there's an error, we respond with a response.json error. Or perhaps we can even do a status 400. Let's give that a go. Oh, and this should be, catch. Let's say that again, to catch any errors that might happen here. If I go back here and try to register with the same John, I get, look at that, an error. And we see that key email John already exists. This is an important point here. We get a 400 error, but we are returning information about our database. We now know that in this database, John already exists. And one of the big security principles is you want to make sure that you don't give the client any information about your system. And this is not good. So perhaps instead of returning the error, we can just say unable to join or unable to register. If we save, send again, unable to register 400 bad request. Amazing. Let's see if that actually works with our front end now. I go back to my app, click on register, and let's register with a completely new user. We'll do Amy. Email will be theamy@gmail.com. Password 123. Password 123. Register. Amy, your current entry count is 0. How cool is that? And just to make sure that Amy got registered, if we go back to our database and I do select, or I can just press up because we've done this before, I have Amy in my database. So cool. So we've done the register, everything looks pretty nice. There's a few more endpoints to fix, so let's do that. I'll see you in the next one. Bye-bye. Let's use connects to finish up some of our other routes. If we go to profile/ID, we don't really use this yet on our app. It's something for future development. This is a good example because sometimes backend engineers develop endpoints that might not be used for the front end, but they might need in future installations, such as this one where maybe we might have a profile page for each one of our user, and they can edit this. And maybe they can have a post, a delete, a put. So let's work on this. With profile.id, we just want to grab the user. That's a very simple operation with our database, right? We can simply remove this now and say db.select everything, because we want everything from the users table from the users table. Seems a little too easy, right? Let's see if that works. I'll do a dot then. We'll return the user. And let's just console.log, again, just to test everything out. We'll console log user. Let's go to profile/ID. And remember, if we go back to our database, we have ID 1236. So let's just do ID 1. Using our postman, we will grab a profile. Let's see if we have one of these here. There you go. There's a GET request. And we'll do profile 1, send. And if we go back to the console, all right, we're getting all our users. But remember, with profile ID, we want to make sure that it is the ID and not every single user that we're grabbing. So we can simply say dot where, and within the where clause, if we go back to connects, and I want to demonstrate to you here that this is what a developer does. They don't know every single spec of a library or a package. You simply get really good at reading documentation and seeing what you need, such as here, where, and we pass in an object of what we want to check against. So first name test, last name user. In our case, we want a object where ID is the ID that we received in the params. If we save and run this again through Postgres, go back to our example, and look at that. We have an. And we want to grab the array of the user, so we can just do, and we can just do 0. Amazing. Just to keep this short, again, with the ES6, we can do just this, because both the ID, the property, and the value are the same. I'm going to save. And now, instead of console logging, we'll do response.json. User. I'll be the user that we get. And we don't need the found anymore, do we? Let's clean up the code now. And if this is a not found, well, in that case, we will get an empty array. But let's just see what we get with our response first, and then we'll touch the error case. We'll save, go back to Postman, we'll send, and we get an error. Found is not defined, and we should comment this out. We'll try that again. Click send. All right, we get an. This is so cool. And if we do 2, we get Anne with an E. If we do 6, we have Amy. And if I do 3, I get John. What if I do a number that doesn't exist? I get 200 OK with no response because, well, we don't have that user. But let's just console log and see if we get back a user from this. If I save and send, I get an empty array. So it's still returning something. It's just telling me that there's no user. If I do a dot catch here, let me just fix the alignment here. And I do the error with JSON or response.status 400. And we'll just do not found. If I save this and go back to Postman, click send again with the wrong ID, I still get 200 OK, not the error that we catch. Because in JavaScript, if I open up the Chrome, again, trick of JavaScript, if I do Boolean array, an empty array, it's technically true. So the way we want to check against an empty array, well, we simply say if user.length exists, in that case, it will be greater than 1 or equal to 1. We'll respond with the user. Otherwise, we'll respond with our status, not found. And maybe we can also in here say error getting user. If we save now and go back to, let's remove console because we don't need it anymore. Go back to Postman, click send, not found, that's awesome. We get a 400 bad request, but if we grab somebody that we want, it's now working. Very cool. We can now remove this ugly code. We have much better syntax here now. And we also have the register done. We'll leave the sign in till the end, but let's work on the image endpoint in the next one. I'll see you in that one. Bye-bye. Welcome back. Let's work on the image endpoint here. And given what we've done so far, we can pretty much be sure that we won't be needing any of this. We're going to connect it to the database. Now, the image endpoint, if you remember, updates the entries and increases the count. So all we have to do is update. And let's look at connects and see if they have the update function. Yep, they do, and they give us good examples of how to do it. So let's use this as an example to create our update function. We'll just copy it here. And we know that with our db.where, we want to say that where the ID equals, and it's not 3 equals because this is SQL, where the ID equals the ID that we received in the body, then we want to update the entries to be higher than the entries that is currently there. But how can we do that? How can we grab the entries from the database and increase it? Again, this is a problem that's very common. And instead of selecting the ID, grabbing whatever the entries is, and updating it, well, we can simply use something called increment. And increment just tells us the column and the amount we want to increment it by. Very cool. Let's do that. Let's say that user ID, instead of update, we'll just do increment. And we'll do entries. And we just want it by 1. And the default is 1, I'm pretty sure, but I always like being explicit so that people know what's going on when they read the code. And let's do that. So we increment by 1. And then we want to say returning the entries. Let's do a .then and see what we get. Console.log entries. And let's save. Go back to Postman. Let's find our image endpoint that has a body of ID. And we'll have to give it an ID that actually exists. for now. So let's just do 1, send. And going back here, we don't get anything because, well, we need to do a put request. Remember, we changed it to put. We send again, and it's hanging because we haven't given it a response, so we'll just cancel the request for now. But if we go back to the server, well, we can see that there's a bit of an error here. And we definitely made a silly error here. It has no idea what database we're talking about. We need to actually say users here. The SQL error sometimes can be really confusing, but like I said, it is pretty declarative. So as long as you can read it and understand it, with connects, errors are to a minimal, unless you're like me and you forget to actually mention the table. Let's try that again. Send. We're going to cancel the request because there's no response. But now I have 1 returned. If I send it again, cancel the request, I have 2. If I go back to the database and I select all, I see that Anne now has entries of 2. Amazing. So we can go back here now, knowing that this works. Let's say that entries, we want to again return the first array because we get 1. And instead of console logging, we'll say response.json entries. But if something fails, then we will do a .catch, just like we failed over here. And we can say that error response.status, we'll give it another 400. And we'll say JSON unable to get count or entries. We will save that. And I'm going to actually remove this to make sure that the error is working. So it should return me a 400. Let's try that again. Send. Unable to get entries. 400 request. But if I fix this to users and select Anne again, I get 3. Awesome. All right, we got our image endpoint working, and we have our final endpoint to work on, which is sign in. That's for the next video. I'll see you in that one. Bye-bye. Welcome back. We have our final endpoint sign in, where we're finally able to sign in users. Now, there might be something that you have realized when we were working on register. That is, we're inserting the user with email, name, and joined, but we're never updating our login table. If I do select star from login, well, we have nothing there. That's not good, is it? We want to create something every time a new user logs in and actually capture their passwords or the hash of their passwords. So let's work on that in this video. In order for us to do this, we first need to register a user and grab their passwords. Now, for us to do this, we need to insert into another database. But first, let's use bcrypt to hash the password that we get. If you remember, we already have bcrypt installed, and it's from a previous video. We can go back to the bcrypt Node.js package, and although I've shown you the asynchronous way of doing things, we're going to do the synchronous one because it's simpler. Just keep in mind that with synchronous, it means that as this is working, JavaScript is not going to get executed on the next line. Versus with asynchronous, if you run bcrypt hash, JavaScript keeps executing, and then when this returns, it'll come back here. This way is just a little bit cleaner for now, so we'll use this code example. We will copy this, go to our register, and in here, we don't want to compare yet, we just want to store. So we can say const hash, we want to bcrypt the password. So let's change this to password. And now that we have the password hash, we need to make sure that we update the users as well as the login table, so that we don't have an issue like this, where we have these users, but if we go to the login, well, we have absolutely nothing. So to avoid this, we have an important concept of transactions. And transactions are these code blocks that we can add to make sure that when we're doing multiple operations on a database, if one fails, then they all fail. If for some reason I can't enter something in the users table, but I can in login, as long as it's wrapped around a transaction, they both fail so that I never have these inconsistencies. Let me show you how to do that. With the users table, I want to have this part. I'm going to indent it a little bit. And before we do the users, I want to create a transaction. I'm going to say db.transaction. And now we have a transaction in connects. And if we go to the connects, they have transactions, and you can read about them here. And SQL has transaction as well. If we go back, this transaction gets a TRX parameter that we can now use instead of the DB to make sure that whatever we do is a transaction. The first transaction we want to do is that we want to insert into the users or into the login the hash and the email. So we can say hash email or hash that we just received from bcrypt, and then email, which we just got from request.body. Instead of just doing this syntax, which we can do as well, we can do into login, and then finally returning the email of the user. Now that we have this returned, we can say .then email, because we're returning the email. And just to keep it separate from the request.body, we'll say that this is the login email. And this login email will now be used in here. So we can just copy and paste this into here. Just make sure the spacing is right. And we can use the login email after we've updated the login table to update the login email. So we didn't really change anything. The only thing we did was this block, we moved it inside a .then so that we first update the login table. We get the login email. And in order to make sure that these are both part of the transaction, instead of doing DB here, we have the TRX object. So we will do TRX. And let's save and see what happens. I'm going to go back to our example here, our nodemon. We have register with John. If I click send, all right, I get ID 11 John. I get email. If I go into the login, I don't have login here. If I go into users, I don't have John either. So something must have gone wrong. The last thing we want to do is at the end, and you can read about these in the connects section, we can do .then trx commit, because we weren't able to send these because we didn't say that if all these pass, then commit, send this transaction through. And if I do .catch, I'll do trx roll back. So now let's give this a go. I'm going to click send. I get a response. If I go to users, I have John. And if I go to login, I have John with the hash. The only thing that's wrong here is that I have this syntax for the email, which is not what we want. That's a simple fix because we're giving the login email here. Remember, we're returning an array. So if I go like this, let's do John 1, send. Go to our example of login. That looks good. And login or users, we have john1@gmail.com. Amazing. So this transaction is probably the trickiest part to get used to. And you can see here it is a little bit. But once you get the syntax, it becomes very easy. You create a transaction when you have to do more than two things at once. And you use this TRX object instead of the DB now to do these operations. In my case, I inserted into login. It returned the email. And then we use the login email to also return another TRX transaction to insert into the users and respond it with JSON. And then in order for this to get added, we have to make sure that we commit. And then in case anything fails, we roll back the changes. If I enter the same user again, I get unable to register. If I send the wrong information, I'll get unable to register. Perfect. Now that we have this working, we can finally go to our sign-in. We are containing the hash now into our table. And all we need to do now is, well, let's remove this. And in the sign-in, we can do a DB. We'll do a select. We'll select email and hash from login. Then we'll get the email and hash. So let's get response, or in this case, let's just do data. And let's just console log to see what we receive. I'm going to save, go to sign in. Let's see if we still have something. There you go. Let's do sign in body, John cookies. If I send this, I'm not responding with anything, so it hangs. But if I go back, I see that I get email and hash, and I receive everything because, well, I haven't selected any specific criteria. We can say that now we want to do the where clause, where email equals the request.body.email. If that's the case, let's save and try again. Send. We got a syntax error because we don't need an object here. There you go. Let's try that again. Click send. This will hang, so we'll cancel. And there you go. We have John's email and hash. And now we need to check to see if John put in the right password. So within data here, we can grab the array, which is the first one, and now use bcrypt. And remember, with bcrypt, we have compare sync. We can simply say bcrypt.compareSync with whatever the user entered, in this case, request.body.password, with the hash. In our case, we can just say data 0.hash. If this returns true, well, let's just have a const is valid. In that case, let's make this a little bit smaller so you can see. We'll say if is valid. This will return true or false. We'll do a response.json with the user information. So we'll have to do a db.select star from users dot where email equals to request.body.email. Then we'll get the user. And finally, within here, we can move this to response.json user array, the first item. And if there's some issue getting that, then we'll say .catch error response.json, or we'll do status again 400 JSON unable to get user. And also down here, because we're still doing the database search right here, and this doesn't need to be a transaction because, well, we're just checking. We're not modifying any of the database items. Within here, we can say .catch. If there's an error, we can just respond .status 400. This time we can say wrong credentials. All right, let's give that a go. I'm going to save. No errors here. If I go back to Postman, I'll click John Cookies, send. I get a 200 OK, but I didn't receive a user. So let's console log here. Oh, and this is a simple error. We always want to make sure that we're returning this so that this database knows about it. We always want to make sure we're returning. Let's try that again. I'm going to send with the right information with password cookies. All right, I get 200, but let's do a console log here. Is valid. We'll save and see what we get here. We're going to send. Okay, is valid is running. And then users is 0. So we're not grabbing the users properly. Let's see why. And that is because our email for John, remember we made a mistake of not returning it properly. So let's register a new user and make sure that they have the right password. We'll go back to register. We'll register with Eddie. Password will be hello, and his name will be Eddie. We'll click send. Perfect. And now if we sign in with Eddie, we don't need to send the name, just the password. If we click send, all right, we got 200. Looks like it's working. But if Eddie enters the wrong password, all right, this is still hanging because we never stated if this is false, what should happen. In our case, we want to say response.status 400.json wrong credentials. Oh, and make sure that I do an else statement here and put that up here. Let's save. Click send. Wrong credentials. But if I click hello, I get Eddie. That is awesome. We have our entire sign-in flow working. We can remove the console logs here. And now that we have everything working, we have our users, our new Eddie user, and he's also part of the login. With the hash, we're storing everything securely because in our database, we never store Eddie's password. And we finally have our routes working. In the next video, we're finally going to test all this out with our front end, and hopefully everything works. Oh, and looks like we won't need this database anymore. Good job, everybody. I'll see you in the next one. Bye-bye. Welcome back. It's the moment of truth. We've set up our database, we've connected it to the server, and now we should have our front end working. We might have a little bit of cleanup that we need to do, but let's test everything out. I'm going to create a new user. And this new user, well, first of all, since she doesn't exist, let's test it out. I shouldn't be able to sign in. I'm going to call her Yolanda at gmail.com. Her password will be trees. I sign in. And I get an error. Failed to load resources. But I shouldn't be able to sign in, right? So let's go to the front end and fix this issue. In the app.js, when we sign in, we see that we're grabbing the sign in, and if we get a response, we then load the users with that response. And you might remember, if we go back to our server, that with sign in, if anything fails, I give back JSON. And JSON, well, technically that's a piece of string that we're going to have, and that will be true. In our case, we can just check that there's a users.id. So we can just check that the user has an ID. All right, let's give that a go. I'll sign in with Yolanda at gmail.com, and we'll do hello as her password. Nope, it doesn't let me sign in. And I can display an error message here, but for now, that's working. So let's register Yolanda. Click register, Yolanda. We'll have Yolanda at gmail.com. We'll have hello as her password. Click register. All right, Yolanda, your current entry count is 0. Let's find a face that Yolanda can use. And we can use this face. We'll press it in here. It's detecting the face. That's awesome. Yolanda, your current entry count is 1. Let's sign out. And now if we go to sign in and do Yolanda at gmail.com and get hello, I click sign in. That is awesome. If I sign out, and let's enter a wrong password for Yolanda. If I do Yolanda at gibberish, it doesn't let me sign in. If we look at the console, we have the server responded with 400. Awesome. So we have everything working as we wanted to. Let's just submit the same image all over again. And look at that. Current entry count is 2. Amazing. We have our app working. Good job getting this far. So excited that we got this to work. I'll see you in the next one. Bye-bye. Welcome back. I want to just take a second to say good job getting this far. I know it's not easy just following a voice and a screen, and that requires a lot of motivation. So again, thank you for sticking in there. I really hope that you've learned a lot in this, and you're excited to learn even more. You see, we're able to start from just simple HTML to building our database and connecting it to a server and creating this beautiful app that you can now see how much potential we have. We can really expand this to do so many things. And that is why being a developer is so amazing. You literally have the power to do anything you want. Whatever you want to build, there's a way. And I hope you really got that. Now, this app of ours, there really is a lot that can be improved. There's a ton of things that we can clean up, a lot of validation that we'll need to fix, and some optimizations. But following somebody on a project can get pretty daunting. So I want to hear from you. I want to hear what you want to see next, how we would like to improve this app. Maybe you want to create sessions so that if I come back to this app, I don't have to log in every single time. Maybe you want to just expand on this and create a user profile so that we can update and delete users. Let me know what you think you want to do in this course, because I want this to be fluid. I want you to learn things that you're actually interested in. So let me know, and I will keep working on this app with whatever new features you want to add. But again, good job. You've gotten this far. Boy, it definitely took me a long time to record these videos, and I'm glad that we got here as well. But there's so much more to learn. I'll see you in the next one. Bye-bye.
Let's talk about deployment. And I want to look at a diagram here to just give us a high-level overview and truly understand what we're trying to do. Now, up until now, in this course, we've learned about front-end code, back-end code, about databases. But now that we have to put something online, not just on our computers, but to the whole world, how do we go about actually deploying something to production properly so that our apps can become real businesses? Well, let's review what we know. We know that we can write front-end code. That is, we use HTML for text, we use CSS for the visuals, and we use JavaScript to create logic and add behavior to our front-end apps. With our SmartBrain app, we used Create React app that allowed us to use JavaScript to manipulate the DOM, HTML, to add different information on the screen, and use CSS to style the app. So we have those files. Then we learned about Node.js. We used Node and Express to create our server. And what does the server do? Well, the server allows us to interact with our front end. So whenever a user logs in or a user submits a picture, our JavaScript code on the front end, our React app, is going to send an HTTP request to our server, to our Node app. Hey, the user just signed in. Hey, the user just submitted an image. And our Node server either logs us into our app or sends the image information to clarify, to get the response back and then send it to the front end. And we also created our database, right? We needed a place to persist our information. If a user comes back after 5 days, we need to have a way for us to store that information, for them to sign in with their password and email. And we couldn't just leave that on our Node server, because if the Node server ever crashed or turned off or stopped, well, that information would be gone. We needed a database to store that information and to access that information in an efficient way. So we've created these three things ourselves: our front-end code, our back-end code, and we also wrote some SQL statements to create our database so that we can connect using the connects library to our database and use those commands to store information into our Postgres server. But here's the thing. How do we deploy these things? I mean, up until now, we saw GitHub pages, right? We're able to put our websites, such as our startup landing page, on GitHub pages for free. And GitHub pages allowed us to just simply serve the HTML and CSS and JavaScript code. We also saw how to deploy our React apps using create React app. We had to have a bit more configuration with React to serve our JavaScript, HTML, and CSS files, but we're able to deploy it. But our SmartBrain app now has more than just front-end code. It has server code. It has database code. So how do we deploy that? And this is what this section is all about. What we're going to do is, well, we're going to use Heroku to have another server. And this is what you'll see in most apps. You'll usually have your server code, that is your backend code like Node, on a computer dedicated as the server. And you can use things like Heroku. You can use AWS, Google Cloud, Microsoft Azure, DigitalOcean, Linode. There's lots of services out there that essentially give you computers. Remember, a server is simply a computer. And we put our Node files on this computer, we run the Node file, and the server is going to be running the entire time, just waiting to hear from the outside world until somebody pings us, makes an HTTP request, and we do something with it. So we're going to deploy our Node code to Heroku. And Heroku is going to give us, for free, a computer somewhere in the world that we can put our Node.js files to, our backend code, and it's going to wait for us to be able to ping it whenever we want. Now, we could leave our front-end code, our SmartBrain app, on GitHub pages. That totally works. But we're also going to put our front-end code on another Heroku server as well, just to practice, just to show you how it works, even though you could leave it on GitHub pages. And then finally, we're also going to show you how to create a database, not just on your computer. Remember, for production and deployment, our goal is to move our code from our computers to computers that are dedicated to just being alive, staying alive so that whenever users go on our app, whether it's 3 o'clock in the morning, whether it's midnight, they can always access the app. We don't have to keep our computers turned on. And on Heroku, we're also going to create a dedicated database. Now, a database is, again, just like a server, is just a computer. But usually when you deploy, you want a dedicated database server that focuses on just running the database software. In our case, our Postgres software is going to be running on a Heroku server. So Heroku is going to provide all three of these things for us. But I use Heroku just because it's a simple one to use. But you can do different things. You can have your database on Amazon's AWS. You can have your front-end code on GitHub pages. You can have your Node server on Heroku or DigitalOcean. When it comes to production and deployment, it's a whole nother ballgame. It's usually called DevOps. And where you want to deploy things is really dependent on the situation. But I hope this diagram makes it pretty easy to understand. All we're doing is moving the code we just wrote from our computers to dedicated computers that are going to make sure our code is always going to be running so that anybody in the world can access our SmartBrain app wherever they are and whatever time it is. Let's get into it.
Welcome back. In this video, I want to do something called code review, and specifically for the front end of our application. A code review is something that you want to do every once in a while when you're working with your code base, because it can always be improved. It's never perfect. And the project we've been working on is pretty good, but there's minor adjustments that we could make. So in this video, I want to go through a simple code review process to show you how we can improve the app so that you can take this code base and expand it and make it even better on your own. Let me show you a bug that we have. If I create a new user, Mike, and Mike has an email and password. Now, if I log in with Mike, and I have a sample face here that we can use. If I enter this face, I get my face detection, which is great. But when I sign out now and I register with a new user, let's call him Wes. Well, we never clear the state of the front-end application. So Wes now somehow sees what Mike submitted. So let's fix this. If we go to our front-end application and let's open up app.js, we have the on-route change that gets called right over here when we sign out. And when we sign out, all we do is set state to is signed in false. But if we look at our state, we never clear out the user object, do we? The user object, which at the beginning was Mike, stays the same. And when we come logging back in as Wes, this has Mike's information. So we can do something interesting here. We can just create an initial state. So outside of the app, we'll call it initial state. And this initial state will have this entire object. So that this dot state will be initial state. All right. And we can now simply use this variable to change on route change. When we sign out, we want to remove all the information. So instead of doing set state is signed in to false, we can just say that we want to set state to initial state. Let's see if that works. I'm going to save. Go back to our application. And let's log in as Mike again. And we'll grab this face again. Face is detected. If we sign out now and sign in as Wes, we get an error. Bad request. Oh, and that's because I misspelled his name. Let's try that again. Sign in. All right. There you go. We have Wes now with a clear profile and he doesn't know what Mike has been up to. All right. We managed to fix a bug, which is great. What else can we do with this code base? Well, there's a lot of things that I think we can clean up. For example, it's always important to have a catch statement every time you do some sort of a fetch. We see that we're using fetch, but we never catch if for some reason this fetch response to localhost image ever fails. The only thing we catch is we catch if the clarify API fails, but a good practice is to always have a dot catch after you do any dot then. So we can do something simple like a catch console.log to log out any errors we have. And that's something that will improve our what we call error handling to make sure that we don't have errors that happen without us knowing. So that's one thing we can improve. We also have the register and sign-in components. If you remember, those are very, very similar. We did a lot of copy and pasting. And the only thing that was really different with them was these input values. The register form has an extra field, which is name. And the sign-in, well, just add email and password. And we won't get into it into this video because it is pretty simple. And there's many ways of doing it. But we can imagine maybe having a shared component, maybe we'll call it form, and this form accepts different props like input types so that we can set and share that component between sign in and register so we don't have this duplicate code base. All right, awesome. So that's something that we can do with our front end, just improve some of our errors and some of the duplication of code. We can probably even put this into a container component so that app.js, app.css, and app.test.js are all in a container component. But overall, the front end looks pretty nice and clean, pretty simple. As we expand the app, we can always move components and make them smaller and smaller if we want, so we want to reuse them. We already talked about how we can break down the sign in and register component. Maybe inside the image link form, if we go to that component, we can divide up the input and the button so that we can reuse it somewhere. But for an app of this size, I think this is a good enough place to leave this application. So let's move on to the backend and see how we can improve the backend. You remember here our API, which is connected to a database, and we have our 4 simple routes. And we've kept this a little bit messy. We've had everything in just one file, server.js. But ideally, in a large project, you don't have just one single file that contains everything. Although this is just 4 routes, you can imagine this getting bigger and bigger. So one thing I like to do in the backend is create something called a controllers folder. And what controllers do, controllers are things that control whatever happens when an endpoint gets hit. Let me show you what I mean. I'm going to create a new file, and this file will say register.js. And within register.js, we can copy this entire function, this entire transaction that we use, so that now we have app.post register, and we can call the function here instead of having that entire block. So let's say that we're going to call it register.handle register. So how is this going to work? Well, let's go into the register file, and I'm going to copy the function that I just copied out of there. Looking at server.js, we see that register.handle register will get the request response. So that when register endpoint gets hit, I'll receive the request and response and get called with it. So all we will be doing here is module.exports. If you remember this syntax. And within here, we'll just have a handle register function that we'll create. And we're just exporting it. And this handle register function will just be this block of function that we are creating. So we'll call it const handle register equals this block. But you may notice a problem here. We have the request and response, but we don't have DB or bcrypt. If I run this function in this file, I'll get an error saying, I have no idea what bcrypt is, and I have no idea what DB is. And we have 2 options. We can either, within this file, place the bcrypt and connects imports and connect to the database, or we can pass these to the function. Let me show you. Within the register, well, I can simply just do a request response. And this request response will receive the request response as well as the database connects and bcrypt. So it has it available. And this is what we call dependency injection. We're injecting whatever dependencies this handle register function needs. So if we go back and now change our parameters to include the ones that we've stated and save, well, let's go down and see that, yeah, we have module exports. Everything looks fine on this end. If I go back to the server, and now within here, I do a const register require, and we give it a path. In our case, it'll be controllers and register. So let's see if this works. Go to tim@gmail.com, password 123, register, and looks like I'm registered. If I go to my database and make sure that we have Tim in there, I can select star from users. All right, I have Tim in there, and if I go to the login table, I have Tim's email as well. So we haven't changed any of our functionality. Everything is still working, but the only difference is that we've now made register just have one line and separated out the register function to just be in this file. So that if we wanted to have more things added specifically to register, we separate these concerns of the register logic to be in this file. And this is a better way of doing things. So let's follow suit and do that to the rest of the functions as well. We'll start with the sign in now. Again, I'll just copy this. And we see that sign in requires bcrypt and the DB as well. And we'll say request response will be run with the function that is sign in dot handle sign in. That will have request response DB and bcrypt. I'm going to make this smaller just so you can see better. All right, and we can create that up here by saying sign in, require, and we'll create that file right after this. We'll call it sign in. Going to the controllers. Oh, it looks like we got an error here. Let's just check this. Oh, cannot find module. That's because we're creating it right now. I'll say new file, sign in.js. Copy and paste our function. And we'll call it handle sign in. It'll receive the database and the bcrypt through dependency injection. And we'll export it handle sign in as handle sign in. Oops. Let's save. Make sure that we can still sign into our app. We'll sign out. Sign in to tim@gmail.com, and his password was 123. All right, we get a bit of an error. Let's see. Bad request. Oh, and we want to make sure that, spell that right, bcrypt. Make sure we have that on the server as well, bcrypt. All right, let's give it a try. We'll go to sign in. We have wes@gmail, password 123. We're able to sign in. All right. Okay, things are starting to look a little bit cleaner. Let's continue with this one again, and you can see that there's a bit of repetition here. But hopefully this now makes sense. We know that here we're not using bcrypt, but we are using the DB. So we'll do request response. We'll say profile. handle profile, and we'll say get here. And it'll be a request response and the DB. Again, we'll create a new file, calling it profile.js, const handle profile get, which receives the DB. And of course, we'll do module.exports. And we'll do handle profile get. And I'll show you again with ES6, we actually don't need the value. So if I do this, go to the server, let's do profile here and profile. And then finally, let's do our image endpoint, which does not need bcrypt, but does need the DB dependency. So we'll do request response image handle image, do request response DB, create a new file, image.js. Oop, didn't copy that properly, so I'll have to handle image module.exports handle image, and make sure we get the database in there as well. Go back to our servers and let's just make sure that this image endpoint works. If I go back, sign in as Wes, and I'll submit a face here. Oh, and I'm not getting the entry point, so we made a mistake. Let's go back here. Image is not defined, and that is because up at the top over here, we haven't imported it yet. Controllers and image. All right. Let's give that a go. Make sure we don't have any errors. Let's try that again. Detect. We're doing 1. And if we detect again, we're at 2. Everything is working. Awesome. So that was a little bit of repetition, but look how much cleaner our server.js looks now. We just have very simple files, or very simple one-liners. And somebody can come and look at the server and know exactly what our endpoints are. And anytime we want to add more functions to handle images, maybe when we want to do a post request with an image, maybe with profile, we also want to do a delete request, we can just expand on this and know exactly where our concerns lie with profile and just import them into our server as a way of handling things. The one last thing I wanted to show you is how we can clean this up. So this is really nice because you get to see exactly what each function depends on. But you can also do something like this, where instead of declaring the function, and we now, because of the way we're doing this, we're first running this function with DB and bcrypt, and then it automatically receives request and response. So this function gets run, then request response gets called as well. And I know that's a little bit confusing and it's a little bit advanced, but if you remember our functions section, advanced function section in JavaScript, it's similar to that. We can go back to our handle sign-in, and within here, we can now have request, response. I know this looks a little bit scary, but let's just see what happens. If I save this, sign in as Wes, and it works. If I add another image here, everything is still working. And this is a little bit advanced, and it might take a while to wrap your hand around it. We have a function that returns another function and then runs this. But if you look at it step by step, it's pretty clear, right? We're running handle sign in with DB and bcrypt. If we go back to the sign in, again, we're passing this. And then we are also, when sign in gets hit, we're passing the request response. So we're running the function again, request response. So that this order is the exact same as this order right in here. And this is a matter of preference. If this you find a little bit too confusing, you can resort to this other way of doing it. I don't think one is better than the other. It's just a matter of preference. I do like the fact that this looks a lot cleaner than the repetition here, but it might be more confusing for some team members. So I wanted to show you both ways. All right, I think that's enough for a code review. We've made this server a little bit cleaner. Our server.js looks pretty nice, pretty clean. We only have 35 lines of code here, and we know exactly where to go to find our controllers, how each route gets called. All right, that's it for now. I'll see you in the next video. Bye-bye. Welcome back. I want to do a quick review of our security and how our app is working right now. Because putting a secure web app online is a very, very important responsibility of the web developer. Let's go back to our code base. There's two main problems that I see so far. The first thing is that we're not doing anything called validation. If I'm going to sign in here and I go to my sign in controller, if a user doesn't enter the proper email or enters something that we don't expect, maybe leaves the email field blank or the password field blank, well, what happens then? And same with register. If we go to register and a user doesn't type in the proper email or name or password, we technically still register them. Because if we leave email blank, name blank, password blank, it'll just enter a blank user into the database. Let's go to the app and show you what that means. If I leave this blank and click register, look at that. I'm entered into the app, and if I go back to the database and go to users, I see a blank user. And this isn't very harmful, but it showcases one important topic that you really want to focus on in your app, and that is validation. Making sure that when you communicate between the front end and the back end, there's a few layers of security. First, the front end will do its own validation. For example, if we go to the sign-in page or the register page, within our front end, within our React app, we'll actually check before, when we click register, we'll have an on submit button, and on submit is going to check to make sure that the name is not empty. The email has proper email format, such as having an @ or a .com at the end. And then password will have some sort of validation for, let's say it has to be greater than 6 characters. And now the front end sends that validated information to the back end. And an important thing that you want to make sure with your server is that the server never trusts anything received from the front end. So it should do its own validation, that is to check email, name, and password, and make sure there are values that it wants to enter and transact into the database. One way we can do this, well, we can simply say that if email or name or password, and we can just do the not, so that is the opposite. So if this is empty, it'll turn to true. If this is empty, it'll turn to true. This is empty, it'll turn to true. So if any of these are empty, we can just respond status 400, and we can just respond with incorrect form submission. Let's save this and see what happens. I'll save. The one thing I want to do is actually go back to my database, and I have my pSQL running here. If I go to login or users, I want to delete the empty user now. And this one as well. Perfect. If I go back here and try to click register, I still get the register. That's because if I go back, I see that I get an error here. And I get can set headers after they are sent. And this is a little bit of a trick, because if you go here and open up the console, all right, we have a bad request from the server. But this if statement gets run, and then it continues on and does this as well. Because remember, in order to end execution within a function, we have to say return. So that way, if this gets run, it returns from this function, and this part never gets run. Let me save that. Go back to our app, and let's just refresh here. We'll just do a blank user. Again, we're getting logged in because now when we go to the front end, if you remember in our register file on the front end, when we click register, well, we're fetching, and we're just checking if user. And this user, because we're responding in here with incorrect form submission, user will be that. So let's just check here for ID. We save. And remember, this is something that we did with our sign-in as well in the previous videos. If we go back to register, try to register. It's not letting me because if I open up the console, I have failed to load resources. If I go to network, try that again. Go to register, I get incorrect form submission. So that is really, really important. The server and the client should do its own validation and make sure that it handles all possibilities. If an attacker, for example, enters some really, really bad piece of code instead of an email, well, we need to validate against that and make sure that we take proper action based on that. So we can add things like this into other parts of our app, especially ones where we accept input. Luckily for us, that's for our register, and then we have our sign-in as well. And then for the sign-in, we can simply just copy and paste. And here we're using request.body.email and password. So we can simply just, again, destructure it. Password from request.body. We'll remove the name. And again, we'll just remove the request.body from these just to make it a little bit cleaner. And if I save this, this should work as well. Let's go to sign in, make sure I'm not able to sign in. Perfect. And if I go to wes@gmail.com, 1, 2, 3, sign in, I'm able to sign in. All right, so that's the first part of the security I wanted to cover. There's obviously a few more things that we can do here, but I think you get the idea. The next thing, and another major flaw in our app, is that when we submit an image, let's grab this, and let's open up the tab, the network tab here, click Detect. And if you look at the image endpoint, well, that one we take care of, but if you look at the outputs, this is where we're asking API clarify for the request. If I click on this and look at the headers, and I look at the authorization, I get the key with DCB17E, and if I go back to the front end, and under app.js, DCB17E, that's our API key. We're making our API key, which in my case, it's a free one, but when you're using an API that costs money, somebody could steal this information and use your API key to just load that API with requests and make you, well, pay a lot of money. And you never want to do this. When you're playing as a developer on your own project, that's fine. But things like this shouldn't happen. So one thing we can do to avoid this is actually move this to the back end instead of the front end. Let me show you how we can do that. We're going to go back to our front end. And in our front end, I'm actually going to copy the clarify information to the back end and remove it from the front end. So if you remember, we need to just install clarify on the back end. So I'm going to stop the server and do npm install clarify so that we have in package.json. We will import it, this time using require. So let's go to our handle image. And in the handle image, we'll just import. And instead of import, we'll do const clarify equals require clarify. And we will just copy exactly what we have in our app. I'm going to remove this. Going to cut this out. Use our API key right here. Then scrolling down, we take a look at where we use our API key. In our case, it's here, app models. And here, we want to just do the clarify and then grab our response. So this bottom part we can keep. We just need the clarify call to now be coming from the backend. So we'll copy that, go back to our backend. Let's put that in place because we have app now from the new instantiation of clarify. And we will now need to grab the input. So it sounds like we'll need a new endpoint. Let's clean this up a bit. I'm going to do predict, clarify. Well, let's do it over here just so we can see it better. I'm going to minimize this a bit. In app.models predict, we will predict with our request.body.input, which we obviously don't have, but now we know that we need the input. And we can wrap this around a function just like this. We can say const handle API call, and this one will receive a request response. And we'll just move this up here. So now we can just say handle API call at the bottom over here. And on our server, we can create a new endpoint for image. And we can do a post request because we'll add it to our request.body. And we'll just call it image URL. And the image URL endpoint will have the handle API call. It won't need the database. We'll definitely need to import it, but we have it on the image object already. Okay, so if I save this, we now need to make sure that we receive the body with the URL. So going to the front end, we'll say that on submit, we need to fetch, and let's just copy this, what we have here for now. We want to fetch image URL. It's going to be a post method, and it'll have a JSON of input, and that input will simply be the thisState.input. That's going to give us a response, and that response will keep trickle down this way. But keep in mind that because this is a fetch, we'll have to do response.json. So that's simple enough to do. Let's fix the indentation here, and we'll do a .then response equals response.json. We'll save, and we'll want to go back and make sure that this is working. So let's go to our server, go to image, and make sure that we're responding here with .then data. And this data will have a response.json of data, whatever this gives us. If there's some sort of an error, we'll do a catch, and we'll say response status 400. We'll do JSON unable to work with API. Let's save. We'll see if this works the first time. It usually doesn't. But if we sign in with wes@gmail.com, 1, 2, 3, let's sign in. Oh, we have a bit of an issue. Let's go to console. Failed to fetch. Oh, we need to actually NPM start our server. All right, and now we get some errors. All right, we have missing brackets, so we just made a bit of a syntax error here, and that's because I forgot a period in here. Let's save that, and if we go to our front end's running, back end is running. Let's close this and try this again. All right, I'm signed in. If I copy this image again, moment of truth. All right, we're getting the image, but the response, something's not working. We have failed to fetch. The server responded with a status of 500. So we get an error in the server, and it looks like handle API call is not a function. So let's go to server, and my terrible spelling mistake again. This always gets you with the spelling. Let's try that once again. We'll clear this, send detect. No errors. All right, look at that. That's working. Amazing. I see no errors in my API or the front end. So that wasn't bad. And if I actually go back to the request, go to the network tab, and let's check this. I'm going to press detect. If I go to image URL, we're not seeing any of our keys. The only thing we're seeing is a response, which is the response that we get from Clarify, but our server is running in our own environment and nobody has access to it. So let's go over what we just did. We created a new endpoint, and because we now have our own controllers, and it's regarding the image, we can add it to the image controllers, and within the image controllers, we create a new function and just pretty much copy and paste it exactly like we had on the front end. We respond it with JSON data. And this JSON data is now getting sent as response.json. So on the front end, we simply created a fetch request that sent the input, and we responded with our response. So not much really changed on the front end, except for the fact that now we're hiding the API key. And instead of having clarify here, we have it on the back end. I hope that was some valuable security tips for you. There's lots of things when it comes to security, and it definitely is something that you have to get used to as you have more and more years of experience. But having that general rule of making sure that your machine, or in our case, your code base of front end and back end, never relies on the security of the other. Always focuses and makes sure that whatever inputs it gets from other places outside of itself is always validated, and we protect any secrets that we have from the outside world. Never trust anybody is pretty much the motto in security. So I hope that was insightful, and I'll see you in the next video. Bye-bye.
Welcome back to a little bonus video that I've made for you. Now, as you've worked with the Clarify API, you may have noticed something, this term called gRPC. What is it? Now, if you remember, we used the Clarify API with JavaScript, and we were able to make predictions on our images. We installed the Clarify API, and we followed the documentation, and everything worked. But at the very top here, we see note. For Node.js users, this API client is no longer supported. Now, as I mentioned before, this isn't a big deal. All this means is that they're just not making any more updates to this API client. But as you saw, it still works. And the reason I used this one is because it's extremely valuable. The way this API client is created is the way a lot of clients are created. They use this principle of a REST API. And everything we did, well, you're going to see in a lot of other APIs as well. However, an important thing that we keep going over and over in this course is that things always change. Technology is evolving. And in this case, maybe an API that you once used for your project gets updated, and your boss comes to you and says, "Hey, Andre, I saw that this Clarify API, it's been updated to this thing called Node gRPC client. Can we update it?" Now, as you saw, things work as they are. But let's say your boss says, "We need to update this." What do? Sometimes things change. This is a big, drastic change. And I'm going to show you how to make that change in case you ever encounter it in your workplace. With that said, gRPC, as we're going to talk about, is actually quite rare that you're going to see on the job. As a matter of fact, I've yet to really see it in my day-to-day consulting work. So this is a very rare case, but I just want to show you the thought process that I have as I try to read the documentation and update an API. Now, for a reference, I'm going to leave this article for you that you can read so you can learn about the way we did things with REST and what gRPC is. On the surface level, gRPC is essentially a way for us to have faster interaction with Clarify. Remember, Clarify is an API that provides us data, predicts on our images. And gRPC is a faster way for them to provide us information of what the image has. So as I scroll through here, one thing I do want to note as you read here is that gRPC was developed at Google. So it stands for Google Remote Procedural Call. And it's essentially a faster way for us to communicate between systems. And it does that by using something called protocol buffers instead of JSON that we're used to. Again, this is a pretty advanced topic. We don't need to focus on it. I do want to mention one thing, which is the conclusion right here of this article. gRPC provides plenty of advantages. However, the low browser support makes it challenging to compete with REST universal support. REST is used in a lot of APIs. It's pretty much everywhere, versus gRPC is more for internal systems, which is why I don't really teach you in this course. But read the article if you're interested. Enough talk. Let's actually show you how I would update an API if my boss asked me to and I have no idea what gRPC is. Well, I'll read about it here, and then I would open up the new Clarify node gRPC, and then I'm going to follow the instructions. Now here you see that I can just npm install clarify node.js gRPC. So I'm going to do that. As a matter of fact, I have a copied project here of our final server, SmartBrain API, and you see here I have added gRPC. I just copy and pasted all the files, so nothing is different here than what we had before, except I'm going to turn this into the gRPC client. So the first thing I'm going to do, I have my front end and my back end. And I'm going to npm install clarify node.js gRPC. Now, while that's downloading, I'm going to go to package.json and see that now I have the clarify node.js gRPC. And I also have the old clarify API client. Awesome. So that's the first step. Next, as I read through here, yada, 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 getting started, we see that, all right, this is pretty much what we need to do. So I'm going to copy this, go back to my images.js. This is the old way of doing things. The new way, I'm going to copy and paste. You see that I require clarify node.js gRPC. I do this thing called stub and then use the gRPC method. Again, we don't need to know how that works. It's just the way gRPC works. So we just kind of let them do that as the documentation says. And then we have the authorization with your key. So I need to add my clarify API key here, which I have right here. I'm going to copy this API key. It's actually important here that you leave this key space and then your key. That's actually part of the way we want to use the API key. So we can comment this out. Again, this is the old way. We don't need to require the old clarify API client. So we have this new one. There you go. That's the setup. So we've just replaced these two lines. What's next? All right, predict concept and images. Again, I have no idea what this does, but I'm going to copy it and see how we can use it. And this is usually what developers do, right? We figure things out. We problem solve. And the idea in this course is to create that muscle in your brain to problem solve. So let's see. I have stub.postModelOutputs. Okay. It looks like I need the model ID here. Now, this general model was from their documentation. Remember, we got it from here. Let's keep it for now. It's not the face detect model, but just to make sure that everything works. We see here that this is where we give the image URL. So in our case, if you remember, our image URL is in the request.body.input. And we use this handle calls API. This is the old code, so I'm going to just comment this out. And instead, take this handle API call and wrap it around the stub post model outputs. So I'm just going to indent that. So we're going to do the same thing here, except we're going to use this new way of doing it. The URL, instead of this static one, is going to be request.body.input. And because we wrapped it around the handle API call, we have this request object. All right, so that looks pretty good. Some error and responses that we're getting. Looks like we're doing some error checks. And then here we have the response. So response.outputs.data.concepts. So it looks like we receive our response here. Okay. So far, so good. We still need to return. If you see here, we still need to do a response.json.data to our front end. But for now, since we're logging some stuff, let's just save and make sure that this works. Let me start up my server. All right, everything's running, and my front end. All right, there's my front end, and luckily for me, I have a really nice Tom Hanks picture. Look how happy he is. All right, let's take that, paste it in here, detect, and nothing happens, but that's fine. We want to look at what the app gave us. Portrait, dinner jacket, people. Okay, that's cool. Look at that. We have a response with the general model of what the picture is. So just like that, we converted our app using gRPC and everything works as expected. Now we have to change the model ID to the face model, and we also need to give a response to the front end. So this part right here, we need to still do this. So how do we do this? Well, we have the response.outputs data concepts. Now, if you remember on the front end here, if we go to app.js, we see that this calculation of, where was it? Outputs, data, regions, region info, bounding box, that's something that we do on the front end. All we need to deliver for them is the data, the response from the API. So what I'm going to do is, instead of doing all of this, I'm just going to keep that the way it is. I'm going to say response.json is going to be the response. So I'm doing the exact same thing as I'm doing here, but I'm doing it inside of the handle API call, which we have the response. So unless we get any errors, because this is going to return with errors, otherwise keep going, make predictions, and then respond with the response. The response being the response from the Clarify API, and then the response from the Clarify API, we are going to respond to our front end. A little bit confusing. I could change the naming of this, but this is just to show you how it works. So if I do this, let's comment this out. Again, this is the old way we did it. Let's save. Now, the only thing we need to change is the model ID to use the face ID. Now, a quick and easy way to figure out the Clarify model ID is I'm actually going to return this old require Clarify API, because if I do console.log clarify here, it's actually going to give me some model IDs. This is a little trick. Let's see. There we go. We have console log the clarify, which actually gives us some of the model IDs. So let's see, face embed, face detect model, this one. So let's copy this. Going to comment this out because we don't need it anymore. And then model ID, I'm going to use this model, which is the face detect model. Again, you can go on the Clarify website and actually find this, but this is a nice and quick way. So I saved this, everything is running. Let's go back to our friend Tom Hanks. Let's refresh the page just to make sure everything is fresh. And Tom, where are you? Oh, look at that. Facebox activated. And just like that, forget about unable to get entries. I don't have the database open right now, which is why that's the case. But as you can see here, we were able to use gRPC the way the new API has been updated with very minimal effort. All we did was just used our problem-solving brains that we've developed throughout the course and figured out how to do it. It's not that bad, is it? There's obviously things that we can improve here, naming, we can organize our code better, maybe we can comment and explain some things better, maybe deciding what model ID we want to use. Overall, I hope this shows you the thought process of having an updated API. Your boss comes to you and says, we want to do it this way. And you use your problem-solving skills to read the documentation and figure it out. Because at the end of the day, programming is simply a language. If we understand the basic principles, we can understand what the code does. There you go. Your own gRPC fueled Clarify API. Good job. I'll see you in the next one. Bye-bye.
Welcome back. I wanted to show you a quick video on an important concept called environmental variables. And I've created a simple server here that we've done before using the HTTP module that comes with Node. And we have a simple server that listens to port 3000. If I run node server.js, we get servers listening to port 3000. However, this is not really realistic. Sometimes we don't want to hard code what port we are listening to. For example, when we're deploying something through another service, like we will with Heroku, we can't really pick what port we're going to listen to. We need something dynamic so that it can be changed. How can we do that? Well, this concept of environmental variables is the idea that there's variables, just like we have a const A equals 1, const B equals 2, that are variables in this environment. There's an idea of an environmental variable, which is an environment such as here, a computer that this application is running on, or this server is running on. It may have its own variables, and we're able to inject these variables into the specific location in a file. And this isn't just node or server specific. It is with all programming. Everywhere you look, there's going to be environmental variables that are being used. It's a concept. So how can we do this in Node? Well, in Node, we have access to, let's do a console log, process.env. And with process.env, if I run the server, you see that it tells me the environment, such as where I'm running this from, the home, tells us what terminal program I'm running with this with, which is iterm. Getting a lot of information. Let's clear this. With this now, we can set our own variables. If we wanted to set the port, for example, we can say process.env.port, and now change this to process.env.port. And just to make this cleaner, we can just have port equal to process.env.port. So now we can remove the same call. Let's just console log here as well, just to make sure that we see it. If I run node server, I get undefined. But that's because this port number is something that we didn't have initially. I just made this name up. I could have said ABC. It doesn't exist. In order for us to access or create an environmental variable within this computer, we have to inject it. I'm going to show you how to do it with fish, which is the shell that I'm using here, which is a little bit different than bash. And most common, you'll see bash. So I'm going to show you that way first. With bash, we simply do port 3000 node server.js. And look at that. Server is listening to port 3000. If I change this to 3050, server is listening to 3050. And this isn't limited to port. You'll see in the next couple of videos during production, we can set up something like a database URL. And this database URL can now be dynamic. Maybe we won't know where the database URL will be. In that case, I can simply say database URL equals 123 node server.js, and we get port is not defined because we're not using it here. So let's just revert this back to port 3000 and run that command again. And look at that, server listening to port 123 because that's the database URL. And we can set whatever environmental variables we want. And the importance of them won't really come into play until later on in these videos. But they're really important for things that should be kept secret or dynamic. For example, port. We might not know what port the server that's going to be running our API will be run on. So this way, whoever is running it can just set the port without touching the code base. But also for secrets, for example, API keys that we might not want to have in our code base. We can just launch the app and give maybe API keys or even passwords to log into the database dynamically through the environment so that it's more secure. Let me show you how to do this in Fish. It's a little bit different and you don't need to worry too much about it because it's just specific to Fish. It's kind of a weird kink, but you can do environment, database, URL. We'll say hello node server.js. And we have server is listening on port hello. Again, this is just specific to Fish, but to demonstrate to you that they're environment variables. The environment decides the variables, and because the environment that this is running on is a Fish shell, I have to use the specific Fish way of declaring it. But the goal is still the same. We're trying to inject these properties and values into Node so that it has access to it. And that's why it's called process.env for environmental variables. And we'll use them in the next couple of videos. I'll see you in the next one. Bye-bye. Welcome back. It's time for us to actually deploy our app that we've been working so hard on. Now, up to this point, our entire project, our entire beautiful app has just lived on our laptop. If we wanted to show it to somebody, well, we needed to have it set up on our laptop. But that's not really realistic, right? If we ever want to get users and spread the word out about our project, we need to have it online, accessible to everybody. And we're going to do that in this section. If you remember, we have the front end, all done with React. We have our backend server that has a beautiful API created by Node and Express. And we also have our Postgres database set up. And we're going to be setting up each one of these rectangles that you remember should be separate computers. We're going to deploy them separately so that as long as they can communicate and they know where each other lives, it doesn't matter where each one of them is as long as they have this connection. And we're going to be deploying to a place called Heroku. And Heroku is just a company that has a ton of computers and they're willing to host the files that we give them for us. And I'm going to be walking you through this. And you might be asking yourself, why aren't we using something like a HostGator, something that I've heard of before? Well, HostGator or Bluehost or most hosting platforms that you've heard of are these simple platforms that we've talked about before, right? They have usually an Apache server that is just hosting files. So they're really, really good at hosting and serving really simple HTML-based projects. If you just have an info page or an about website, well, they're really useful. Maybe you have a WordPress website. That's good if you're not worried about the servers and everything is taken care of them. But that's not how we deploy apps anymore. If you're actually building applications which are more complex, we need something that gives us more control. And there's many options. And these are some of the more famous ones, such as Amazon, Heroku, which we'll be using, Engine Yard, DigitalOcean. There's also Google and Microsoft that offers web services. And they offer a ton of different things that we don't really need to get into. There's a special industry called DevOps that really focuses on this domain. But we want to know how it works so that when we encounter it, we can explore it more and understand it. At the end of the day, these are just computers managed by these companies. They allow you to run your files on their computer and in return, well, we pay them, but they also make sure that the computers are going to be running really, really fast. And if we're running something like Postgres or a database, they're going to try and do their best to make sure that it doesn't go down or that there's backups. And you're going to be hearing a lot about these sort of companies a lot when you get into the web development field. We're using Heroku here because it's really developer friendly, and they also offer a free tier, which is great for projects like this, just for demo purposes. If you go to their website, they have really, really good documentation, and it's so simple to set up. So I'm going to go ahead and tell you to sign up for this. It's completely free. As soon as you log in, you will be directed to something like this, your personal dashboard. And you can see you can use different languages to deploy. In our case, we're using Node. And we can just click on Node and it will take us to documentation that takes us from 0 to getting our app deployed. But you don't need to go through all of this because it's so simple. Let me show you. I'm going to link to all this documentation after this video so you can take a look for yourself, but it's really, really easy. If you go to documentation and deploying with Git, it's as simple as few commands. It tells you that we essentially need two things. One, we need Git, which we already have, and Heroku. So let's talk about our game plan. We're going to be putting our server on Heroku and also our Postgres database on Heroku. And the front end, the React app, we can put it anywhere really, but we can use GitHub pages that we've used before for background generator project because it's free. Let's look at the API first, because that's the most important one, I think. It's the connector of the two. We already have Git installed, so let's get Heroku CLI, which is the command line interface. That is, we can use it in the terminal to install it. Now, before we get into this, I went ahead and put our API on GitHub to make sure that we can actually run these commands, so make sure that this is a Git project. I went ahead and did that without recording it because we've gone through it before. I didn't want to bore you with that. You should know how to do that by now. So looking at the Heroku CLI, we have both Mac, Windows, and Ubuntu operating systems that we can run it on. So again, I'll link to these and you can decide which way you want to install it yourself. For me, it's a Mac, so I'm going to use brew install and install this command line. And as you can see over here, I already have this installed, but for you, it might take a little bit longer. And once it's done, I'll say it's installed. Go and have some fun. All right, so we have Heroku installed. If we go back to the documentation, it tells you how to add your app to Git, which we already know, so we can skip over it. And it says that we need to just run Heroku create to create an app. We go into our directory and simply run Heroku create. And look at that. It created our app. It even gave us a URL that we can reach our app. All right, awesome. But in order for us to use this, well, let's go to this URL and see if it works. We can use Heroku open to actually take us to this link. Now let's see what happens. It says couldn't find that app. Well, because we actually have a few more steps. We have to actually deploy the app. And the way we deploy it, we have to first check something called Git remote. And it's something we haven't really talked about, but let me show you what it is. If we run git remote -v, we get, let me open this, make this a little bit bigger. There you go. We see that we have Heroku and Origin. Up until this point, when you work with Git, the default is Origin. So you may do commands like git push origin master. That meant we're pushing to Origin, which is GitHub, and we're pushing onto the master branch. And origin is just the default name that GitHub has. We might have done the command just git push because the default is always origin and master. So that was just the shorthand way of doing it. But now, because we've run these Heroku commands, we also have Heroku now. So instead of pushing to GitHub, we can push to Heroku. So in our case, if we go to deploy code, we see that we simply run git push Heroku master. Let's do that. I'm going to run git push Heroku master. Let's see what happens. You see here that I got an error, and this is an error that you might not get, but because I've used Heroku before, it has a different name. You can see over here, shielded anchorage versus the name that I actually want, which is Radiant Ocean. And we see that in our remote as well, that we don't have the Radiant Ocean app. We have something else that I've created before. And the way you get around this is for an existing Heroku app, you can simply run this command to rename it. So we do git Heroku git remote -a and the name of the new app that you want to add. In our case, it's this. And now if I do git remote -v, all right, I have Radiant Ocean as my app. And don't worry, if this is confusing, it's just a matter of reading documentation. It's very specific to Heroku and something that you'll get used to, but now our app is pointing in the right direction. So let's try that again. We're going to try running git push Heroku master once again. All right, looks like it's running, and you can see over here, we're creating an environment, we're installing a bunch of things, it's installing Node modules. So it's running NPM install for us and getting everything set up. And it's saying verify and deploy, done. Awesome. Let's do Heroku open and see if this actually works. And it's just hanging there. And don't worry, I did this on purpose. The reason it's not working is, instead of me telling you, let's figure out what's actually going on. There's another command that we can use, which is Heroku logs --tail. And this gives us a log into what's happening in this computer where the server is running. All right, so it looks like everything is running. Node server is listening to port 3000. Oh, we see that we get an error now. So it looks like we're getting a boot timeout. And it's saying web process failed to bind to port. And this is something that you'll read in the README or the documentation of Heroku. What's happening here is that Heroku has its own port that it assigns. And as we've talked about environmental variables before, because we're setting our port to listen to 3000 here, Heroku wants its own port. Doesn't necessarily care about 3000, has its own thing. So the way we get around this is we can use process.env.port. So that if we receive a port from the environment that we're running in this case Heroku, run that. Otherwise, run port 3000. And we can change app is running on port 3000 to something more dynamic, like process.env.port. All right, let's go back and run git push Heroku master. But here's the thing. Because we're going it through Git, we actually have to add these changes to our repo so we're pushing anything. If we run this command just by itself, it'll say everything is up to date because we haven't done the git add, git commit commands. So let's do that. Git add, git commit adding port. And then we'll do git push Heroku master. I'll run through the commands again. It's redeploying the entire server. And if we go to Heroku open, looks like we're hanging again, and we get internal server error. Let's look at the logs. We go again to Heroku logs tail. And this is a little bit tricky. If you scroll up here, we want to go to app. Okay, so no one's running. App is running on port 9098. But if you keep going down, after npm start, we get a reference error. Database is not defined. And this is something that I left here on purpose, just to show you how debugging works, where you have to look through the logs. If you remember, we're no longer using the database that we created, the first variable. And because our app, when it first loads, goes through the root route, it's going to run this command and it's going to say, well, database doesn't exist. I don't know what you're talking about. So to fix that, let's just change this to it is working. If we save, and yes, unfortunately, we have to go through our git commands again. We're going to git add, git commit, changing response, and then git push Heroku master. All right, it's running through some magic. And let's do Heroku open. It's working. Our app is now at this location, and we can reach it using this. Let's test that theory. Let's add this instead of our local host to our front-end app. And by the way, if you go to the Heroku dashboard, which I can just use over here, and we see that my app is running. It has all the logs that I need. I can look at metrics. I can look at activity. You can look at the deployment process and add different things. There's just so much stuff you can do. It's really, really cool. But let's just test our assumption to make sure that our app actually works. I have the SmartBrain application running here. Let's open up app.js. I'm going to make this a little bit smaller so we can see. And where we do our fetches, we're going to change localhost, which is our computer, to the actual endpoint. Let's copy the endpoint that Heroku gave us. And change it for all the local host locations. So we have this, and if you remember, we also have the register and sign in as well. Just to confirm with you what we just did, we've essentially just told the front end where these arrows should point. And it should point to the location of the server, which was provided to us by Heroku. All right, so let's give it a try. I'm going to run npm start. And hopefully everything is working as we want it to. If we sign in or just click on sign in, nothing happens. So we need to register somebody. We'll go with Todd at gmail.com. 1, 2, 3. Register. Oh, we get an error. Let's see what we get. If we go to console, server responded with status of 400 bad request. Let's look at the network and see what happens. I click register. And we get unable to register, which is actually a really, really good sign, because that is what we've written. Remember, in our server, we said that when we try to register, if it fails, we want to return unable to register. So it's actually connecting to our front end. That's amazing. But you may notice a problem. That is now the fact that we don't have a database anymore. Because our database in the backend is referencing, if you remember, our local host. But since this computer now lives somewhere on Heroku, it has no idea. Well, it might know what localhost is, but they definitely don't have a database called SmartBrain, do they? So now let's create a Postgres database on Heroku. But this video is getting already a little bit too long. So that's for the next video. I'll see you in that one. Bye-bye. Welcome back. We left off with Todd unable to register to our app because our backend server is not connected to any database. Luckily for us, Heroku also has Postgres. If I go to my dashboard here, and let's just go to Personal, and in this corner we have Data. We click on Data, and it says, hey, looks like you don't have any data stores yet. And we have Heroku Postgres, Redux, and Kafka. But Postgres is what we need, right? So let's create one. And we can just log in with the same credentials, the same thing that we had for our server. And we can simply just install Heroku Postgres. And look at that, it already knows which application we want to install it to. So let's click on that, click Continue. And now we just pick the Hobby Dev, which is free. We click on Provision. There you go. It says the add-on Heroku Postgres has been successfully installed. Check out the documentation to get started. That's awesome to hear. Let's open it up. And once again, they have amazing documentation of how we can set up everything. So looking at here, the first thing we want to run is Heroku add-ons to make sure that we actually have it. Let's go back to our server. I'm going to clear this and run Heroku add-ons. I'm going to make this a little bit bigger. All right, we have Heroku Postgres. That's great. If we actually scroll down, we see that we can run the CLI with Heroku PG info. So let's do that. I'm going to say Heroku PG info. And I'll show that, yep, this is our Postgres. And we can connect to it by running PG PSQL, just like we did on our laptop. Let's do that. I'm going to say Heroku PG PSQL. And look at that, we're in our database. So let's recreate the database that we had originally. We can simply go back to our PSQL because PSQL is smart enough to remember our commands. And if we go to query, there you go, we have our create table commands already. So let's create a login table. Perfect. And let's create the user table as well. Or users table. I'll copy this, go back to Heroku, and create table. Let's do \D to make sure that the tables are there. All right, we have our tables. And you see that the owner is, well, something completely different than my laptop. But there's one more key thing that we need to fix now. We have our tables, but my connection on my server is still referring to my local host. How can I change this? If we exit out of this by doing \q, and we do again Heroku PG info, we have the add-on, which might be the URL, but a better way for us to do this is to actually run Heroku add-ons. Yeah, it's the exact same one. This is the URL that they provide for us. So let's try this. If I do this Postgres within this URL, this database URL, in here, will it work? Let's find out. I'm going to, once again, git add. So we have to commit the changes. And I will say updating database, git push, Heroku master. All right, it's deployed. Let's go back to our app and see if it works now. We have todd@gmail.com. I click register. We still get an error. If we go to console here and actually network and click register again, we have 400 bad request, unable to register. So let's take a look at the logs. If we do Heroku logs --tails, oh, look at the error. Connects warning connection error. So it's not finding the host that we want. So let's go to our documentation to connecting to Node.js. And we see here that with the client, Postgres actually just gives us a database URL here. And we also need to have SSL true here. And you can read up on it a little bit more. But we can just copy this, remove all the database information, and within the host, we can say process.env.database URL. Let's save. We'll have to git add this again. Git commit, adding database connection. And we'll git push Heroku to master. And while this is loading, I really want to go through the fact that this is one of those things that you just have to read, and it's so platform specific that just because you learn this one way on Heroku doesn't mean it works on the others. But it's all a matter of just reading documentation and being comfortable with that. Let's do Heroku logs here to keep an eye on, make sure everything is working. Right, we have a port. So let's go back to our app. I'm going to close the console for now. Click register. And looks like it's still not working. If we open up the network, click register, we have the bad request. If we go back to the logs, we have a connects warning again, connection error. This is a good time to use another command, which is Heroku config. And Heroku config actually gives us the database URL. And this database URL, well, you see that they're using Amazon, AWS. But you see here in the connects warning that we're actually getting that link. So it looks like we need to actually use the connection string, exactly like they have told us. So we forgot to do that. Let's do connection string here. Oops. Let's copy this. Connection string. And now it's getting repetitive, but this is how a debugging session usually works. I'm just going to do a quick commit here. Git push Heroku master. All right, and let's give that another go. Let's actually try registering now. So we'll do Jenny@gmail.com. We'll do 1, 2, 3, register. And Jenny is logged in. Awesome, it's working. If we go to the logs here, we see that, look at that, we're doing post request to register, and we can check out the logs. And we can even go to our Postgres, Heroku, PG, PSQL, do a select star from users, and we have Jenny and Todd both registered. Awesome. Just to check that the login table is working as well, I have a login table. Nice. And then finally, to get a face, we'll grab another face. We'll view image. That's a big one. Let's see if it works nicely. I press detect. And look at that. It is working, but Jenny's entries is not updating. Let's go back to Jenny's profile and make sure that her information is correct. If I go to users, looks like entries is not being updated. If we look in the console logs, we get failed resource on the image endpoint. And if we go to the network and submit this again, we see that the image endpoint is failing. And this is something that, again, we're going to tackle in the next video. I'll see you in that one. Bye-bye. Welcome back. All right. So the reason the image endpoint wasn't working was because of a silly error. I had left the port over here, which shouldn't be here. As you can see, our Heroku app is hosted there, and we don't need the port. So if I save this, let's actually create a new user. We'll register Teddy this time. And Teddy@gmail.com has a password of 123. We will register. And let's grab another face. Grab this face this time. We'll paste it in here, detect, and look at that. This is now updating and everything is working as intended. Beautiful. If we go back to our server, we see that our image endpoint finally gets hit and everything is working amazingly. How cool is that? We've just deployed a server and a database. And they're both communicating together with the front end as well. So cool. In the next video, we're going to deploy our front end application on Heroku as well. So we have 3 different servers running for us. We could put it on GitHub pages, but that's something that we've already done. And I'm excited after doing these 2. So let's put this on Heroku as well. I'll see you on that one. Bye-bye. Welcome back. In this video, we're finally going to put our front-end application on a server so that everything is now off of our computer online and we can share our project with the world. To get started, we can go back to Heroku. And in our dashboard, we can simply see that we have our server, but we want to create a new app. And this new app, we can call it SmartBrain. We'll choose region US. We'll click Create App. And it gives us really nice commands how to set up everything. We can just do Heroku login. So let's do that from our SmartBrain front end. I'm going to say Heroku login. Log in with my email and my password. And going back to the README, we see that we make sure that our Git is set up, which it is. And we can add our remote to Heroku Git remote SmartBrain. All right. if we do git remote -v, and these are the same steps that we ran with our API server as well, we see that we have Heroku. Next, we want to do git add, commit, and then push to Heroku master. All right. And a reminder here that even though we haven't changed anything on the front end, we do have to run git add and git commit. Otherwise, the changes won't appear on Heroku. So let's just say deploy for now. All right, and then we can just do git push Heroku master. Seems a little bit too easy, right? Well, let's let this run and see once it's deployed if it's all working. All right, deployment's done, and look at that, we have a new link. So let's run Heroku, open. All right, look at that, we have a new link on our front end, but let's see if it works. If I sign in with teddy@gmail.com, do 1, 2, 3, sign in. All right, and look at that. Teddy is loaded. He's already done a count before with the face. Let's do another one just to make sure it works. Click detect. Nope, I don't want you to save Teddy's password. But look at that. Everything is working. It seemed almost too easy, right? So cool. Let's recap one more time what we just did. We've created 3 separate servers or 3 separate computers where each of these individual rectangles are running. We have a Postgres, a Node server, and a front end. And all of them are working exactly as they were on our computer, but this time in production, live, into the world. And all we had to do was just change some numbers to make sure that we're pointing these arrows, so that the front end knows that this is where our server is, and the server knows this is where our database is. And these are just small configurations that is really dependent on each platform you work with. But the underlying concepts are the same. You're just pointing to the address, to the location of these things. But, oh boy, wasn't that crazy how we got all of these things to work? I remember my first time in my career when I managed to connect the dots and actually build each one of these myself. It was an eye-opener. It opened up a whole new world, and it made me really understand how everything is connected. And moving on from that point, I understood most things. And every tool or new technology is just an addition to this pre-existing idea. And as long as you understand this underlying architecture, this underlying concepts of different servers connecting to each other, the rest is just extensions of this. So, could we improve this app? Absolutely. You can do so many things with this app. We might want to be a little bit extra secure and perhaps not even have our API key in our code for our server. We can create something like environmental variables for this. For example, on Heroku, if we go to our SmartBrain app, or let's go to our backend, our Radiant Ocean. Now in here, if we go to settings and go to reveal config vars, we have our environmental variables here set for us. You remember Postgres, how we tried to connect to it and we had a process.env.database URL? We can add our own. If we wanted to, we can say API clarify, add the API key that we have in our backend into here, click add, and now we have this available to us as a process.env.api clarify, which is, I believe, what I called it. And this is an extra layer of security. You don't want anything sensitive like addresses or passwords or API keys in your code base so somebody can peek it. This is something that you'll get used to more and more. And hopefully with what you know about environmental variables, this makes sense. But for now, because this is a simple app, we don't need to add any of this. We'll revert the changes and just be proud of ourselves for creating an awesome app and deploying it in real life. Now go share this link with all your friends and family and tell them how awesome of a dev you are. I'll see you in the next one. Bye-bye.
Hey there. I wanted to take a second at the end of it all, at the end of your learning journey, to just say this one thing, and that is, thank you. I know your time is valuable. We have limited time on this earth, and you decided to spend your time and your money, frankly, with us, doing something that takes a long time to learn. So truly, from the bottom of our hearts, I know it sounds cheesy, but thank you for dedicating your time and effort to this course. I hope you got what you wanted out of it, and congratulate yourself for getting this far, because a lot of people start, a lot of people have hopes of learning, but they give up along the way. But you didn't do that. You worked through the challenges, the problems, and you got here. Now, your learning journey doesn't end here. It keeps going. But I hope this created a foundation for you to go off and learn things on your own, get a promotion, get hired, start a new business, whatever it may be. Again, thank you and best of luck with your learning journey. This is just the beginning of whatever you decide to do in the future. So thank you and good luck. Hello and welcome to the Ask Me Anything video that I just impromptu decided to do after we hit 1,000 students, which was just last week, and we already have over 2,000 students. So I want to start off by saying absolutely thank you. Thank you so much for being part of this course. It is beyond what I expected. I thought I'll get a couple of, 100 and call it a success, but I've really loved interacting with a lot of you. We have students from over 100 countries, and everybody's so excited to learn with so many different backgrounds, and I just love the community that has come out of it. Like I said, it was beyond my expectation, and I love that everybody's so excited about learning to code. So thank you so much. I've created a couple of videos for you to watch, but I think the community that's forming around it, that's supporting each other, and hopefully in a few months, helping each other to become the web developers that they want to be, I think that's the most amazing part. So again, thank you so much. I'm just going to answer a few questions that some of you have asked to celebrate getting to 1,000 students. The first one that I see over here is from Ashley, and she asked, what was your biggest hurdle after starting a new career field? I think the biggest hurdle that I encountered was definitely the imposter syndrome. You may have heard of it. It's the idea that you feel like an imposter. You feel like everybody else knows this stuff except you. You sit in a room and people start talking and you realize that you have no clue what's going on and you're afraid to ask questions. And I think that's the biggest hurdle. Realizing that when you read something or watch videos online, people have practiced this and made sure that there's no mistakes in their writing and their videos, and I did this as well. And what this means is that what we project onto our videos or onto our blog posts isn't exactly us being perfect. It's us iterating and making sure that we check our mistakes and fix them. So nobody out there knows every single answer about web development or coding. We all are beginners and we are problem solvers. We're really good at solving problems, not just dictionaries that know everything. So really realize that you're not an imposter. You're not less than everybody else. Everybody has these difficulties, and I think the biggest thing you can do as a developer is ask a lot of questions. Anytime you don't know something, ask questions. Don't feel like you're the only one that doesn't know. Most likely other people in the room don't know, except they are afraid to ask a question and raise their hand. So I think That's the biggest hurdle. You get over that and you get comfortable asking questions to your coworkers when you don't understand something. I did that a lot when I first started coding, and I was able to get answers and progress a lot faster than most people that didn't ask questions. All right, so next question was from Mike. Other than JavaScript, what is the most important language to learn? I have to say, probably, other than JavaScript, Python is a really good language to learn, mostly because it's used a lot in machine learning, and it's a very, very fast-growing field. And I'm going to write a little bit of a blog post on it so people can get familiar with it, but Python is definitely interesting. The other one I would say is Solidity, which is the coding language that is used in building distributed applications for Ethereum. If you haven't heard about blockchain and all the hype with cryptocurrency, I think Solidity is a really interesting one. In 2018, we're going to see a lot of distributed applications being created, and there's a huge demand for developers who know that language. So I think those two are pretty exciting. I'll be writing a blog post about it so you can get more information. But yeah, you should look into those as well as JavaScript. But focus on JavaScript first. All right, next question was by Wasim. And he asked, if you were to hire a React developer from students who completed this course, what would you be looking for, and what questions would you ask? All right, so I think I would ask, number one, what's the benefit of React? Did they just learn a couple of syntaxes and know React, or do they actually know what problems React solves? And I go over that in the course, so hopefully you understand it as well. And then I'll also ask about what are its shortcomings. When is it a bad time to use React? Because I've seen a lot of people who get really excited about the technology and think it's the greatest gift ever without understanding that not every problem can be solved by one library. I think React is great for some things, but not for everything. And there are a lot of shortcomings that come with React that you should know as well, because if you're able to understand the pros and cons, well, I think then you truly understand the library and you're able to make a good decision as a developer. And it's something that I try to do in this course, which is not necessarily learn a bunch of functions and ways to do things, but deeply understand them, know what problems they solve and when they're good to use. And if you deeply understand that, then I would 100% hire somebody, because I know that they have deep knowledge about something and not something superficial, which in turn means that they're able to do more than just follow instructions. They're able to think on their own, and it doesn't just follow the rules and follow what I say, but can think for themselves and make good decisions. All right, next one by Josh. Which programming blogs do you read most frequently? I definitely like Medium. Medium is great for technical blog posts. If you haven't been there before, just medium.com, and just follow anything. Actually, I would say just follow the top 10 articles daily and browse through them and see which ones are related to technology. I think they're really good. It's actually how I started this course. I wrote a Medium blog post that became very popular, and I thought, hey, maybe I should create a course. The other one is Software Engineering Daily, and that's a podcast that is really good. And it's not just about web development, it's just about software engineering in general. And it can get very technical at times. It really gives you a good grasp of what's out there and the technology as it evolves. And then finally, for JavaScript, there's a JavaScript weekly newsletter. You can Google that and sign up for it, and every week it'll give you updates on JavaScript. Okay, a few more questions we have. What did you do prior to your career change? So I've actually had an interesting career, I guess. I used to train tour directors around the world, so I'd fly to Costa Rica, for example, and train people. I also had a small business that I actually used to run yoga and surf retreats. So I've always worked with people, and every once in a while I would need a website made. And I would give a bunch of money to a developer and never know what was happening behind the scenes. The finished product would never come as I wanted it. And it was kind of this black hole that I was throwing money into. So I wanted to learn it for myself, and that's kind of how I got into the field. And next thing you know, I really enjoyed it. and decided to make the career move based on the fact that A, it's a great industry to be in, and that I found it interesting. The next question was, how did you get your first job as a dev? So I actually got my job as a developer 5 months after starting with HTML. I didn't know what HTML, CSS, JavaScript, any of that stuff was. Didn't really know how the internet worked. 5 months later, I got a job, and not even as a junior developer, but as an intermediate developer. And that's nothing to show off, but just to show you how fast you can progress through this career if you really work for it and understand the fundamentals. So the first job that I got, I actually applied by messaging a bunch of companies that I was interested in and finding their email, their CEO's email, and letting them know that I was interested in a role and that I was solving a specific problem that they had. So I would research a company and say, hey, I noticed that, you know, your website or your app could have this and this fixed. This is how I would do it. Or I would message a CEO and be like, hey, these are my past achievements. I've recently turned into a developer, and I guarantee you I will work twice as hard as anybody else on the team, and just kind of make a grand promise, I guess, in order to really catch your attention. So another question was, and how did the interview go? I actually had multiple offers when I first got my developer role, and I think I was able to get those offers not because I was the best developer in the world, and by no means am I that now, but I think in the interview what I was able to do was to convince them that I will work harder than everybody else. And I made sure to do that by showcasing that A, I come from a different background. I'm not a computer programmer that graduated with a degree, and I turned that actually into an advantage by telling them all the other things that I've done beforehand, and then finally showing them that I was a self-taught programmer just like yourselves, and showing that I had the ambition and determination, so that by the end of the interview, I was able to convince them that although I may not be the most skilled developer out there, I'd be the hardest working, and I would make sure that I would learn these things so that I'd become a really, really valuable employee in 6 months. And I think if you're able to do that, you'll be surprised how many more offers you'll get, because there are a lot of developers out there, but it's really, really hard to find developers who A, can follow instructions, B, can work hard, and C, aren't so confident in their abilities that they have a narrow vision and don't take others' inputs. So if you're able to convince somebody that you're going to help them out, you're going to work really, really hard, and that you're going to be an asset to them that will make their life easier, I think that is a great, great way to land a job. All right, next question from Wan is 3 books that have inspired you in some way. And I've chosen non-coding related books just because I think the coding related books, all the popular ones, everybody knows, or you can Google them around. But the 3 books that have really inspired me, one is the 4-Hour Workweek by Tim Ferriss, that some of you may have heard of. It's a very popular book. I don't like the actual content, tips and tricks, but I really like the way that Tim thinks, and he thinks in efficiency. And I'm obsessed with using our limited time to the most efficient degree possible. So that means, what is the best way for me to learn a topic and not waste my time? What is the best way for me to learn something and get rewards as soon as possible? And I'm sure you can notice in this course, that's what I did. I wanted to find the most efficient way possible to start earning money as fast as we can and start working in teams as soon as we can, because, well, we have limited time and we're able to learn a lot more when we're surrounded by others, when we're working in development teams. So that book, not just in developing, has really influenced my life to make sure that I think critically about what I do to grow in career, personally, financially, emotionally, just everything, to try and look at everything and analyze things. The second book was the So Good They Can't Ignore You And this book is by Cal Newport. And it's a book that I read and it changed my thinking completely once again. And it taught the idea that passion isn't really a thing. When we're young, we think that, you know, we're passionate about traveling, we're passionate about, I don't know, surfing, and we try and follow this passion. But this book argues that passion actually develops from mastery, from becoming really, really good at a skill where people start paying you money for it, where you become respected in your field and people have admiration for you. And when you become really, really good and master at your craft, well, that's when you become content with your life. That's when you feel like you're providing value to people. And that book has really, really shaped the last couple of years for me. It's why I've really gotten into coding and I've really started to enjoy it more and more. It's because I've become better and better at it. So I highly recommend that book. Finally, the third book is Smart Cuts by Shane Snow. And this is the book that I recommend to everybody taking the course, especially those that don't come from a computer science background. It talks about how you can actually climb the ladder of success, not by just, you know, following the traditional path, but by jumping from side to side. From, if, for example, you were an actor and now you want to become a developer, well, this book argues that that's actually better because you're able to use whatever you learn into that field and jump on this other ladder of developing and use those skills that no other person has, such as communicating well with people and being empathetical and mimicking body language from each other. That's something that, you know, not a lot of developers know. So using those side skills to your advantage. You can definitely check out the book. It's really, really good. Highly recommend it. All right, next question, your opinion on the blockchain technology. Very, very cool stuff. I'm actually really interested in it and I'm writing a blog post on it. I think everybody should learn the blockchain data structure. You can actually do it in JavaScript and build this simple one quite easily in a day. And I think it's very, very exciting. I think there's a lot of hype around it. I wouldn't recommend investing in it. But, you know, to each your own. I think the technology is actually very interesting and there will be big changes in 2018 and the field will grow really, really fast. All right, this is getting long, so last two questions. We have, what is the meaning of life? I'm probably the worst person to ask that to. I have no idea, but I can tell you one thing that I live my life by, and I heard it somewhere. I wish I could credit the person that I heard it from. Provide more value than you capture. And I think that's really interesting. And this is what I did try to do with the course. I tried to provide a lot of value, as much as I could, and you know, there are times that it really, really sucked making this course because it took a lot of hours, a lot of editing, and a lot of times where I didn't like the video, so I had to redo it over. But I wanted to provide something really valuable and just capture a little bit of the benefit. And I like this way of thinking. I like this idea of providing out as much value and not necessarily capturing it and getting upset if, you know, your course gets copied and torrented and people download it for free. If you're able to help a bunch of people, that's great. If you're able to capture a bit of the benefit, that's great as well. But I think that's a really nice way of looking at things, and if we all strive to do that as web developers, to capture a little bit of the value that we provide to the world, I think the world would be a better place. All right. Last question. How many messages do you get every day from your students? I mean, well, this number has definitely increased. You know, I'm very, very excited about it. I can't believe that we have over 2,000 students now, and I definitely spend a lot of time. I wish I kept track of things, but you know, I wake up in the morning, I spend about an hour answering messages, then in the afternoon I spend another hour or two answering messages and questions, and again at night I do that as well. And if I don't do that 3 times a day, I won't be able to keep up with it. I'll have to figure out a better system to it because I do want to answer each student, and I want people to feel comfortable asking me as many questions as they can, but I do also want to continue providing new videos, and evolving the course to be better and better based on feedback. So we'll see. It's been so much fun right now and so exciting that, as some of you know, I've quit my job to focus on this course full time. So all the feedback, all the community, and everybody that's helping me out on Slack, answering questions, and trying to form open source projects. It's been really, really fun, and this is probably the most fun I've had working in my life, and for that I really, really thank you. I think you're all amazing, and I think what I provide to you is perhaps 20% of the value. I think the community and the support that we're creating with this course is the big benefit, and I hope it keeps growing, and I hope it becomes something bigger than I ever envisioned, and I hope all of you by the end of this get what you want out of it, whether to improve your skills, to get a job, or just to get a little bit smarter. So I'll see you in the next video. Thanks for watching my face talk for, I don't know how long this video is, but it felt really, really long. I really, really appreciate all of you. Thanks so much. Bye-bye. Hey there, this is my face, Andre. I'm usually sitting in front of a computer, not in front of a camera, which I'm not comfortable with, but this is the AMA video, and wow, I want to just absolutely thank all of you, because we have officially hit 100,000 unique students, which is insane, absolutely mind-blowing. I did an AMA video when we hit 1,000 students, and I thought that was just extraordinary. And to be at 100,000 now is absolutely incredible. I feel extremely lucky. I feel extremely blessed, and not to get too sappy here, but I'm very, very thankful for you watching this video right now, because I don't really do any marketing, and it's all grown out of word of mouth. So thank you for telling your friends, your family, your kids, whatever it is. I am extremely thankful that I get to do what I do, and it's all because of you. All right, so no more sappiness. Let's get to it. I asked you on Discord some questions that you might have for me. There were a lot of questions. Unfortunately, I won't be able to answer all of them. I don't want to make this into a boring 1-hour video. So I've picked the ones that I thought had a lot of people interested in them, and hopefully I can give you some answers. Keep in mind that you should form your own opinions and decisions based on these. This is just one person's view, my view. It doesn't mean that I'm 100% correct. If I thought that, then I would have a YouTube channel. But take it with a grain of salt. These are just my opinions. I may be wrong, I may be right. It's just what has worked in my life. Doesn't necessarily mean that it will work for you or the answers are right for you. All right, let's see. First one here. We have Nick Solar, who asked, what's the best way to get into machine learning and artificial intelligence? That's actually a question that kept coming up. A lot of people are interested in machine learning, data science, anything related to AI, because it is extremely popular and a hot topic right now. I actually have a course coming up on it that tries to tackle that question, because machine learning right now, it's a bit of a buzzword where it solves all your business problems, when in fact maybe it's not necessarily so. And I think there's developer interest to learn about machine learning, as well as business analysts and business decision makers to use machine learning and data to improve their profits and their business. So I didn't really give you an answer for that one, but it's one of those topics that I think in order to learn about it, you should at least learn to code, become a web developer first, or perhaps have some understanding of business data analysis before you get into it. All right, next question is from NK. Talk about your life as a developer from start until now to learn from you. Well, I think some of you know from my previous MMA, I did not come from a computer science background. I came from a business background. I did also a minor in psychology and learned to code in my 20s. I'm 33 now, by the way. Hopefully I don't look 33, but that's my age. And yeah, I would break down the developer lifecycle into 3 phases. So the first one is where you're just learning. You're learning to code. Everything is completely new. You feel extremely overwhelmed. You don't know what to learn, what person to trust, what mentor to have, what course to take. That's a really big challenge, and getting to the point of understanding and being able to build something from scratch yourself, I think that's the first phase. The second phase was when I was employed for the first time, and the first couple of years working as a developer, where you feel the imposter syndrome, right? Where you feel like you just don't know enough, or somehow they hired you by mistake and, well, everybody else around you is smarter than you. That phase really goes by. The one advice that I have for that phase is to honestly be comfortable with being uncomfortable. That is, ask as many questions as you want. Don't feel like by raising your hand and asking a question, it's going to make others look at you like you're dumb or not good enough. The more questions you ask, the better you'll have the answers, and you'll find that the successful people through this phase are the people who ask a ton of questions. When they don't understand something, they try to learn and try to grab as much experience as possible from those around you. And then the third phase is when you start to become a little bit of a senior developer, when you start to get confident in your abilities. You perhaps start to lead projects, perhaps other junior developers look up to you and ask you questions. One of the biggest things with that phase of a developer is to not almost get a God complex, where you feel like your opinions are the right ones and everybody else's is absolutely wrong. I've seen way too many really good developers get overconfident in themselves and have really strong opinions where they don't take anything else into consideration. I think through that phase, if you're able to understand that everything has pros and cons, everything depends on the situation, and that you're not, oh, I only use GraphQL, oh, I only use TypeScript, and dynamic languages are trash. When you avoid those strong opinions to almost make yourself feel like you're smart, you're doing something wrong there. You want to be open to ideas, open to suggestions, and not forget to keep growing from that phase, because as you start to get more and more recognition, maybe you feel more confident, it's very easy to think that you've reached the pinnacle and you need to stop learning. This whole industry is all about learning and constantly evolving, and what you know 2 years from now will probably be different than what you know now. So those are the three phases, kind of the ones that I went through. Obviously, I'm teaching now, but for me, learning doesn't stop. I'm constantly learning. I'm constantly trying to improve myself, both in teaching, but also as a developer. And I hope that that is the case with you as well. All right, next question. Next question is from SG. How many countries have you visited during the last year? Any suggestions to travel while working remote? So for some of you that don't know, I work completely remote. I carry my recording equipment online, and I set up my studio wherever I am in the world. So my courses have been recorded in Ecuador, in Nicaragua, Colombia, in Greece, in Romania, pretty much anywhere that I'm traveling. I bring my recording equipment, set up my little studio, and record. So last year I traveled to, I would say, about 7 or 8 countries where I lived in them long term. My favorite was I actually recorded the Master the Coding interview course in a little house on the side of a volcano in Ecuador. We're the last house at the very top of the volcano. So we had to hike down and grab groceries every time we needed to eat or wanted to cook dinner, and hike back up with all our groceries. That was a lot of fun. Any advice for remote? Honestly, it's one of those lifestyles that it sounds nice, but it also requires a lot of dedication and commitment to work, instead of just not being committed to a schedule and making it really easy to go off and pretend like you're busy without actually accomplishing anything. So you do need to have a bit of structure, but for those that are self-motivated and determined enough and can keep track of tasks and don't get distracted often, it's definitely a lot of fun. All right, this next question, I think I got asked maybe 5 times from people like Dorjan, Shupar, Scramblelock. All of them essentially said, why did you quit your full-time job? How come you're not a developer anymore? Well, let's say that I'm still a developer. I do a bit of consulting work on the side. The reason that I quit my developer job was mainly because I wanted to travel a bit and take a break. I had spent a couple of years working for other people and working on projects that perhaps I didn't care too much about. I was working for other people's passion projects or businesses, and after a while that kind of gets old, or at least it did for me, where I found that I stopped learning as much. It was just repeating and doing the same thing over and over. So I decided to quit and kind of figure out what I want to do next. And along the way, I decided to record some videos, my first course, Zero to Mastery, to just keep myself busy and keep doing something and help people who were like me, where they didn't have a CS background and wanted to get into web development, but there wasn't a clear path for them to do so. So I recorded that course and it took off, and all of a sudden this became my full-time job. And now I would 100% still go back to being a full-time developer, but I'm having so much fun teaching. I still get to code every day. I still get to learn every day. And if anything, I think this way I have a bigger impact on people's lives than I did when I worked on a single project. So that's why I quit my job, and in the end of the day, it was one of the best decisions I ever made. I have another question here, which is, what is my biggest regret? I feel like I'm in an interview right now, so I'll give you my interview answer in case you ever get asked this in an interview. So my biggest regret, honestly, there's nothing. I'm really happy that I learned coding when I did, in my 20s and not when I was young, because when I was young, I was able to learn different skills. I was able to learn about business, about psychology, about communicating with others and people. And those skills helped me get my first job as a developer. Although maybe I started to code when I was a lot later on in life, it's not like I didn't do anything before my 20s. I was learning different skills. And for those people that perhaps are thinking, am I too old to learn to code? Or I'm in my 30s and there's people, in their teens that are learning to code right now. There's no way that I'm going to be able to keep up. Keep in mind that most likely you have skill sets that other people don't. And when it comes to regret, honestly, there's nothing. As long as you're learning every single day and learning something useful, over the years, that's going to compound. And honestly, every single mistake, every single decision that you make leads you to where you are now, which sounds a little hokey pokey, but it is true. Honestly, there are no regrets. If you're learning, you're never going to have regrets in life. All right, Yex, how's it going, Yex? Asked me what annoyed you the most about being a developer. I usually don't get annoyed. I'm pretty easygoing, but the one thing that I did notice was that as people get more and more experience, they tend to form really strong opinions. And everybody wants to feel like they're part of a group. And I think we see that a lot on Twitter and YouTube, and all these people with really strong opinions that kind of gang up on other people that have different beliefs than them. I think it's very easy in the developer community to have something like that, where you're thinking, my React team is better than your Angular team, or TypeScript and static typing is the way to go, or REST is dead and let's all use GraphQL. I think when you have that type of mentality, it's really hard to actually have smart discussions and decisions within a project. It becomes really easy for those who feel superior to others and feel confident in their opinions to really impose their opinions on others, especially junior developers that are susceptible and have less experience, so they start to believe these senior developers that perhaps have really strong opinions. And in turn, that kind of creates this wave of more and more people that think it's a good idea to have strong opinions and debate with others and argue with others and telling people that their code sucks and their code is the right way of doing it. I think that was a little bit annoying to deal with because I think it influences junior developers a lot, and I don't think it's a good attitude to have when working with others. I think being somebody senior, being a lead, being a project lead, means you're a person that doesn't put other people down, but it lifts others. And that was a little bit annoying because I saw that was a little bit prevalent, where everybody's trying to almost outbeat each other and be a better developer than this person and this person, instead of all of you growing together and learning together, because there's enough developer jobs for everybody. You don't need to beat out everybody to be the #1 developer. So that mentality was a little bit annoying to me, but then again, I worked in Toronto and Silicon Valley, and I think those areas especially have really, really strong individualistic philosophies. All right, this is another question from DH. From where and how did you learn and become a developer? So when I started to learn to be a developer, I probably spent, I would say, $20. I think I bought a book on HTML and CSS, and the rest was all online for free, just using online resources. The only difference was that when I started to learn, there were very few resources online. I think I used one blog post that told me to use Photoshop and GIMP and some tools that I actually didn't even need, but it was really hard to find resources online when I started to learn. So I essentially just try to grab as many resources as possible and create my own curriculum, but it's not like it is now. I think right now we have a lot of resources online. It's a lot easier, and there's more of a clear-cut path to become a web developer. So I'm a little bit jealous, but I also did the same thing that you probably are doing, which is watch a lot of online courses, read a lot of books, read a lot of articles, and most importantly, building my own projects and coding as much as possible. That nothing beats actually coding. You can watch videos all day, but if you're not doing anything, if you're not producing anything, it's like watching a tennis match and trying to become a better tennis player. It's just not going to happen. We have Jamie who asked, what's the best way to practice code? Is it good by imitating someone else's code for practicing? Again, goes back to my last point. The best way to practice code is to code. The more you code, the more you practice, the better it is. But keep in mind that the best way to code is to solve your own problems, create your own projects. I actually don't recommend just watching all my videos and following along without coding, because then you're not going to be able to do things on your own. The best way to code is to code by doing your own thing. You can watch 100 videos on people coding and follow along, but if you don't understand why we're doing things, then when you're left to your own device, you're not going to be able to do anything. So the best way to code is think of a project today, think of a task that you have to do over and over in your life, and see if you can automate it with code. That's the best way to learn. Ty Lim asks, what is your favorite tech stack? My favorite tech stack is the one that lets me accomplish my goal as fast as possible. That's a very vague answer, but honestly, anything that lets me finish fast and deliver something fast is my favorite tech stack. Because I tend to work by myself or in small teams, I really prefer things that are efficient. So for example, I'm not a big fan of TypeScript, because although you get type safety and static typing, it's a lot of extra code. It's the same reason that I personally am not a big fan of Java programming, not because it's not a great language, but because for my personal use cases, I'm not working at a big company with thousands of developers for, let's say, a financial institution. If I'm building a personal project, I'd rather use something quick and easy like Python or JavaScript to write a few lines of code and accomplish a goal. So there's really no favorite tech stack. It's the stack that allows me to accomplish the goal the fastest, which happens to be usually dynamically typed languages, and usually the languages that I'm comfortable with. I don't need to learn something new until I have a need to learn something new. All right, S. Morales Jr., that's what it is. Any advice on escaping the golden handcuffs and going freelance? I have a cushy non-developer job at Google, and it's hard to imagine leaving when I have a family and a mortgage, but I long for freedom. And this topic of freelancer is another topic that has come up many times. So let me address it right now. I get to work remotely. I get to work for myself, which I feel very fortunate about, and I'm extremely lucky. But when it comes to freelancing, I actually am against freelancing. Obviously, every situation is different, but let me explain why I think freelancing might not be the best option for most of you. Not all of you, but for most of you. You see, when it comes to freelancing, let's say you're just starting to learn. You're just learning to code. If you go straight into freelancing, you lose the ability to work with others, to learn from others, and actually be in a company and understand how their processes work, how they work with developers. You gain a lot of experience by working on projects with others, with other developers, working with management teams, working with project managers, scrum masters. That's a really, really valuable experience that I really recommend for people just getting into coding. Now, let's say that you've had a couple of years of experience. You've worked with teams, you have that experience. Should you go into freelancing? I think you should go into freelancing if you have a clear edge or a clear advantage over others. For example, you have an existing client base and you have people that really trust your work, or you offer a really unique skill. The problem with freelancing right now is that you're essentially battling with thousands, potentially millions of other freelancers to get a job. A lot of people might go to places like Upwork or any type of place where you can bid on projects. What happens is, in those scenarios, people just bid, and it's a battle to lower and lower prices. So what happens, you eventually become an employee of a contract that you probably didn't charge enough for. So it's really hard for you to compete with people that keep lowering and lowering and lowering prices, and you'll see that if you're a freelancer, that's what will happen. Unless you have an established client base, unless you have a really distinct advantage, maybe you're extremely skilled in graphic design and you're well known, then yes, maybe you can charge more for it. But people that are usually looking for freelancers are usually looking for the cheapest price. And when you do that, you stop valuing your time. You stop being a slave to the person that created the contract, and you're trying to fulfill and please this person so that they give you a good review for the next contract job. I think freelancer jobs can be good, but there's also a lot of issues that come with it. If you want to be a freelancer or perhaps be your own boss, I think there's better ways for you to go about it. I think there's smarter ways to go about it instead of competing with others on price. So I know that's not really helpful. It's just my personal opinion when it comes to freelancing, but it is a question that I get asked a lot. Freelancing essentially involves you taking a lot of time finding clients, working a lot for clients, and at the end of the day, why not just work for a company that already has the clients for you so you can gain that experience? You might think you have the freedom of being a freelancer, being your own job, but instead you're an employee of whoever your contractor is. That's my advice. I know it's not very, very helpful. But like I said, it's not for everybody. I think there's better opportunities for you to work remotely. You can work for remote companies. There's tons of websites right now of showing companies that hire remote workers. I think that's a better option for you than being a freelancer because the reasons that I mentioned previously. JT Avares 8 asks, how is life as far as time spent with family and doing what you like now as an instructor and before when you work for a company? Do you enjoy work more now or before when you work for a company? Hands down, I absolutely love what I'm doing now. I wake up every day and all I can think about is work and what I'm going to teach or what video I'm going to record or what coding challenge I'm going to do. I feel so extremely lucky to be at a point in my life where I absolutely adore and love what I'm doing. And I wouldn't trade it for anything in the world. Being a developer was absolutely great. Working full-time for a company, I loved it. I had a lot of friends. I got along really well with my bosses, with my clients. But having the freedom to to work on what I want, to work on my projects, but most importantly, knowing that the work that I do maybe impacts just a little bit of the world, I think is a really rewarding feeling, and I'm extremely thankful to know that, you know, not everybody's going to love my courses, but at least there are some that do enjoy my courses and gain a bit of help in their career through it, and that is the most rewarding feeling. And honestly, the past 2 years since I've started to teach have been some of the happiest moments of my life, and I know this thing isn't going to last forever. I know I'm not going to teach forever, but I'm really appreciative of this moment to have this opportunity, at least for now. All right, Mr. Luciferus asks, a safe, secure, and stable life being a skillful employee working for someone else, or dreaming big and starting a business on your own and being your own boss. What path do you suggest? Honestly, it really depends. I think everybody wants the ideal work for yourself, own your own business, work remotely, live wherever you want. It sounds sexy, but it's not for everybody. And you know, before I started teaching, before I was a developer, I started a bunch of businesses. I was running surf and yoga retreats in Nicaragua. I was doing adventure tours. I was doing adventure race businesses. I was trying all these different things that in the end weren't extremely successful, but they were a lot of fun. And meanwhile, I had friends who were doing their MBAs, they were becoming lawyers, and you know, they have really nice life right now. They have families, they're very comfortable, and there's actually an advantage there. As you start to work at a company and you see people leave that company, most people think, oh, I should leave too. But you can also look at it as an opportunity for somebody else has left. Now you are one step closer to going up that corporate or company ladder. So I think it's not one is better than the other. It really depends on what you prefer, what kind of lifestyle you prefer. Do you want more of a stable, comfortable life to make sure that you can provide for your family, or are you at a stage in your life where you can perhaps take more risks and you're okay with the high ups and high downs that may pay off, may not in the end. But I think every day, if you're working towards what your ideal life should look like, eventually you will get there, but don't expect to get there overnight. You know, it's hard work. Nothing comes easy. There's no easy solution. So all you can do is kind of work towards that goal and learn every day and improve every day, and eventually you'll get there. But it really matters. It's the best thing you can do is to have a plan for yourself, and write down what you value, and based on those values and what makes you happy, decide what type of path you want to take. I got all philosophical there for you. All right, let's get back to some coding. Justin W. Lin, hey Justin, asks, how do you decide to learn next in this ever-changing landscape? From Redux, GraphQL, React, Angular, Vue, SSR, there's so much to learn, so little time. So I guess, how do you decide what to learn then, and how you actually learn and make time for it? I think this is actually something I'm pretty good at, or I think I'm good at, and that is because when I started to learn how to code, I realized how much is out there. I've become really good at selecting only the right things to learn. And there's the famous Pareto principle, which says the 20% usually accounts for 80% of value. So what's the 20% that's going to give you 80% of value when learning? And you know, things like GraphQL, for example, they're extremely popular, so a lot of people want to learn it. But at the end of the day, how many people actually use GraphQL in production? How many people have actually built something with GraphQL that creates a value? I like to look at technologies and see what's hot and what's trending, but not necessarily jump really deep into them until there's a clear need for me to learn it. So, for example, Vue.js. Yeah, I know a bit of Vue.js, but I wouldn't call myself an expert because I haven't had to use Vue. I can use React, or I can use Angular. So being selective in what you learn instead of trying to learn everything is going to be a better long-term strategy over the course of your career, because learning never stops. And the more you learn, the more you start to realize that it's not about the syntax. It's not about learning the libraries. It's not about reading the documentation from start to finish. It's about understanding the higher principles, the why was this tool built? Why are we doing things the way it is? What problem is it solving? Being able to understand those and discuss those is going to be really, really important, because at the end of the day, the fundamentals is what matters, not the syntax. If you learn the fundamentals, if you learn to think like a developer, think about systems and how things communicate, that's a lot more valuable than learning the newest React hooks API. I mean, that could still be important, but as you can see, I'm very selective in what I learn. And I'm not trying to learn 10 languages at the same time. If I want to learn something, I'll dedicate maybe a year to get really, really good at something and then move on to the next thing. So really being picky, as if you're dating a new technology, and making sure that it's the right one is the way to go. Oh, and with that said, you obviously have to enjoy what you're doing. If you don't enjoy learning, then that's going to be really hard. So that's just something that has to come for yourself, and being able to enjoy the learning process, because that's going to be your biggest asset. If you enjoy learning, you're going to learn more. Adrian asks, how long do you plan on continuing doing courses? Because, well, this isn't going to last forever, right? Honestly, I'm not sure. It's been close to 2 years now that I've been doing this. I don't imagine doing this for a lifetime. There's only so much I could teach. I'm going to keep going until I stop enjoying it. Right now, I really enjoy the process. I get a lot of reward by hearing your reviews and how pleased you are with the courses. So that really drives me to create more. But eventually, I will have to stop. I can't just keep creating courses. They do take a lot of time and effort. So I hope that I can keep going for a few more years. But one day, maybe retire and spend a little more time with family or move on to something else. But for now, don't worry, I'm not going anywhere. Balloon asks, do you play any instruments? No, I am the least musically talented, artistically talented person you'll ever meet. I took piano lessons, guitar lessons when I was a kid, and I'm hopeless. Thank God coding exists, and thank God sports exist, because if I had to do anything in the arts, I would not be very good. Garasan asks, it would be really inspirational for all of us to what do you want to do with the next 10 years of your life? Coding, business, looks like he's the same age as me, so just asking what's the next 10 years of my life look like? The next 10 years of my life is going to involve learning every day. I want to, whether it's coding, whether it's different things, I have different hobbies that I want to keep improving at. I really like surfing, so I want to become a better surfer. And there's so many things that I really want to improve. So honestly, every single day, my goal is to learn. I want to hopefully have a family by then, and have a house, and just enjoy life. And hopefully in 10 years, I'm retired, being able to spend every single day with my son or daughter, and just enjoying life. But honestly, what I'm doing now is not much different than what I hope to be doing 10 years from now, because I am really, really happy with how life is right now, and I wouldn't really change anything. Dorian again asks, do you think all the races you do and yoga and exercises help you mental clarity and have helped your career as a developer when things get rough? Yeah, so fun fact, I'm also a yoga instructor on the side, and I do a lot of adventure racing as well, and both of those things I think actually really help with being a developer and dealing with different situations at work. I think for adventure racing, it puts you into situations that are extremely uncomfortable that you have to just survive through, and then with yoga, obviously, it stills your mind, especially with meditation as well. I think those are extremely important, especially when compared to coding, when you're staring at the screen and everything is usually fast-paced, and it's really, really easy to get lost in your head. I think balancing out coding with something that's complete opposite, like yoga or meditation. Again, not to get a little hippie here, but I think doing different things is important, and being physically active, being mentally strong this is your vessel and this is your body, and you should take care of it, and it will only improve you as a developer and as a coder. So I 100% think that, although for some people it may be silly to meditate, although for some people they don't enjoy exercising, everybody has their different things, but I think doing something other than coding is really, really important for that balance and to not burn yourself out. Asim Ahmed asked about interview and the fact that he's really worried about interviews and that he doesn't know enough. And honestly, just keep this in mind, because this is something I hear from so many people. Everybody is just a child trapped in an adult's body. No human knows everything perfectly, and most likely the person sitting across from you that's asking you a question on an interview doesn't know everything, has their own insecurities, has their own areas that they're not an expert in. So go into an interview knowing that this person is not God. It's not the ultimate smartest person that you'll ever meet. They have their flaws and their issues. And if you start to realize that there's no such thing as a perfect developer, a perfect coder, and everybody is just trying to pretend like they're smart, everybody's just trying to pretend like they're an adult. Remember, everybody's just a kid trapped inside an adult's body. You start to realize that this whole world that we live in, this whole system that we're in, is just a game. Just like you're a coder, just like you're a programmer and you're trying to create a system, this is simply a system that you need to learn, to adapt to, and to try to essentially beat or improve. So put yourself in their situation. They want to feel important. They want to feel like they're doing a good job. So maybe asking them questions during the interview, maybe praising them for something that they did, even though they're the ones being interviewed, is going to make them feel better. That perhaps will make them ask you better or easier questions. Again, think of it as a system. Think of it as a game, and realize that there is nothing is extremely serious and important. Everything is just a game that you can play and that you can improve. And if you start looking at life, at interviews as a game, I think it becomes a lot more fun, and it also removes some of those insecurities. I don't know if that answer helped, but kind of went on a tangent there, but hopefully that helps a little bit. All right, last question, because this video is getting a little too long. So Charles Manchin asks, what's a typical day for you at the moment? Your courses are that's very kind of you. Seem to be your healthy way of living and your sporty attitude. It'd almost be worth a course on how to balance your life and the way you do things while you code. I guess I kind of already talked about this, but my everyday life usually involves in the morning drinking coffee, reading articles and catching up in the industry, learning a little bit. I really like morning for learning, and then I usually either record or plan recording or edit videos in the afternoon. Then around 1-2 o'clock I usually go out for a run, do some exercises, try to get outside, not stare at the screen, and be active. And then I come back. I usually check out my emails, answer questions, go on Discord and chat with other students. And then usually by 5 o'clock, I'm done. I don't do any work. I stop whatever I'm doing, because I know after 5 o'clock, for me personally, I'm not productive. So I usually spend time with family, with my girlfriend, or do social activities, or maybe go play some tennis, go play some soccer, go for a hike, just to relax. And I usually go to bed at 10 o'clock. Not that very exciting. I don't enjoy going to bars or clubs anymore. I'm an old soul, and at 10 o'clock I'm ready for bed and I'm ready for the next day. So a pretty boring day, nothing too exciting, but it's what I like. All right. Anyway, this was the AMA video. Again, I want to thank you. I cannot believe that there's 100,000 students that are taking my courses, and honestly, if it was just me, I would never get to 100,000 students. It's every single one of you that talk to others, recommend my courses, that really help me get to where I am. And I cannot express how thankful I am for everything that you have done, that you have shown support for, and I hope to continue to keep impressing you and keep helping you with your learning journey. And yeah, I'm really thankful. So thank you.
Woohoo! We did it. We finished RoboFriends. We finished our app. Now we can forget about it, and it's going to live forever and ever on the internet. Right? Well, maybe not. You see, part of using a library is something we've already talked about. A library or a framework is constantly evolving, constantly changing. And every time you use a tool, you usually want to stay up to date. This is one of the challenges with being a programmer, that you always have to stay up to date. I mean, sure, your projects could live on GitHub, but eventually they get stale. If they have a lot of dependencies or libraries that they depend on, then things might not work as intended. Now, this doesn't mean that you always have to jump on the latest and greatest. And as libraries come up with new features, you don't necessarily need to jump on them right away. But in these next couple of videos, I want to actually show you what my steps are and what most programmers' steps are when things change. Because if you have an application that is running, that has users, most of the time you want to keep things up to date. And this is something we've already talked about. But what about things like React? We learned about React in this course, and we're starting to get comfortable with it. But again, because it's a library, it gets updates because it's being used by companies like Facebook that has teams that constantly need new things, find challenges, and want to improve it. Ideally, things are always improving. So React had a big update. As of version 16.8, it got something called hooks. Now, if you know anything about React, everybody is going a little crazy with hooks because they are quite a big shift. They are exciting, but can also be intimidating for a beginner. And you can see over here in their documentation that they have a new section on React hooks. Over the next couple of videos, we're going to be talking about React hooks, what they are, why they're useful. But instead of just showing you point by point, as it is in the documentation, how hooks work, because let's be honest, you're able to do that on your own. That's what these documentations are for. I want to show you the process, how I would learn something new when a library changes, when a library has a new feature. Now, the reason I haven't talked about hooks up until now is that, well, even React documentation actually doesn't talk about hooks until way later in their guide. When you learn about React, their main concept, some of the advanced guys, some API references, they don't mention hooks until the very end. So when you learn about React, it's good to put off hooks until you actually understand the concepts, which hopefully you do until now. So let's say React comes up with hooks. How would you go about learning it? Well, obviously you'd start off with the documentation and start going through it and actually understand it. Now, starting in the next video, we're going to learn about hooks, but I'm going to show you the process of how I would learn about hooks, and then also convert our RoboFriends app from using the class stateful components to using React hooks so that you can compare them side by side and see what the differences are. I'll see you in the next one. Bye-bye. Welcome back. Let's learn about hooks and also teach you how the process should be when you learn something new with a library. Because again, your job as a programmer is to be really good at problem solving, be able to adapt to changes and solve problems. So let's say hooks was just introduced to React. The very first thing I would recommend to do is to read the documentation, but more importantly, read the motivation. Why did the library add this? Why did React decide to add this thing called hooks? Now we see over here that they're a new edition as of 16.8. And if you're watching this video now, there's probably a way later version of React. So as long as you're using this version or higher, you're going to be able to use this new feature.
Now, I'm not going to read through the entire documentation for you, but I do want to point out one thing. The number one thing I do when I look at a library and see some of the new changes, I want to look at the motivation. Why did they add it? So if I scroll down, look at that. They have the motivation. Why do we need hooks in the first place? Now, sometimes to learn what the motivation is, you have to actually understand the library and have used it before. And hopefully by now you're comfortable with React. So let's just go through the motivation quickly, and then we'll get to coding because I know that's the exciting part and that's when we'll actually learn. But the 3 things to keep in mind is that 1, with the ways that we've used React up until now, it's really hard to do this. Reuse stateful logic. What does that mean? Well, if we had some logic of, let's say, changing state in our class components, sometimes if we want to do something similar in another component, it's a little harder to do with the way that we had it before. Hooks makes this a little bit easier. Again, something that we'll see shortly. Next is that complex components become hard to understand. You see, as components become bigger and bigger, especially class ones with component did mount, component did update, component will unmount, all these lifecycle hooks, things that can happen within a component, hooks make things a little bit cleaner. You can see over here, hooks let you split one component into smaller functions based on what pieces are related. Again, hard to really understand unless we code it. But the biggest motivation, and I think this is something that a lot of people overlook when talking about hooks, is that some people find classes confusing. This keyword, the bind function that we have to do. Classes are just daunting for some people, such as doing super props. Why do we do that in a class? So hooks allow us to not use classes, not use the this keyword in our React applications. And another major reason that is overlooked is that React wants to do something called ahead of time compilation one day, hopefully for performance, something that things like Svelte, Angular, and Glimmer do. And by not having classes, it makes this easier for them to do so. But you know what? This is a lot of talk, a lot of gibberish, maybe hard to understand. I think the best way to learn about hooks is to actually convert our RoboFriends app from using class components to using hooks. And I'll show you what that means in the next video. Bye-bye. All right, let's convert our RoboFriends app from using classes to using hooks and learn about what the differences are. So the very first thing I want to do is, well, clone this repository. So we'll use our RoboFriends example, and I'll just say git clone and grab this repository from GitHub. Or you can use your existing project. Now I'm going to go into the RoboFriends directory. And the very first thing I always want to do when I clone a repository is obviously npm install. So let's run that to install all of our dependencies. All right, npm install worked. Now, one of the things that will happen, and this is something we've already talked about, is that whenever you're revisiting an old project or grabbing a project from GitHub that has been around for a while, is that, well, you'll get a lot of vulnerabilities because libraries haven't been updated. So the first 2 commands that I always like to do after npm install is npm update to update my libraries. All right, only one low severity vulnerability after the npm update. And sometimes I also like to run npm audit fix just to make sure that we're not missing anything. And looks like we're good to go. You see here that there is one vulnerability that requires manual review. So we'll have to manually update those. But for now, I think everything's good. Everything's up to date. So we can start using hooks. Now, the very first thing I want to do is to make sure that we can use this new feature. Remember that hooks came with React 16.8. So let's go check to see that we have React 16.8 or higher. So I'm going to open Visual Studio Code. And I know, shocker, up until now, I've loved Sublime Text, but it looks like a lot of people like Visual Studio Code, so I have to conform to what everybody else is doing just so that you get to see a different editor as well. All right, so we have our terminal here to the right, and then we have our RoboFriends app. If we take a look at package.json, let's see over here what version we have. We see that we have React 16.13, so higher than 16.8, so we should be able to use hooks. Awesome. The very last thing before we move on to the next video and finally introduce you to hooks, because I've talked a lot about them and you still have no idea what they are. Let's just do npm start to make sure that everything still works. We've updated our packages. We want to make sure that things are still working. So npm start, hopefully we get no errors. All right, looks like things are loading up. On the console, there's no error, and I can search my robot friends. And again, things are working. Awesome. All right, time for hooks. I know. I keep building the suspense, but I promise next video, we're going to find out what hooks are. See you in that one. Bye-bye. All right, it's time to learn about hooks. Now, the very first thing that we need to answer is, what are hooks? Well, if we take a look at the documentation, there's a section here that says, what is a hook? And we see over here that hooks are a function that let you hook into React state and lifecycle features for function components. Hooks don't work inside classes. And that's the thing. All hooks are is if we go to our container, the app.js, let's minimize this. There you go. The app.js is using a class component. And remember, hooks are a way for us to avoid using classes so that we can avoid the super keyword, the this keyword that some people find confusing. Even things like component did mount, that these lifecycle hooks that sometimes can get confusing. So hooks allow us to use functional components, which, remember, we have talked about. Our components are functional components, right? They're just functions that render something. But before hooks, we only created functional components once when we didn't have any state inside of them. All these components are what we call just presentational components, right? They just return something. They just receive props and return some sort of a view. But anytime we wanted to use state, we had to convert those functions into a class component so that we can do this .state and declare our state. With hooks, what you get is that you can now add state to a function. So because we have version 16.8 or higher of React, we can convert this app class into a function. Now, here's the thing. I want you to practice reading documentation here. Oftentimes, whenever we are introduced to a new concept, our default is to, hey, let's go find a tutorial online. Let's go buy a course that teaches us this. But the best resource is usually the documentation. The documentation is created by the people that actually created React, actually created the hooks API. So they usually have good resources for you to learn and use. So as an exercise, before we dive into the next video and I show you how we can start converting this with hooks, I want you to go into the hook section of the React documentation and see if you can figure out how to keep this app the exact same way that it is. It still works. You can still search through your robot friends, but you convert this class app into a functional component. And instead of having things like constructor or component did mount, to just convert this all into using hooks. I'll give you a little hint. In order for us to do this, we'll have to import two things from React that we now have available because we've updated. One is something called useState, which is a hook. So it's called the useState hook. And the other one is called the useEffect, which is another hook. You see, hooks essentially give us that. They give us hooks like this from the React library for us to implement and use inside of our functional component to finally have state and lifecycle methods. So if you want to give it a go and convert this into a functional component that uses hooks, go ahead. Otherwise, I'll show you how to do this in the next video. Bye-bye. All right. Hopefully you were able to do that little bit of a challenge. If not, no worries. I'll show you how we can convert things into using hooks in this video. But again, hopefully you got a chance to check out the using the state hook and using the effect hook in the React documentation. Because it's not as hard as it seems. Remember what I said. Hook is a special function that lets you hook into React features. So the use state and the use effect hook allow us to hook into a React feature because it's from the React library to either work with state or with lifecycle methods. So the first thing I want to do is to actually remove this component from here because we're no longer using that component class to extend app. Instead, we want to change this into a function, right? So I can now say function app, and we remove this and turn this into a function. So let's scroll down here. Next is we no longer need this constructor, super, and this.state. Because we're now creating a function, we can, let's say, comment this out for now just so we can see it. We are also going to comment component did mount because inside of a function, there's no such thing as component did mount. Remember, we got component did mount because we were able to use the component class in here that gave us this feature, this lifecycle hook. So now we can't use this either. And then because this is a function, what we need to do is turn this into a variable. So the onSearch change and the render is no longer needed. Instead, we'll have this piece of code that just simply returns out of the function. So if I save this, I'll probably get a few errors. All right, so I have useState is defined by never used. UseEffect is defined by never used. onSearch is assigned but never used. And that's because onSearch now is just a variable inside of this function. And you see that we're using the this keyword here. Remember what I said, because we're no longer in a class, we don't need the this keyword anymore. So if I save this, we have one less error. Now, if I go back to our app, we have some errors. Cannot read property state of undefined. And that's because, again, we're using the this.state here, and we've commented out the constructor that gave us state, right? So this.setState that came from our component class no longer exists. This.state no longer exists either, again, because it's no longer a class. So how do we create state now? Remember, hooks give us now the power to have state inside of our apps. And we do that using the useState hook. Let's find out how to do that in the next video. Let's talk about the state hook. And this is the most common, most important hook out of all of them. And if we check out the documentation, we see that the useState is a hook. We call it inside a function component to add some local state to it. So this is exactly what we need. So we need now the useState hook to replicate whatever we did in the constructor here to create the state. So the way we do that is a little tricky. So hang with me here and then I'll explain exactly what's happening. We first declare a constant, and in here we'll do array destructuring. That is, the useState hook is going to return for us two things. One is the robots. Remember, this is part of our state. And the second thing is the function that changes this robots. And usually the standard naming convention is to say set with the name of whatever the state that we're changing is. So we'll say set robots. So const robots is the state now, and set robots is the function that changes this state. So we're going to say equals use state, which we've imported from here. And then in the use state, we give it the initial state. So what's the initial state of robots? Well, right over here, it's an empty array. So we just give it an empty array. And again, this is a bit of a magic that's happening with React. This idea of hooks isn't a JavaScript context. It doesn't really exist in the JavaScript world. Hooks are very React specific, so there is a bit of magic that's happening. In this case, we just need to understand that useState returns for us just by doing this. It's going to return for us, one, a piece of state, and second, the function that changes that state. So we can change or name these variables whatever we want to describe our state. So that's our first piece of state. And then the next one is the search field. So once again, I'll say const. And what should we put here? Well, the search field. And then the function that changes the search field. So again, using the standard, we'll do set search field is going to equal use state. And what is the initial state? Well, the initial state is an empty string. There you go. That's it. We've just recreated this part, except now our function has state. It has the robots state and it has the search field state. And you'll also notice that it's not in one big state. Instead, we've sliced things. So we have one state for robots and one state for search field, and we keep them separate. Now, this initial state can be anything you want. You see here how this.state was an object, and if we wanted to, we could make this into an object, but this is completely up to you and what state you want to have in your app. Now, another thing that tricks a lot of beginners is this array destructuring, which is a new JavaScript feature. Essentially, what this allows us to do is it allows us to name our state whatever we want. So even though useState returns for us a piece of state, which will be an empty array initially, and a function to change that state, by using array destructuring, we can customize our code and name it whatever we want instead of the useState library that React gives us, naming it in one way that everybody has to use. This is just simple array destructuring to name our variables. Now that we have a piece of state, we'll forget about the component did mount for now. We're going to go to the on search change event. And we see here that instead of doing on search change, what we'll do is remove this .setState because we're no longer in a class. And instead, to change the search field, all we need to do is say set search field. So this .setState changes to set search field. And this search field can be changed. So in this case, because we just give it exactly what the change needs to be, we can just remove the object here and just say event.target.value is going to set the search field. So we got rid of a this. And then what else do we have here? This.state here we no longer need because again, we don't have a state object. Each robots and search field is already here. So we can just remove this entire line because we already have access to robots and search field. And then if we go here, robots.filter, we have that. Any more of this around here? Nope, everything should be good. Let's save. We see that set robots is assigned a value, but never used. And that is because we haven't implemented the component did mount yet. But let's have a look. If I go back to our app, it's loading because we haven't fetched anything, But if I open up the developer tools and console, and let's just log out over here. Let's just do console.log robots and then search field. If I save and go back, we see that we have an array and an empty string. So we have state, we've created state inside of our function using the useState hook that allowed us to finally do exactly what we did with a class component, but in a functional way. Next step is to add the lifecycle hooks. Again, remember what hooks are. Hook is a special function that lets you hook into React feature. We've hooked in to the state feature of React so that we can create state. The next part is to hook in to the lifecycle events that we got with classes, but this time within a function. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about the second most important hook, and that is the effect hook that comes with React. Now, the effect hook adds the ability to perform side effects from a function component. It serves the same purpose as component did mount, component did update, component will mount in React classes. Again, remember, the whole idea of hooks is to be able to do the things that we were able to do inside of a class, but this time inside of a function. And we see here that we can use effect like a function and just tell it what we need to do. So let's give it a go. I want to use effect now to replace this component did mount, because right now our robots aren't being fetched. Our friends are non-existent because we're not fetching. So let's do this. Let's do use effect. We have that because, remember, we've imported over here. And use effect is going to run like this. And inside of use effect, we have to tell it what is the side effect that we want this function to do. So I'm going to just create an arrow function. And inside of here, we're going to put this fetch call that we had in component did mount. So let me just comment that out. Make sure our spacing is correct. And inside of here, we now have use effect. And this use effect gets run every time the function app gets run automatically. So we see over here that we're calling use effect because of the brackets, and inside of here, we're telling it, hey, what's the side effect? So this is something important to remember. By default, React runs this use effect function after every time it renders. So when app renders, it's going to run the use effect and whatever is inside of it. Now remember, we no longer have this .setState. Instead, we have, what are we changing? We're changing the robots. So I can say set robots right over here. And this set robots is going to get the new users. Like that. Now, let me save this and see if this works. I'm going to save. All right, compiled successfully, no errors, but do we get our robot friends? Let's have a look. Hey, look at that. We have our robot friends. Love it. Can I search through them? What? Look at that. So simple, and it works just as expected. But let's take a look at the console. If I open up the console, I don't know if you can tell here, but look how many times this render function is running. It just keeps going. It's actually running in an infinite loop right now. Let's take a look and find out why that is. And this is another tricky part when people get started with hooks. Again, it's often commented in the documentation, which you can read on the React website. Now, this use effect actually has a second parameter that it receives. Remember, the first parameter is the function, what it should do when app renders. And the second one is this. If present, which is an optional argument, if present, effect will only activate if the value in the list changes. What does that mean? Well, use effect receives an array as a second argument. Now, before I just show you what this does, let's have a look at why exactly the use effect was running continuously over and over and over. Well, if we look at the code, when the app renders, it creates the state, right? That's the initial state. And then it runs the use effect because it rendered. So it fetches the users, and then these users are going to update the state. It's going to update the robot state with the new users. So what happens? Well, new users are being rendered right here. So the app re-renders and says, hey, I got new robots. So I need to re-render myself to show the robots. So it re-renders. But remember what I said with use hooks. Every time the component re-renders, it's going to run use effect. So it's going to run fetch again. And then it's going to set robots again. So it has to re-render. And then it goes use effect again, then set robots. So it goes into a continuous loop. And the trick with use effect is that if you don't want this to constantly re-render, then you wouldn't want to set state inside of use effect. But if we are setting state like we have here, we can give it an optional list. And this optional list tells us in here, hey, when should I run use effect? So you can tell React to skip applying the effect or the use effect function if certain values haven't changed between re-renders. So in here we say, hey, only run use effect if one of these have changed. So for example, if I put in robots here and I save, what will happen? If I go back, oh, you see that it's still running. Look at that. It's still running, still running, still running. Why is that? Well, because robots changes, right? We always run set robots. So that means, hey, run use effect because robots changed. Hey, run use effect because robots changed. That's exactly what we're doing before without the second argument. But in here, if we do, let's say, search field, only run use effect if search field changes. If I save this and go back, there you go. It no longer goes into that infinite loop. But if the search field changes, you'll see that we're fetching again. So that's not good either. Instead, we want to give it an empty list or an empty array. Because what does that mean? It means, hey, only run use effect when this changes. But when the list or the array is empty, it's a shortcut for doing component did mount. Hey, just run use effect initially when the component mounts, when app is rendered. So the component did mount shortcut is essentially this, adding an array. I know it's tricky, maybe it doesn't make sense. It's just a quirk, a thing that you just have to remember with React. Remember, hooks aren't a JavaScript thing. It's just a way to use React that you need to get used to, just like you had to get used to this .set state. So by having an empty array here, I now replicated component did mount. So now if we just move console.log over here to use effect, so inside of use effect, we'll ignore the warnings for now. If I go back, you'll see that it's an empty array. But as soon as I type something, no other updates are made because use effect is only run once. Versus before when we didn't have anything, and you see that it was going like crazy. So this is a shortcut. Remember, component did mount, we just add the empty array. And then we can give it different options inside of this array. Now, if you're using Create React App, this actually gives you a hint here whenever you're using it incorrectly. So React hooks use effect has missing dependencies, robots, and search field. Either include them or remove dependency array. And what this is saying is, hey, inside of use effect, you have two pieces of state, robots and search field that you're using. Now, in our case, we're just console logging. But it gives you a warning saying, hey, don't you want these to run if you're using them inside of use effect and add them to the dependencies? So it's saying this, hey, just add these. And you see that it's compiled successfully. But again, we don't want to do that because remember, robots change all the time. So if we do that, it turns into an infinite loop. So let's remove and remove. There we go. I'll see you in the next one. Bye-bye. All right. So I know this part is a little tricky. When you first start off with hooks, it can be a little overwhelming. It's why the React documentation doesn't really teach hooks until later on, because it makes a lot more sense once you understand this idea of class components, this idea of lifecycle hooks. But if we just remove our alt code that has been commented out, you see that our code reads pretty nicely. It's just a function, except this function now has some state that we usually declare at the top, and a use effect, a side effect that we do every time we run the app, and we tell it when we want to run this use effect in the second argument that is an array. The other parts are pretty self-explanatory, just like we've built components before. Now, to really solidify our knowledge here, I want to do one other thing just to make sure that we really get these hooks concept. Let's say I wanted to create a button. And let's just say that this button lives right here, right below our title. And this button is going to say just click me. And it's going to have an onClick function. And this onClick function we haven't written yet, but I'm going to just say that it's going to have a set count that we haven't created yet. So this is going to be a function that changes a new piece of state. And this time around, we'll just have a new count state. So I'm going to create a piece of state. I'll call it count and set count. So you kind of see the repetition here. We're just creating state at the top with what the state name is and what the function is that changes that state. And I'll say use state. And I'll just give it a count of 0. So this is going to be 0. And this set count is going to be right over here. And when a user clicks, it's going to run set count. And we'll just say count plus 1. So we're just incrementing a counter. So on click, set count, and it's going to add 1 to the count. If I save this and go back, you see that I have click me here, and let's just console log this so we can see it. Let's do it right after the fetch, just so we understand exactly what's happening here. If I do console.log count, okay, if I save this, we should understand what the error is, or the warning that we get on the right side. Hey, how come inside of use effect you have count, but you're not adding anything in here? Let's just save this and see what happens. If I go over here, see that I have 0. If I click me, nothing happens. And why is that? You should be able to answer that, right? Because we've added no dependency to this use effect, nothing in the array, which means, hey, just run it once when app loads. If I refresh the page, again, just run it once. But after that, don't run it. So how can I solve that? Well, we just add count in here. And that's what the warning is telling us. Hey, don't you want to add count? If I add count, now every time I click, it's going to run the use effect. But this also means that we're constantly fetching our users. If I go to the network tab and I click me, you see that we get users. We make that fetch API call every time. So this line simply means only run if count changes. Right? And that should make sense. I just wanted to show that example just so you understand exactly what is happening here. Because at first, use effect can be tricky. But hopefully this clears things up for you. Now, I'll link to the repo of this finished code so you can play around with it and try new things. But hopefully, hooks aren't as intimidating as you initially thought. At the end of the day, we're just converting our class components into stateful functional components. I'll see you in the next one. Bye-bye. Welcome back. So should you replace all your React class components with functional components with hooks? Well, not really. One of the key things in the React documentation is that hooks work side by side with existing code, so you can adopt them gradually. Classes aren't going anywhere. They're going to be around. For example, the creators of React, which were the developers at Facebook, say, at Facebook, we have tens of thousands of components written as classes, and we have absolutely no plans to rewrite them. Instead, we're starting to use hooks in the new code side by side with classes. Just because a library introduces a new feature doesn't mean that your code now needs to all be updated. Hooks are just an additional tool in your tool belt as a programmer for you to use. But out there in the wild, there's still lots of class components. If you work for a company, you're most likely going to see class components. So you need to understand both things, but also understand some of the ways that hooks might make things nicer, depending on your team, depending on your situation. So React documentation actually doesn't recommend rewriting your existing components overnight. You can start experimenting with hooks, starting to use them, start getting comfortable with them, but by no means is your code incorrect just because you use classes. You see, libraries change all the time. New APIs are formed all the time. That's why when you work as a programmer, it's not about learning the latest and greatest tools just to show how current you are. What you need to do is to be able to read documentation, understand what is the motivation behind the change, what is the motivation behind the new feature, and learn to use it slightly. And then if you need it, if it makes you productive, if it makes your code more readable, then use it. But don't use it just because it's new. So I recommend playing with your RoboFriends app, trying out different hooks, but I do want to go over two other things. One is the rules of hooks. There's two things that you have to remember. You can only call hooks from React function components. So you can't really call them outside of that. Only call hooks from React functions. So you can't actually call hooks in regular JavaScript functions. Remember, hooks are very React specific. So what you learn about hooks doesn't translate to anywhere else but React, which is a little unfortunate. And also part of the reason that I'm not spending too much time teaching you hooks. The next one is that you can only call hooks at the top level. You can't call hooks inside of loops, condition, or nested functions. So you declare a functional component, and at the very top, you use hooks. Just like we have had here. I can't use effect or the state inside of if conditions or other functions. Again, just rules that we have to keep in mind because they are React specific. Finally, you can actually build your own hooks. Remember, one of the main motivations that React introduced hooks was to have a reusable state logic. If you have complex state logic, like let's say in here, having a friend status with is online and set is online that you want to use across different components, you can actually create your own hooks and combine use state and use effect and share it across components. Now, this is very dependent on the component that you're building, so I do recommend you read the documentation, because if you go to the hooks API reference, beyond use state and use effect, there's a few other ones that you can use. As you can see, there's not that many, and most of the time you'll be using these two, but you can quickly get started in understanding how these work or even create your own. But the thing I want to remind you is that in your career, you're always going to see new features added to the tools that you're using. It's not about just jumping on the bandwagon from day one and converting your app to the latest and greatest, newest feature. Instead, decide for yourself. Learn about what it does, what the motivation is, and decide for your own project, for your own team, whether those updates are necessary. Often, senior developers are able to not jump on the bandwagon right away because they know that new things are constantly changing. New things are still being adopted. Best practices are forming. So take your time when new things are introduced to a library. Understand the motivation, read the documentation, play around with the feature, and then decide for your situation if it's the right thing to do. I don't recommend spending too much time on hooks unless you really want to get into React because it doesn't really translate anywhere else. And the reason we've taught this section in this order is because classes are things in JavaScript that you can use in other parts of your projects, other parts of your programming career, versus hooks is so specific. So unless you want to be a React developer, it's not really worth your time and investment learning them. Now I have full dedicated courses on React if you want to dive deeper. But otherwise, I think we're pretty happy with this RoboFriends app. I'll see you in the next one. Bye-bye. Welcome back. Before we start learning about Redux, we need to talk about something called state management. We've heard this word before, state, right? When building a React app, we had this.state. And state described what our app should look like. If we remember this, well, React is simply a group of components that are rendered in a tree-like structure. So this would be the app.js, for example. And each one of these components would have state. For example, the red dots over here, they have state. So for example, this app component will have a state of signed in as, and let's say the state is user. In that case, this user component might have a state of user Mitch. Or if signed in as is admin, it might render the admin component. And anytime you see the blue dot, that means there was a change. So if there's a change here, it can update something into this component and re-render. And we did this in React. And I want you to think of state as memory. An app needs to remember things in order to work. Otherwise, we would just have simple HTML web pages like before. Remember this Keiko Corp website? This really doesn't have any state, does it? Each time, we show the exact same web page to whoever is using it. This page has no idea of who the user is or any interactions that I'm having. It's mainly just text. Now, the RoboFriends app, that's different. It has state. Well, mostly because we wrote it and we had the this.state, but we can interact with it. I can type in here Leanne, and I have a state of the search box having LEA in it, and the robots being filtered with just Leanne. State describes how our app should look. Our app, our RoboFriends app right now, should look like this with just one robot card because the state is of a search box having the letters LEA inside of it. Now, with a simple app like the RoboFriends app, state was pretty easy to understand. But state management is a really hard problem as our apps get bigger and bigger and bigger. And you'll actually see in the later part of the course when we start working on the SmartBrain app, which does the image recognition, you'll notice how the state gets more and more complicated and your head starts to hurt because you have to keep track of all these things happening. So again, with a simple React app, we can have nice views and maybe have different states and different components. But eventually, as our app gets bigger, we end up with something like this, where we have more and more components, more and more state within that component, or we can have one massive state at the very top here, which also gets pretty hard. And all these blue dots, as they update, they also have to update the state and then re-render. And this example over here is just a little diagram, but you can see with all these arrows how confusing it's going to get, and keeping track of all this state is really, really hard. So we need some form of a state management. And Redux solved this problem for us. How can we make this diagram simpler and make things easier to understand in our heads as developers? Redux came up with a novel concept. What if we just remove all the state, so this.state, from all the components? What if we just have props? So all these components just have props being passed down. And now the state, we keep it in a store. And a store is simply just the state, which is this.state that React had, but in one massive object, just like you see here. So one single object that describes how our app should look, and all we do is just pass down that state to whichever component needs it as props. So our diagram, from looking like this with just React, can go to looking like this with Redux, where none of the components need to hold state anymore, and we can have one massive object that describes our entire app, and whichever component needs that prop can just be passed down to it. And any updates that happen go through the state gets modified, and then we pass down that information to the component. This diagram might be confusing without actually coding anything, and we'll come back to it so this makes sense. But even just visually, you can see that this diagram looks a lot simpler than the diagram before it. We have a lot less arrows and everything just flows nicer. So as we go through the videos, you're going to get more and more familiar with this idea of state management. But I want you to keep in mind that that is what Redux is solving. Redux is a library that makes state management easier, not only for React, but for any tools that we use. It just happens to work really, really well with React. And Redux actually got inspiration from database design, from things such as event sourcing or CQRS, which you can read up more on. Databases had the same problem. All these updates and all these changes happened, but we needed a way to make sure that all these changes are organized in a nice, cohesive way. All right, let's get into the next video and get a little bit deeper with Redux. I'll see you in the next one. Bye-bye. Welcome back. I know we're all getting excited to start coding, but I want to do one last video before we actually start working with some code, which is the exciting part. But again, I want to emphasize that before we use anything, we need to understand why and why we would need something like Redux. Right now online and with any company that is working with React, most of them have also Redux. So you'll hear React and Redux app mentioned a ton when you're watching tutorials or working with React. And that is because they go really, really well together. Let's just go over a few things about Redux that we want to make sure we learn. And a bit of warning here. Some of the stuff might go over your head or might be a little bit confusing. But I want to show you these slides first because after we go through the Redux coding, we're going to come back to them and make sure that these principles are applied and they make sense to you. So bear with me, trust me, it's all going to make sense by the end. Why do we want to use Redux? As we mentioned before, Redux is really, really good at managing state, especially large state. So Redux is a library that we would want to use if our apps get bigger and bigger and bigger, and they have a larger and larger state. Remember, we want to use tools based on the problems that they solve. And Redux solves the problem of what happens when React apps get really, really big, and using just this.state just doesn't make sense anymore. It gets more and more complicated. Remember, React is what we call a view layer. It's really good at the view side, but not necessarily at managing state. So use Redux when things get really, really complicated. The second point is useful for sharing data between containers. And this is another thing with when projects become large. When they need to start sharing state between containers. With React, this is actually a little bit difficult, and you have to move the state up one layer so that you have a parent that can share state between the two. But with Redux, this becomes really, really easy, as we're going to demonstrate in our coding section. And finally, Redux has predictable state management using the 3 principles. Now, what are the 3 principles? These 3 principles in Redux are going to really, really make sense at the end, but I want to still introduce them to you so that we're aware of them. The first one is the idea of single source of truth. And this is a fancy way of saying that we have one single big object that describes the entire state of the app. Remember this? We had one massive state object that describes everything within our app. So we have our single source of truth. Because React reacts based on whatever the state is, we can just have one big object that describes how the app should look, and React will take care of it. The second principle is the idea that state is read-only. And this encourages something called immutability, which is not modifying the object. And it prevents unexpected errors this way. So the state object that we will create with Redux will actually never get modified. And instead, we would create a new state after each action is taken by the user. And then finally, the third principle is the idea that changes are made only using pure functions. Something that we've talked about in my previous course. The idea that a pure function is something that receives an input and always returns an output that is predictable. If we enter the same input 1,000 times, we expect that function to have the same output 1,000 times. Using these principles, Redux has some new words that we're going to introduce in our vocabulary. And we're going to be comfortable with them by the end of this section. The first one is action. An action is something that a user does, such as clicking on a button or a drop-down menu. And what happens in Redux is as soon as a user clicks on something, a button, and creates an action, it goes through something called a reducer. And a reducer is simply a function, a pure function that receives an input, which is the action, so the user just clicked on a button, and creates an output. And this output is the state, or the store, as we call it in Redux, which is the entire state of the app. So as it goes through the function, the store gets updated, and React, because it notices this state change, makes changes to the view layer. Again, these are words that we're going to encounter as we start coding along. Now, why do this? I mean, can we just have an action, and then an action happens, and then we just make changes? I mean, that's how something like jQuery used to work. And yeah, it looks more complicated, doesn't it, adding all these steps beforehand? But as you can see above, if you have tons of actions happening, which with modern apps that are very interactive, this happens a lot, where the user scroll action and then it clicks a button and then highlights something and so on and so forth. You see that the more and more actions we have, the more changes we have to make. And those changes might trigger other actions, which trigger other changes, and so on and so forth. And it can get pretty complicated, as you can see in this diagram. Well, with Redux, we make sure that all the actions go through one reducer. Everything flows through this function. And through this function, it always, because it's pure, returns the same state based on the action and updates the store. And this store now, which represents what our app should look like, makes changes. So it kind of funnels all these actions into one reducer so that everything is predictable and nice. Again, one of those things that's hard to really explain without encountering the problem first, which we'll get to. Now, Redux, and I want to teach this just for historical purposes, uses an architectural pattern called flux pattern. Architecture in software is used as a way to make sure that we're able to solve problems in a logical sense and in an organized fashion. And this flux pattern, which inspired the library Redux, has this idea of having an action and then having a dispatcher that dispatches this action to the store, which is our state, which updates the view. And it's one-way data flow. Everything flows one way. If the view gets updated, we go back to the action and again goes through dispatcher that dispatches the change to the store and then to the view. And this was a pretty revolutionary idea because before that, we had something called MVC, or Model View Controller. And you may have heard of it. It was quite popular. The idea with an MVC pattern is we have an action, and that action is read by a controller. So again, another JavaScript file that looks for actions. User clicks on a button, and based on whatever the controller says, we update the model or the data in this case. So we can think of it as state. We change something in the model, and then it updates the view. Now, the problem with the MVC pattern is, well, this diagram over here. We have the controller that changes different pieces of the model, and this model can change the view that can trigger another change. And that model can change another part of the view, and so on and so forth. And we have this thing that we saw before. We have the craziness of actions and making changes. All these arrows just crisscrossing and not looking very nice. And although it might not be bad when your apps are smaller, as your apps get bigger, you want to do something like this so it's logical and makes sense. And that's what we want to do with architecture. We want to architect our apps in ways that as they grow, although we may add a few things, in the end, everything is easier to reason about and understand. So we have the flux pattern, which enforces a unidirectional data flow. We have the MVC pattern, which could definitely be improved. If you get anything out of this video, the one thing I want you to understand is the idea that Redux, at the end of the day, is pretty much the same as this.state in React. With Redux, we can replace this.state and theoretically remove all of this.state from React and have it all happen inside of this Redux library, which again, we're going to do. But one caveat. You could technically have Redux with the state, but also still keep a little bit of React state in a component. Redux doesn't replace completely the this.state or this.setState in React. You can still use them together. And I'll show you when you might want to do that, when it's a good decision. But like I said before, without having gone into any of the code of Redux, this might look a little bit overwhelming and confusing. I promise you that we're going to come back to these diagrams and things are going to make sense by the end. Before I throw code onto the screen, I want to make sure that you have some principles and concepts that we're working from. All right, I know what you're thinking. Andre, I am sick and tired of these slides. Even though they have this cool grading color, I need to see some code because I'm getting bored here. Well, you know what? Your prayers have been answered. In the next video, we're finally going to start writing some code and get into some fun things. I'll see you in that one. Bye-bye. And welcome back. We know how the RoboFriends app works now with React. That's great, but Bruno asked us a specific thing. We need to add Redux to our RoboFriends app so that it can scale well and handle state management better. Now, with these next videos, we're going to work together. Step by step, I'm going to show you how Redux is implemented and how it works, and you're going to be following along, trying to make sure that your code works as well. All right, so take a pause now and get your environment set up so you can code along with me. You're all set? All right, I'm going to get started. The first thing I'm going to do is I have my RoboFriends app, so I'm going to clone this repo. And we'll just do our regular setup with git clone, and then I'm going to cd into my RoboFriends. Perfect. Let's open this up in your text editor. And again, I love joining these together so it looks nice and clean. Perfect. Now, obviously, the first thing we need to do when we clone something is npm install to make sure we have all the packages. And we also want to make sure that everything is running smoothly without any errors whatsoever. So the next step is going to be to run npm start. All right, perfect. Everything is working and we should be able to filter. Perfect. All right, so we're familiar with this code base. We have our React app, but that's it. Just a simple React app with containers and components. The very first thing we would want to do is install Redux. So I'm going to close this and run npm install Redux. This Redux package will give us some tools in order to incorporate Redux into our React app. But here's the cool part with the Redux package and why I'm such a big fan. It's that 90% of your code is still going to be JavaScript. Redux is going to give you a few helpers, but you're still writing JavaScript. It's still improving your JavaScript skills when you write Redux. And it teaches really, really good principles, which is why I'm such a big fan of the library. You might not always need Redux in your projects, but it is just a good tool to learn because it has such great concepts that you'll use throughout your career. Now, the second thing we need, and this is something similar with React. Remember how we installed the React package? And then we also needed something called the React DOM package to connect React to the DOM. Well, in similar fashion, we need to connect Redux to React because Redux theoretically could work with any other library. By adding another package, we can again let React know that, hey, we're going to be using Redux with you. So that's very easy to do. We'll just npm install, and the package is called React Redux. And the way this React Redux is going to work is that it's going to connect only the containers, so in this case app.js, to the what we call a Redux store, or that big JavaScript object we're talking about that describes the state of our app. And they're going to communicate, the container is going to communicate with the store, and vice versa. Now, the other components, what we call DOM or presentational components, won't know that Redux exists. The only connection is going to be between something called a container or a smart component and the Redux store. So let me show you what I mean. If you remember this diagram, we've just installed the Redux package, which you can think of it as being over here. This red box that allows us to create a store and a couple of other help functions. We also downloaded React Redux, which allows us to connect these two pieces. And React Redux is able to be used in order to say, hey, we want these yellow components to be aware that we're using Redux and to get their state from the Redux store. So just think of this diagram as we're working through it. All we're doing is essentially connecting these two libraries together. All right, so now that we have these two packages, we can start importing them and using it within our app. But that's for the next couple of videos. I'll see you in the next one. Bye-bye. Hey, it's me again. I wanted to take a quick note about a new tool that has come out called Redux Toolkit. Now, as we learn about Redux, you'll notice one thing that's a little painful that some people don't like about Redux, and that is the idea that Redux has a lot of boilerplate code. You have to learn new patterns, you have to create numerous files to accomplish something that would have been really easy to do in just React. Now, the added benefit is that it makes our code more maintainable, more scalable as our apps grow, but it does mean more typing by developers, more files, more boilerplate. And boilerplate simply means code that you write over and over that's kind of similar. And you'll see when we start building things like actions, reducers, how you're writing repetitive code. And Redux Toolkit was created for this reason. It's the batteries included toolset for efficient Redux development. They take a lot of the manual hard work with Redux and generates a lot of really niceties for us. Now, we aren't going to use the Redux Toolkit in this course simply because I think it's important for us to practice and see how Redux works without any magic behind it. By doing things manually ourselves, we'll better understand how Redux works. But after you're done with this section, I do recommend you check out Redux Toolkit. I recommend reading through their documentation, and once you get used to building apps with Redux, then I do recommend that you use Redux Toolkit to get started fast and avoid some of the boilerplate code that you might have to write over and over. Just a quick note. All right, let's get back to it. And welcome back. Now that we have Redux and React Redux installed, let's start writing some code and implementing Redux. Now, the first thing we want to do is create something called an action and also a reducer. If you remember this diagram, we mentioned that Redux has these two components, an action and a reducer. So we're going to build those two out and show you what I mean. The first thing we want to do is create a new file. Let's just keep it in the source folder. And we'll say that this will be called actions.js. And within here, we're going to create an action using just plain old JavaScript. We're going to say that export const, and the first action we're going to do is the search field. So remember, when we type into the search box, we can filter the robots. We'll say that that action, which is on search change that we had in the React app, we'll say that this is going to be called set search field. And this search field will receive an input of text, which the user types. And because we want to keep this as small as possible, we can actually wrap it in curly brackets so that we can avoid the return statement. We're just returning an object, and this object is going to have a type called, let's say, change search field. And we'll also have a payload called text. So that is, this action is going to, which is called set search field, is going to take text, which is what the user inputs, and it's going to return an object that has a type of change search field. So that's the action that's being taken, and it's going to send, and payload is a common name that is used in Redux, so just get used to that. Payload is we're sending whatever data is needed to go on to the reducer, which is just going to be whatever the user enters. All right, we just created our action. That's it. That's our action. Nice and simple. Now, in here, I've capitalized this because it's a constant, and a constant is usually capitalized, all caps in JavaScript is just the standard. But I like using an actual constant variable because with just a string, we can misspell something and we might not get the error. But if we use a variable and we misspell it, we'll actually get an error when we're running the app. So it's a nice little nifty trick, and most Redux demos have a constant file as well, where they keep track of all these actions. And it's also nice to have a file where you can see what your actions are line by line, because most apps will have more than just one action, as you'll see. So let's create a new file, and we'll call it constants.js. And within here, we can just export. Let's make this a little bit bigger so you can see. There you go. We're going to export constant change search field. And that's going to equal our string. Again, this is the exact same thing, change search field, but the string. Seems a little bit redundant, but it's just good practice to have. So now that we have this variable, which is a constant, and because we're exporting it, we can just import it up over here. And we'll say change search field. Make sure that there's no spelling errors this way. And we'll say that import from the constants file. Now let's make this a little bit smaller, just so everything fits in. And there you go. So now we can use the change search field instead of the text. And there you go. We have a nice and good looking actions file with the set search field action. And you can imagine here, as we get more and more actions, we can keep adding things, and we can keep adding all the constants that we need for the actions that our app takes. All right, the next thing that we remember with Redux is after the action, we also have a reducer, which I said is a big function that just reads the action and spits out what we call state. So let's do that. Let's create another file here. We'll call it reducers.js. And within here, let's create that reducer. We first start off by saying const initial state. So we need some sort of a start point. So remember in our app.js file with create React app, if I open that up, we see that we have initial state with search field that is blank. So similar to that, we need to say that the initial state here is going to have the search field that is equal to an empty string. So that's the initial state. That's the initial object that we'll have in the Redux store. And now we need to create the reducer. Again, remember, it's a function. That's very easy to do. Again, because we're going to use it in other places, we're going to export it. And we'll say that this is going to be called a search robots, because that's the action that's taking. It's going to search the robots using the search field. So this search robots reducer will take in a few things. First is a state, which is the state of our application. And then the second thing is the action. So that is what action just happened. And using ES6, let's just give it default parameters to make sure that if this is empty or action is empty, we're not getting an error. So we'll say that state will be the initial state, which is what we have up here. And then action is just going to be an empty object. Remember, our actions are just objects that we're returning. So from here, using arrow functions, we have our first reducer. And reducers here, what they do is they get this input of a state and an action. And if they care about the action that they receive, in our case, if we receive any actions that are related to searching robots, we're going to do something. We're going to act upon the state. The way we're going to do that is we're going to use a switch statement. And we're going to say within this switch statement that we're going to do an action.type. And remember, action.type, that's something that we use in the action.js file. Remember, we have a type of change search field. So looking at this, it looks like we're going to care about the change search field action type. So let's just import the constants file up over here for Redux's or for our reducer as well. And within here, we can say that if the case that the action type, let's just do change search field. If that's the case, well, we want to return a new state. And this goes back to the three principles that we talked about. Let's have a look. The three principles in React is that we have the single source of truth, that is the one big object that describes our app. So we have our initial state variable that we've set. State is read-only. That means we can never modify that object. The only thing we can do is create a new object that has the same as before, the previous object, the previous state that we had, with whatever modifications we had. So state is read-only. And then the third thing is that changes only using pure functions. And remember, pure functions are functions that get some sort of an input, just like we have in our reducer, and return an output that doesn't have any side effects. That is, it doesn't modify anything. Every time we enter an input, it always gives out the same output. So based on these principles, if we go back, we know that we want this reducer to be a pure function. That is, it's taking some sort of an input and it should return a new state. And the way we do that without just doing state dot search field and modifying that property, we're going to do object dot assign. And the way we do this is curly brackets, comma, the state that we're receiving, which is the initial state this time. And then finally, whatever we want to change in that object. In our case, we're interested in changing the search field property, and the search field property is going to have the action dot payload. Again, let me just make this a little bit smaller. We're returning a new state, as you can see here with object.assign. That's going to have everything in the state, plus we're going to update whatever search field property, new search field property we have with action.payload. Remember, actions have two things that we're sending, an object with type and an object with payload. If we go back, we see type and payload. So this is simply saying we received an action called change search field. If that's the case, then return the new state with action.payload, whatever the user has entered. I know it can get a little bit confusing, but this is just standard Redux syntax that you'll just have to get used to. just a heads up, there's another way of doing this that some people like and is cleaner. Another option is to do object destructuring or object spread operator, which means we can do something like this, which works nicely as well. For now though, let's just keep it the way we had. And then always remember that a pure function always needs to return something. So in case that the action type is not this, we also want to say default to always just return state. There you go. We've created a reducer that is a pure function. Now here we could use an if statement if we want, but I like using switch, and React documentation also recommends switch because you can have multiple cases, multiple actions that act upon the search robots reducer. And it's a lot easier to just add on different things that affect the state of the robots. All right, that wasn't too bad, right? We've created a reducer with some initial state, and we also have our constants and actions. So that diagram that I showed you is starting to make a little bit more sense. In the next video, let's actually connect these, because right now it's not connected to anything. It's not connected to our apps, to our React app. We've just created these files that kind of live on their own. I'll see you in the next one. Bye-bye. Welcome back. Now that we have our actions, constants, and reducers, let's start connecting this Redux part of our application to our React application. Now, the way we can do that is quite simple. If you remember, we downloaded a package called React Redux. And this package, let's import it over here, comes with nice and easy API of just two things. One is a provider, and the other one is connect. And using these two things, we're going to be able to connect these two parts of our application. So I'm going to say import from React Redux. Now, in this video, we're going to talk about the provider, and in the next video, talk about connect. So for now, let's just have the provider imported. Now, within here, there's a few things we need to do. First is to create the store. If we go back to our diagram, we remember that there's something called a store in Redux, which is the source of all truth. That is, it's a big object, JavaScript object, that describes the state of our app so that React can render it, make changes, and display it to the user. So we've created an action, we've created a reducer, and we also need a store. So let's do that first. We can use the Redux package for this and say import, and it has a function called create store. Nice and easy name. And we're going to import that from the Redux package. Now, the way we create a store is quite easy. We can say const store equals create store. And within here, we put what we call a root reducer. That is the reducer of our app. Now, in real life, we have many reducers. If we go back to our reducer file, right now we only have one, the search robots reducer. But as I said before, applications get more and more complex, and you're going to have more and more actions that need to be taken. And we can keep listing actions related to search robots right in here, but later on in the video, we also need to get robots from the API, if you remember. Now, because of that, we're going to have many reducers. And in the store, we want to combine all these reducers to create one root reducer, which we're going to do later on. But for now, because we only have one reducer, let's just use the search robots reducer to create the store. And we need to import this. So let's go ahead and do that. I'm going to say import search robots from our reducer file. All right, so I have search robots here to create the store with, and that's it. We have a store. Now, this store can now be accessed and passed down into our app. Remember, with Redux, hypothetically, we can remove all state from our React app and keep it inside of the store and pass down the store as a prop. So let's see what happens if I do that. If I go store equals to the store that we have, and I save. And let's also open up app.js. And in the component did mount, let's just console log this.props.store. All right, let's run npm start. Gonna open up the console. And we have a bit of an error here. That's just a syntax error in our case statement. So let's fix that. If we go to reducers, we don't need the double quotes here or the semicolon here because we have it over here. All right, let's save that. And we get an error saying that search field is not defined in our reducers file. And again, small little error here. The way we want to pass the third parameter to an object.assign is as an object. So we want to go like this. And if we go to constant, small little error here. Let's save. All right. So everything is working. We have a warning saying that provider is defined but never used. That's fine because, well, we're not using it yet. But let's go to console log and see what happens. All right, we see that our store over here has logged out and we have a few functions that we can use, including get state. Let's use that and see what happens. Again, going to my index.js file. I'm going to say, or in our app.js file, I'm going to say get state. I'm going to save, go back, and look at that. We have our state, which just has the search field right now. All right, so we're passing down our store as a prop, and we can use get state. Very cool. Let's remove this console log since we don't need it. We understand what's going on now in the index file. We need to pass down the store to the app. Now, we don't really want to pass down the store all the way down our component tree to the smaller components over and over again. And React Redux gives us a nice component that we can use to do this very easily. We can simply wrap our app component in this provider component. Let me show you. We're going to have a provider component. And this app component is going to be inside of it. Just like that. Now, the formatting here is a little bit off, but it's fine for now. I just wanted you to see that the provider is wrapping the app. And now, instead of passing down store to the app, we can just include it into the provider component. And the provider component is going to take care of passing down the store to all the components down the component tree from the app. And we use something called connect, which we talked about, to finish this connection. So there you have it. We've created the provider component that passes down the store. And the store uses the reducer or whatever reducers that we have to create the store and create that object tree of our state. So in the next video, let me save this. In the next video, we're going to use the other part of React Redux to finally connect everything together. I'll see you in that one. Bye-bye. And welcome back. One thing I noticed from the previous video is in my constants file, I should make sure that my variable and my strings are the same. So just adding an underscore over here. All right. So let's talk about the next part, which is using the other method that comes with React Redux, which is connect. Now, this connect function is optimized in order for us to avoid using something called store.subscribe. So if you remember when we console.logged the store in our app.js, we had a few functions, including the getState function that we logged. Now, there's also a .subscribe function, which subscribes any component that is interested to be aware of Redux and listen to any changes. But that's a little tedious, and connect simplifies the process by simply saying, use the connect function, and with that, we're going to make the component Redux aware. If you remember, the connect components would be these yellow little components that know about Redux. So we've created the provider component that essentially passes down the store to the components, but now we have to say which one of these React components we want to be smart or be aware that the Redux library exists and they can subscribe to changes. So I'm going to show you how to do that in this video. And by the way, the standard in the industry is that we call these smart components containers, kind of like app.js. So we're most likely going to connect the app.js file because it is a container. So the very first thing we're going to do is go to app.js file. And within here, we want to import a few things. Let's start off with importing the actions. So I'm going to import the actions that we have. Let's go over here. We have the set search field action. So we're going to do the set search field action, and we're going to import that from the actions.js file. And because actions.js file is folder level up, since the app.js is in the containers, I'm going to do the double periods. Let's save that. And we get a nice little warning saying that set search field is defined but never used. Let's also save our index file. Perfect. Let's now use this connect method that I've been talking about. So at the top over here, I'm going to say import the connect method from React Redux. And this connect method, the way it works, and again, you just have to get used to it, is at the very bottom where we do export default, we're going to say connect is going to be a function, and then another brackets around app. Now, this syntax might look a little bit confusing. And connect is something we call higher order function. And a higher order function is a function that returns another function. So connect is going to run, and whatever connect does inside of this function is going to return another function. And because it returns another function, it's going to run this part with the app. So that's how higher order components work, and you'll learn more about these later on in your career. But for now, just know that this is the syntax. You just have to get used to it. And let's just add a new line so we can see it better here. Now, within here, connect accepts two parameters, which again are standard. I can name them whatever I want, but we're just following the Redux standards, which the first one is map state to props, and the second one is map dispatch to props. All right, so right now we've just connected this component, this app component, and said, hey, subscribe to any state changes in the Redux store. And now app knows that there's a Redux store somewhere, and anytime that there's changes to it, it might be interested in it. But now we need to tell it what to be interested in. That is, what state should I listen to? What dispatch or what action should I listen to? So let's go back to the top. And at the very top here, we want to define these functions or these parameters. So all we're going to do is say const map state to props. And this is going to receive a state. And it's going to return an object. And like I said before, you can name these whatever you want, but this is the standard, and any Redux app, you'll just see this. So just get used to the syntax. Once you do it a couple of times, it becomes second nature. All right, and in here, we want to say that the search field state, which again, if we go to our reducers, we have search field over here. This search field state is going to equal state, which we receive, dot the part of the reducer, which again, if we go to reducers, is search robots. So search robots dot search field. So again, it's saying that the search field that we're going to return, which is going to be used as props by the app component, is going to come from the state, state dot search robots dot search field, which again comes from our reducer. Because remember, in index.js file, we've created the store with the search robots reducer. So if we go back here, let's save that. And we have match dispatch to props is not defined. And again, because we need the second part, which is match dispatch to props. So let's again create that. We'll say that const map dispatch to props is going to receive something called dispatch. And again, something that you'll just have to get used to. Dispatch, if you remember in our discussion about Flux, is what triggers the action. So an action is just an object that we've created, again, if you remember. But in order to send this action, we need something called dispatch, so it gets dispatched into the reducer. So this dispatch can now be used to send actions. And the way we do that, we can say on search change, which is just a name that I can say anything. So remember, this is a prop that it's going to receive, but we're going to keep it the same as the one that we've had in our React app on search change. And so this is what the prop is going to be named. And the on search change is going to receive an event, because remember, it's a input box that users type. And this event, again, because on search change is a function, is going to dispatch the action set search field. Because remember, action is just an object, just a function that returns an object. we want to dispatch that so the reducers are aware of it. And this search field, when it gets dispatched, is going to listen to, if you remember in our actions, it's going to receive a text. That is whatever the user has inputted. In which case we can just do event.target.value. Again, just like we have in the on search change here, event.target.value. So if I save this, let me make this a little bit smaller and save now, I have a few little warnings. One is that remember, we need to return this as an object. So we want to say return, just like we did above with the state, an object that contains all of our action. Again, map state to props is tell me what piece of state I need to listen to and send down as props. And map dispatch to props says, hey, tell me what props I should listen to that are actions that need to get dispatched. All right, everything is working. We're not getting any errors over here. And remember now that down here in the connect, we know what map state to props is, map dispatch to props is, and connect is going to run the first part of the function and say, okay, I'm listening to this part of the state and I'm interested in these actions. And then it's going to give those props to the app. Here's the exciting part. Because remember, I said Redux can replace your state in your app. I can technically now remove the search field from this .state from the app. And I can also remove on search change because again, that's coming down as props. We don't need to declare it as a method of app. So I can delete that now. And then down here, I'm not interested in this .state search field anymore. I can remove that because now it's coming down as props. So instead, I can say const search field with capital F comes from this .props. And finally, the on search change doesn't come from this on search change, which was a method of the app. It comes from the props. So again, I can say on search change and remove the .this. Let's save that. And again, I'll get an error saying that search field is not defined because remember, with our Redux state, we changed the search field to have capital F. So if I change that so it understands that that's what we're interested in, everything is working. Now, here's a little gotcha. Right now, because in our index.js file, we only have one reducer, we're creating the store from this. If we go back to app.js, state actually only has one field, and that is search field. So we would have to do something like this in order for it to work. Now, we're going to get back to this point because once we start adding more piece of state and more reducers, we're going to have to get state from each piece that we're interested in. But for now, we're going to get back to that. We're just going to say state.searchField because if you remember in console.log store.getState, we just had the search field. So let's save that and go back. All right, nothing in the console, that's good. The moment of truth. If I type something here, look at that, everything is working. Despite the fact that we no longer have the state for the search field in here or the method. Instead, everything is going through Redux. And just to test that theory, if I go in here into my set search field, and instead of having these automatic return, I'm going to say console.log text, and I'm going to return from here the object. So we're just going to console log to see if the action is coming through. I save and go back. Let's open up the console, and look at that. Everything I type is being sent through the action. And another cool part is if I go to the reducer, and again, I test everything out and I say console.log.action.type. I save this and go back. We see that we have a little funny action that happens, and this is the default when Redux initiates. But now if I click on anything or type something, I get change search field, because the reducer on every action gets run and says, did change search field action happen? If that's the case, I'm going to return a new state. Very cool. We've just connected our React app to Redux, and everything works nicely. There's a bit of boilerplate here, and you have to remember map state to props, map dispatch to props. But once you get used to that syntax, it's really, really nice and beautiful the way Redux works and how we've cleaned up everything, where everything flows nicely. Just like we mentioned, we've created an action that gets dispatched into a reducer, a function that based on that action takes the state and changes it in the store. And because the store got updated, React components that are interested are going to listen to those changes and make a view change. Very cool. All right, some more exciting stuff coming up in the next video. I'll see you in that one. Bye-bye. Hey, you're still around. Good to see you again. All right, so we just console logged these action types and also did that. Where did we do that? We also did that in the action part as well. But, this is nice to see, but we don't want to console log everywhere in our Redux app for all of our actions. So let's remove this and go back to the way we had things. Let me save that. And also in the reducer, remove our console log. Now, wouldn't it be cool if there was a way for us to come back to our app and still monitor our actions and debug our applications by just seeing, which action got triggered, which reducer got triggered? Luckily for us, there's a way to do that. Now, I'm going to show you how it is, but first I have to admit something. I may have lied a little bit to you. You see, there's actually another part to this diagram that I showed you. And that's something called middleware. And don't get scared. It's quite simple and works similarly to how middleware in Express.js works. It simply listens for actions, and it's a tunnel that actions go through. And depending on what the middleware is, it can modify the action or trigger another action. So they're like triggers that actions go through and something happens within this blue box before it hits the reducer. So why might that be useful for us? I'm going to show you one thing that it's really, really great for. If we go back to index.js file, we can install something that is a middleware, and it's called Redux Logger. So let's do that. NPM install Redux Logger. All right, perfect. And the way we use this logger, which helps with logging in the console so that we can debug our app really easily, we can just, in here, import something called create logger that comes from the package we just installed, which is the Redux Logger package. And it's very, very simple to use. All we need to do is say const logger equals to create logger. And now that we have this logger function, which is a middleware, we can apply that to our Redux app. And the way we do that is through the Redux package that comes with something called apply middleware. And the apply middleware says, hey, we want to apply some middleware to this flow that we have going on. So we can simply, in the create store function, have a second parameter that says apply middleware and give it whatever middleware we're interested in. In our case, it's the logger. So let's save that. I'm going to npm start here. Oh, and the way we create the logger, because this is a function, we need to run the function. Let's save. Go back. We have no console log errors. But now, if I type something into the box, you see that? I just typed L, and the logger, the middleware, caught my action and said, on top of this action that is going to go into the reducer, I want you to also console log this. And that's the action. So I get previous state, search field was blank, and then the action that we took was change search field with the payload of L. And the next state was search field with an L. How cool is that? We have instant logging in our application. And this logger helps us work with our code better. Here's the exciting part about this. Because right now, it's hard to really say why this is useful other than just getting some logging. But the beauty with Redux is the fact that it made it so simple for you to reason about your app and monitor what your app is going through. You see, now we have a clean system for us to monitor each one of our actions, so that no matter how many actions we have, we can always predict what they're going to do. We can listen to what logging output each one of these actions happened. Because reducer is a pure function, we always know it's going to return the same state. And again, because of the way React works, we also know that as soon as the state changes, it's going to make the predictable changes to our view. And with the middleware, we're able to log these actions. And theoretically, we can even go back in time and play out different actions that our users played. Because we have a list, a chronological list of all these actions now. This is why I like teaching Redux. It's not because the library will be around for all eternity. No, it'll most likely get replaced by something new, by other tools and libraries. But it's a really important library that changes the way we think about building applications. Instead of just having messy actions everywhere and just thinking of code as something that we just keep tacking on and keep building upon and keep adding different features to, Redux makes you think in a way of, hey, how can I make an app that is able to scale in a way where we have thousands of user interactions, millions of user interactions? How can we make it so that the information flows from one to another into a predictable view, into a system that is predictable? And as a senior developer, you really want to think about this. How are you building systems that work really, really well together and are logical and flow nicely? And that's why Redux got its inspiration from database design, because databases are similar, right? They are always constantly acted upon. There's reads, there's writes, and they need a way to make sure that they manage all these people dipping their hands in the database and doing things, but also avoiding bugs and errors and all these things at the same time. This is a bit of a side note, but I think it's important to understand this. And this is a good way to think about things in flow diagrams, how data flows through your app and how you should structure your app so data flows smoothly. Finally, I want to show you another tool. I like the Redux logger because it's simple, but Redux DevTools is really, really good. And it uses this idea of middleware to listen in on actions and log out for you a ton of interesting things. You can even play back histories and what you did in the app. It's a really, really good tool that you can play around with. For now, we've learned about middleware, we've created our store, and we have a complete picture. Or do we? There's another part of our app that we need to turn into Redux. So, with that said, I'll see you in the next one. Bye-bye. Welcome back. There's one final piece of the puzzle that we need with Redux, and something that we've been avoiding up until this point. You see, if we go to app.js, you remember that we do this component did mount fetch request. We have an asynchronous request. We're making a request to an API, grabbing their users, and then finally setting that state to robots. But how would that work in Redux? Because remember, up until this point, everything we've done has been synchronous. Because if we do the same thing like we did with the search field, it wouldn't work with fetching robots, because we're sending an action of, let's say, fetching robots, but because that's asynchronous, it's going to go off in another world into the API and try and get the robots. In the meantime, the reducer is just going to check the robots and say, there's no robots yet because in API land, that hasn't returned yet, just like a promise. So the reducer keeps going and doesn't make any changes because the state hasn't changed. So how can we create actions that are asynchronous that still go through the reducer, the store, and then make changes? And this is where we use apply middleware again. We can use something called Redux Thunk to handle asynchronous actions like AJAX calls. It's a middleware that provides a getState and dispatch function that are passed on. You're able to handle something called side effects like AJAX calls with this package. So we're going to show you how that works. First thing we want to do is install the package Redux Thunk. So I'm going to say npm install Redux Thunk. And by the way, just like with anything, there's tons of other ways to handle asynchronous action in Redux. It's just not built out of the gate, so you need some packages. There's other options, but Redux Thunk is the best and simplest to start off with. All right, we have Redux Thunk now, and we can simply start using it by going to index.js. And within here, we can say that we want to import something called Thunk middleware from Redux Thunk. Again, you can read all about this in their documentation on GitHub. Thunk middleware, we already know how to apply middleware to our Redux app, right? We have our apply middleware function. We can simply add the the Thunk middleware. And let me just put this on a new line so you can see it better. Thunk middleware to our apply middleware. And this is ordered, so it's going to go through the Thunk middleware and then the logger middleware. Perfect. So let's run npm start. And I'm also going to save this. All right, looks like everything is running smoothly. We have this middleware implemented now, but how do we actually use it? Well, let's start with the very first steps. the first thing we want to do is create a constant. So a constant for requesting our robots. Remember, in the app.js file, we have this robots array that gets populated after a component did mount after we do the fetch call. And we set state with the new users. So in the constant, we can do something similar to above. We can export const request robots. Now, because this is going to be a promise, it's going to have 3 states. So the first one is going to be pending, which is the very first time that we send that request. It's going to be pending. We're waiting for the promise to return. So we'll, again, use the same string here. And we're also going to have 2 states after the pending returns, which is success and also failed. This request has 3 actions: pending, success, failed, that we want to keep track of. And again, this is pretty much standard with all asynchronous actions like AJAX calls. So let's save that. And the next step, as we know, is to create the actions using these things. So let's go back to actions. And this time, instead of just importing change search field, let's import a few more things. I'm going to import, let's just copy and paste here because that's a lot of typing. Let's go to constants. We're going to import pending, success, and then finally failed. Let's save. And we just get a warning that we're not using them. So let's create these actions now. Just like we did above, we're going to export const, and we'll name this request robots. And this action takes, what's it going to take? Well, this is a little tricky, but it's going to take the dispatch. And dispatch, if you remember, and we go to app.js, is something that we use in map dispatch to props that we get from Redux to dispatch the actions to the reducer. And when we come back here, you'll see that we're going to actually pass this to our action, so we have access to it. But again, for now, just know that we're going to have dispatch. And within here, we're going to do a few things that's a little bit different than the above. The very first thing when we request robots, well, we want to dispatch the pending action. So again, we can just do the standard syntax of dispatching an object that is of type request robots pending. And the payload, well, there's no real payload. We just have a request pending. So we can just leave it the way it is right now without a payload. Next, we have something that is asynchronous. We need to do a fetch call. So we have our fetch function. And if you remember, we go to app.js. We have this API that we need to call. But we also need to do the response.json all over again. So I'm just going to copy all of that, go to actions, and just copy and paste this. So we're fetching the users. We're doing the .then, and JSON using the JSON method on the response. And then finally, in here, we have two options. We have the .then and .catch in case there's an error or something fails. In the .then, we receive some sort of data, which will be users. And once we've received that, we can say dispatch. We're going to dispatch. What do you think we're going to dispatch? Well, the object that is of type request robot success. And this time, the payload for this is going to be the data that we receive from the API. And with the catch, very similar, we'll get some sort of an error. And this error is going to, once again, dispatch. And it'll have a type of requests robots failed with a payload of, let's give it the error that we receive. All right, let me make this a little smaller so you can see.